Morning, everyone. I hope I am audible. Hello.
Good morning, sir. Yes.
Yeah, very good morning. Okay, we'll wait for 2-3 minutes. Okay, because it's 10:26. Okay, so we'll wait. We'll start sharp at 10:30. Okay, I welcome you, uh, Arunjit Chaudhary, sir, who is the speaker for today's session. Very good morning, sir. How are you?
Good morning to all.
So, very good morning to one and all present here. Today we have with us Mr. Arunjit Chaudhary, who is the CEO for Enterprise Building Training Solutions, and he has a vast, I should say, very rich experience of 25 working in IT industry for tier 1 clients across US, Europe, and Asia Pacific. Okay, and apart from that, he is certified in sales and distribution module with SAP and certified Scrum Master from Scrum Alliance. Apart from all this, that is professional experience, he is passionate about teaching. So have passion for teaching and have taught students across 14 colleges in Mumbai area, right, of SAP and machine learning. So with this brief introduction, I welcome you, sir, Mr. Arunjit Chaudhary, and I hand over the proceeding to you for today. He will be talking on how we can go for machine learning using Python. So very good morning, sir, and I hand over the proceeding to you now. Welcome. I hope I am audible. I don't know.
Yes, sir, you are audible, sir. I think
Am I audible?
Yes, sir. You are
Yes,
audible.
sir.
You are audible.
Great. Okay. So good morning to one and all, and I hope you guys will have a lovely session today. And I would like to make this session as interactive as possible. So the more I hear from you will be good, so that we get engaged more into a discussion rather than into a monologue presentation, right? And so my today's theme is going to be on obviously the theme of this particular FDP is advancement in machine learning in artificial intelligence, and I'll be specifically talking about machine learning, and also showing some of the scripts executing in Python, which is one of the most popular platforms today, where you execute a lot of Python scripts with various data sets. And so I hope you guys are all safe in the current pandemic situation. I know the situations are pretty challenging, but obviously, as we always say, in spite of the situation, we have to continuously learn, right? Learning doesn't stop. And that's where I think it's very important that I will try to impart whatever little knowledge I have in part of machine learning is concerned. And I would like to also hear from all of you, your perspectives, so that we make it a more engaging and interactive session, right? Okay, so let me just share my screen. Is my screen visible? Are you able to see my presentation?
Yes, yes.
Yes, sir.
Yes, sir.
Okay, very good. Let me. So I got 2 hours with me, and in this 2 hours, I'm going to touch upon some of the machine learning concepts, because I think understanding the concept is very, very important. And once you know these concepts, then running any machine learning algorithm becomes very easy. I'll be focusing on supervised learning, whereby I will execute some scripts on regression, polynomial regression, and if time permits, logistic regression at least I'll cover. And if time permits, I will certainly cover decision trees and random forest. And if there's any questions, please chat or you can unmute. I'll be happy to answer. Don't wait for me. Don't wait till the end of the session. As and when you've come out with some questions, please raise your hand, or and you can raise and you can ask a question. Okay. So while a lot of us know what is AI, I mean, I'm not going to discuss into what is artificial intelligence. Can somebody tell me briefly as to what is machine learning, by the way? Anybody, please. And I have a habit of writing a lot of notes in a notepad. So typically I will write here and any points, and then, so that we capture all the points, whatever is getting discussed. Okay. So anybody can tell me what is machine learning?
Sir, can I?
Sure, please.
Yeah.
And my small request to you, please tell your name before you answer, so that I know who is speaking. Is that okay?
My name is Rajesh More.
Yes, Rajesh. Yeah.
I'm from Mumbai. And
Okay.
the basic definition of artificial intelligence, which I understood, to train our machine for particular task by generating certain program or by using certain data.
Okay.
Yeah.
Okay. So you're talking about, you just talk about the definition of AI or machine learning?
AI. I'm talking about AI.
AI. Okay.
Yeah.
So I would like to go specifically to machine learning, because I think AI, a lot of people know the definition, but I would like, because the topic is more on machine learning, I would like to really focus on machine learning and what is one's interpretation of machine learning and why is it become so popular?
Good morning, sir. Ranjit is here.
Yeah.
With the help of algorithms and the programs, the ability of our machine to mimic the human being, making machine to mimic the human being
Okay.
through program and algorithms.
Okay. Fine. Any other definition?
Good morning, sir. Am I audible?
Yes. Your name, please.
I'm Rachna this side.
Yeah, Rachna.
According to what I have learned till now, machine learning is
Mhm.
basically a process where a machine learns from the given set of inputs and outputs, and on the basis of those outputs, the machine tries to give us as accurate as possible the output for another set of inputs. So it is learning by itself from the set of inputs and outputs, and it is giving us the results which are based on new set of inputs.
Okay, good. Okay. Anybody else wants to try?
Good morning, sir. Am I audible to you?
Yes.
So my name is Mangala Madankar, and as far as the definition of machine learning, so we are giving the training to the machine
Mhm.
related to the particular data. We are training the machine on the by giving the large number of inputs, so that in a machine learning the things will produce the algorithm, and whenever then we are giving the input, then that input is on the basis of training data. Machine understands what is the input, what we have to process that, and on the basis of training data, it will test the input and giving the output.
Okay. Okay. Fine. I think many of you have given the, at least in the right direction in terms of what machine learning is about.
Excuse me,
Yes.
sir. Can I?
Sure. Sure. No problem. Please go ahead.
Good morning, sir. This is Anuja Vakari from Pune. So, as per my understanding and the knowledge gained from last 3 days from the ability, machine learning is a kind of method which actually a subset of artificial intelligence. It's a method of doing the data analysis, which automates the analytical model building, and it helps to identify the patterns and helps in making decision where minimal human intervention is required.
Okay. Fine. I think that's also a good definition. So the way I will put it, okay, and first of all, for machine learning, the one of the most important things is you need to have data, right? And this data could be structured data, or it could be unstructured data like images or whatever it is. And the important here is that you want the machine to derive a pattern out of the data. Very important, right? So you want to derive a pattern out of the data, okay, by feeding this data into a machine, or you can also call it a model or whatever. The machine will basically learn through experience. These are some of the important words we should all know, right? Learning through experience. Okay. Please forgive my spellings and all that. Okay. So once the machine learns through experience, the machine is able to predict the output, or you can also call the outcome, which is aligned to the input data. Okay. Which means that if I have some data, the machine should be able to derive a pattern as it learns through experience. And based on the pattern the machine has identified, for any new set of input data, it should be able to predict the output, which should be aligned to the input data. Okay. Obviously, the machine will take the place of a human being and will try to derive a pattern and should be able to predict the data based on the prediction it has done from the training data, which it has, which the data which has gone to the machine, and the machine has learned and tried to derive a pattern through experience, right? So whenever we talk of machine learning, it's all about data, it's all about pattern, it's all about learning through experience and predicting an output which is aligned or in line with the input data, right? Can somebody give me some live day-to-day applications of machine learning? Yeah. Any day-to-day applications which is witness in your day-to-day life?
Nowadays, just there is the prediction of the third wave on the basis of the earlier data.
Prediction of the third wave based on the earlier data. Okay, fine. That's more of a pharmaceutical sort of a thing, because you have a lot of mutations happening in viruses, which is happening, which is creating all these lambdas and betas and whatever.
Yes,
Okay,
yes.
fine. What else?
Basically used in traffic signals to identify the number plates or that's that.
In traffic signals. Okay, so what part of artificial machine learning can you tell me all this about?
Pattern, number plate recognition in the sense it is unstructured image with unstructured data, because the number plates, the fonts are all different sizes. It is not okay. Image recognition, right?
Image recognition. So I don't know if you have heard what with us called something called a convolutionary neural networks.
Yes. May I say something, sir?
Please go ahead. Yeah, please
Yes.
go ahead.
Yes. Myself, Dr. Aradhana Deshmukh from Pune, Sinhagad Institute. I like to add here that it is not only with image processing or image recognition, but if we go into depth, nowadays, since last 1 year, all the researchers are mainly concentrated on health science. So obviously the brain images, X-ray images, as well as ultrasound images for the patient. So such kind of data are mainly recognized, categorized, analyzed by this machine learning. I hope, am I right?
Yes, so what you're saying is prediction of a disease or prediction
Yes.
of a particular prescription or whatever based on a symptom, okay,
Yeah.
or based on some diagnosis. The application will be able to tell you or predict you the disease that you're likely to suffer from, right?
Yeah, like Arogya Setu and some dashboards are readily available for the common man.
Okay. So essentially, healthcare is becoming very important, because today, if you see, there's a lot of startup companies whereby if I go to a doctor, you'll be having a doctor who is having a particular tool already with him, which will help him to predict what could be the likely disease the person could be suffering based on the symptoms. Because all this data has already been captured. Okay, a lot of patient data is being captured in the machines, and the machine has basically would derive some patterns, and based on your symptoms the machine can intelligently tell you this is the likely disease or this is the likely diagnosis you have to do. Okay, so so there's again a lot of healthcare related advancement which has happened in machine learning. For example, another classical case is that using machines I can detect whether a person is having a malignant cancer or is having a benign cancer, right? Again, that is happening because of machine learning algorithms which help to detect some patterns out of the various data, which is instrumental to decide whether a particular cancer is tumorous or it is benign. Okay, fine. So health science is one. What else?
Banking sector, sir. In banking
And
sector,
natural disaster, that
in
is
banking
the
sector, we can use, yeah,
we can say the weather forecasting.
to detect the frauds, something in banking.
Yes, so let's go one by one. So I think let's come to banking. So banking, one of the various very important application of banking is customer churning. Today, as a banker, I need to see how I can prevent customer from leaving my bank, right? So customer churning rate is something which as a banker I need to prevent or I need to reduce. So based on the behavior of the data, like depending on the customer, the credit card he holds, the amount of savings account and all that, based on the data, I can derive a pattern whether the person is likely to leave my bank or not leave my bank. Okay. And depending on that, I can come out with some offers to that particular banker, to the particular customer, which will help me to ensure as a banker that he doesn't leave the bank. Okay, that is one important thing. So that is then fraud detection. Absolutely.
Fraud.
Today, Fraud detection is also becoming very important. Today, I can identify a transaction through a machine learning algorithm, whether that particular transaction is a authentic transaction or it's a fraud transactions. And based on which I can, if there's any new transaction which is coming in, the machine can detect automatically whether it's a fraud on this, and it can take corrective actions. Okay. So again, that becomes in banking sector. Then somebody talked about the weather forecasting, right? So based on your past weather, you can sort of do a time series analysis based on your future. What is the prediction of weather, which you can do again based on past data. Okay, and that again becomes some sort of a machine learning sort of algorithm, right? Okay, some other examples.
Customer care,
E-commerce
sir?
and stock markets.
Customer care application.
E-commerce and stock markets.
Customer care applications, for example.
Sir, in case of Mac computers, Mac laptops, yeah, Mac systems, they providing one certain window. Directly you can talk, you can ask your question, and there's answer automatically from other side. So
That's called a chatbot.
yeah, that is the application. I thought that is the application of this machine learning.
Yes. So chatbot is an application of machine learning where if you go to any website and they ask, and they will say, okay, can I help you? So those series of question and answers, they are all again built through machine learning algorithms. So the machine has been trained to ask and and basically based on your responses, it will come out with this next set of questions it will ask, right? And so that is again an example of a chatbot. That's what you're talking about.
Yeah.
Another important example which is product recommendation. You go to a Flipkart site or you go to Netflix where you have movie recommendations. So all these recommendations that movie recommendation with Netflix gives or product recommendation with Flipkart or Amazon gives, these are all coming through machine learning algorithms, because first of all, it knows what is the past data you have, whatever you bought in the past, whatever movies you bought in the past. And importantly, based on your profile, it also tries to find out what similar profile people who are there, who are into this, who are already entered into this site, and what sort of products or movies they're buying. So based on that, so there's a recommender engine. It is also called in machine learning terms, learning association. Okay, learning association, right? So this helps in basically, so this movie recommendation, product recommendation, these are all examples of machine learning, right? Then you talk about LinkedIn, or you talk about LinkedIn, where there are some jobs recommended based on your profile. Okay, so that is again using machine learning algorithms. Then you have
driverless car, that is also one.
Yes, self-driving cars.
Self-driving, yeah.
Yeah, self-driving cars also works through a concept. It's called a concept called reinforcement learning. I'll come to that. But again, self-driving cars is again, or even robotics, right? All these are examples of machine learning. Okay, and then the Google search, basic Google search is again using machine learning. Yes, Alexa. So all Google Echo. So then machine translators, anything to do with machine translations. Okay, NLPs, you have natural language processing. These are all basically using machine learning algorithms. Okay, so these are some of these day-to-day examples of machine learning, which we obviously come across. And there's a lot of work which is happening, not in banking, but in manufacturing, where you can do some defect detection in any product based on the image you capture. The machine should be able to tell you whether this is an actual defect or not, right? So again, lot of work is happening across various industries, right? Okay, so you have now got a fair idea of what is machine learning. And okay, now let us go to some machine learning types, right? And this is where probably I will spend some time. I mean, I'm sure many of you may be aware, but I think this is the concept is very important. So somebody can tell me what is a supervised model? What do you mean by supervised model?
in which data is already known and it is well organized.
Okay, so
Where we
data
give
is already
training to the
known.
data.
Data is already known means, what do you mean by that? Can you be a
May I,
little more
sir?
elaborate? Yeah, please.
So basically, when we know that for a particular input, we have these particular outputs. So we train the data accordingly, and then whatever input we give, it acts according to the training that's supervised.
Okay, anybody else can?
The data which we already available, so we can
Yes.
segregate that data properly in a specific manner. So that we can and we can arrange that particular data into the specific manner. So that is a supervised. We can label that data properly as per our requirement. That we can
So
call it
the
a
way,
labeled.
yeah, labeled. I think we use a lot of words like labeled data and all that. The most important thing you should know in a supervised model, the pattern of the data is already known in advance.
Yeah, that is a pattern is already known. Means you can segregate properly as per the pattern.
Yeah, so the pattern is already known in advance. Okay. For example, when I'm talking about now, if I have a very simple equation is y equal to m1 x1 plus m2 x2 and so on. Okay, what is this equation called?
Linear equation, sir.
Line equation.
Linear equation.
Linear equation.
Yeah, linear equation. But if you remember in algebra, when we had learned in our younger days, we used to call it regression. Okay, this is a linear regression. Okay, and if you see here y equal to m1 x plus m2 x2, if you what is this line? I mean, if I want to show this in a line, so what is this? So what is this pattern? How does it? How you want to? How will you depict this in a graph? So if you have y equal to m1 x1 and m1 x2, suppose you have got 3-dimensional thing, or let's make it more simple. Okay, let's not get into 2-dimensional. Let's say a simple example. So y equal to m1 x1. So what is the pattern of this data?
Your data is gradually increasing. C is constant here in this case, and your data.
Straight line with some
It's a straight line. Perfect. So this is a straight line, right? If I have to draw y and x, it's a straight line. So I know the pattern out of the data, right? It's going to be a straight line. Okay. Or if I say y equal to m1x plus m2 x square, this is not x2 x square, just for simplicity, m3 x cube, and so on. So what will be this pattern? Just an example. Can anybody think about it?
Quadratic equation relatively occur.
The slope of line is gradually increasing.
No. So this is m1x plus m2x square plus m3x cube plus x raised to 4 and so on.
It's a non-linear curve, sir. Curve shape.
Yeah, this is a non-linear sort of you will see a parabolic curve if you want to draw this equation, right? Now again, here the pattern is known. You know that this is going to be a curve, this is going to be a straight line, and so on, right? Now in machine learning terms, what is x called?
Input.
X is called input. Okay, what else? What is x referred to in machine learning parlance?
Independent variable.
It is called independent variable. What else? Any other name?
Input parameters.
Input we have already given here. Input. Okay. Parameters. We also call it an independent variable. We also call it a feature. Okay. Or we also call what is called a predictor in machine learning terms. If you anyway come across such terms like features, predictors, these are all your independent variables, right? And then what is y? So y could be your output. What else it is called?
Target variable. Output variable.
What else?
Your dependent variable.
Dependent variable. Dependent on variable. Okay. So in the equation of y equal to mx plus c, what is y? Is it a discrete variable? It is a continuous variable. What is it?
Sir, if it is a classification problem, it will be a
No,
categorical value.
I'm talking of regression now. I'm not
A
jumping.
regression, it will be a
We'll come to
continuous.
Perfect.
Continuous.
Correct. Yeah. Very good. Very good. We'll come to classification later. Very good. So y is basically called a continuous variable because y is changing as x changes, right? Okay. And in typically what happens is in a standard, if this is a univariate regression because there is a single independent variable. This is a multivariate regression. Can somebody give an example of a multivariate regression? Can somebody give me an example of a multivariate regression? A live example?
Sir, diabetic patient.
For example, when you say diabetic patient, what is X1, X2, X3?
So in that case, we need to check blood pressure, glucose parameters.
Okay.
And hemoglobin of that particular patient that we can check. So 3-4 parameters.
Yeah, but that you're saying whether a person is diabetic or not.
Yeah.
But is that a regression?
No.
That's not right because your regression, your value is not going to be fixed.
The share market stock prices prediction will continuously change depending upon various parameters, and we'll get different values.
Yeah, so you could have various parameters on the stock market. Could be your market capitalization, could be your profit of the company or the balance sheet, whatever. Okay, the assets. So this could be the various
house price prediction also.
Very good. So house prediction also could depend on, for example, the square feet of the house or the floor or the proximity to maybe the railway station or mall. So all those are the features which decides the price of the house, which is your dependent variable y. Okay, so that's an example of a regression, multivariate regression. Okay.
Variable company production output.
Variable?
A variation in the company product, output product. Production, variation in the production.
Correct. So variation of production output could depend on various factors, could be your capacity, could be your constraints, whatever. Okay, the various features could be there. So that is also an example of a regression. And what is classification?
The categorical data is there, and we get output also in the form of either 1 or 0, 2 or true or false, like 2 categories, 2 classes.
Okay. So here the output is discrete.
Discrete.
Correct?
Yes.
Or it is a labeled data having fixed set of values. It could be yes or no, or it could be a person, or it could be maybe if it's an image, it could be basically whether it's a dog or a cat, or just to do a facial detection, whether it's a face or whether it's a cheek or whatever, right? So all those are examples where the output has got a discrete set of values, as against in the case of regression where you have a continuous set of values, right? That is one of the main differences between classification and regression, right? Okay, so classification, we say that the output is discrete, and this. Now, what about unsupervised model?
Output can be binary also, sir, in case of classification.
Yeah, absolutely. It could be 0, 1, whatever it is. Yeah, it could be any, but it has discrete set of values. It will not change. It will have only those range of values. Okay. What about unsupervised model?
Data is unlabeled there. Based on the structure, we can use clustering there, and clusters can be formed for classification. But data is unlabeled there.
Could you give me an example of clustering?
Okay, algorithm or a real-time example?
No, real-time example. You're right. I mean, clustering is one of the aspects of unsupervised model, but I'm just trying to visualize a real-life example where you're going to use clustering.
So, for example, customer segmentation, if you want to do market analysis.
Correct. So that's one of the good examples. For example, I always give an example of a mall. In a mall, you have a customer where you have his salary and his spending power. Spending power in the sense, higher the spending power means he's more likely to spend on products. Less the spending power is less likely to spend, right? Now, if I were to capture the salary and spending power of a particular set of customers who are coming to the mall, and the mall has to strategize as to what sort of action I need to take depending on the different categories of customers. So I segment these customers or I group these customers based on the combination of salary and spending power. So if I have a person with a high salary and a high spending power, that could be one cluster or one group of people, or once a high salary and low spending power, that could be another cluster of people. Similarly, that could be low salary, low spending power, another cluster of people. So I cluster them based on, so I create clusters or groups based on common behavior or common attributes. And the idea here is that if I'm a mall, if I've seen that a person is spending a high spending power and is also having a high salary, what sort of campaigns I should do? Or if a person is having a high salary but a low spending power, that means that he is not spending that much. What should I do to entice his spending or to increase his spending power? So I need to come out maybe some promotional offers. I need to come out with some 1+1 or something like that, some free promotional offers, so that I can attract him to buy more of my products, right? So these are all these are all the things which we cover as part of unsupervised learning. I talked to you about the movie recommendations. I talked to you about the product recommendations, which is part of learning association, right? That is also an example of an unsupervised model, because the algorithm will try to dig out the hidden patterns out of the data, and based on the cluster you define, it will group the segments, it will group into that particular set of clusters, into basically each cluster representing a common set of attributes. Okay, so that's how basically you have an unsupervised model. So you have, as I said, one is clustering and the second is a learning association, which we talked about the movie recommendations, for example, right? Now, I want to explain you one thing. How can anybody tell me how a machine learning algorithm works? Anybody has gone through any machine learning algorithm? And how is the, how does it work? Let's take an example. I am the HR of a company and I have a very simple example. I've got a years of experience and the salary of my employees, right? Now I've got thousands of such records. Okay. And if I, as a customer, that means I, the HR, I approach you as a data scientist, and I am telling you that, okay, you please come out with a model which will represent this data. And basically you can recommend me a model so that that model will actually simulate my actual data, which is my years of experience and salary. If that be the case, how do you think a machine learning algorithm will work? Anybody has any idea? Suppose I've got years of experience, one, say 10,000 rupees, two, 20,000 rupees, 3 years of experience, 30,000 is my salary, and so on, right? And this goes up to 60 years. I'm presuming that we working till 60, which could be whatever, 1 million or 10 lakhs, whatever is your salary. Now, if I were to come out with a model, how will it work? Anybody has any clue? You can share whatever experience you have if you have gone through any machine learning algorithm.
Using a decision tool.
No, let's not get into a specific decision tree or any algorithm. I want to understand the flow. Does anybody know how the flow happens? See, once you understand this flow, right, it becomes very easy to you to appreciate any type of algorithm, whether it's decision tree, random forest, it doesn't matter. Okay, these are the various algorithms which are available, but the flow of the machine learning algorithm, how it works, can anybody throw some light? Okay, let me, yeah, please.
Sir, I think in machine learning, input and output is already well defined. So, as contrast to conventional programming, the result of machine learning is a program. Whereas in conventional programming, we give the input data and we create program and we get some output. So this is exactly reverse. We are providing already the output target is defined. So we give the well-defined target is given as input to the model. Input and output are given, and we get a program as a result. A complete model program we get as a result. This is, I think, this is a basic difference between conventional programming and machine learning.
Okay, the other question is not to basically find the difference. I'm just trying to understand the flow, how a machine learning algorithm works, right? Now, typically, I assume that I have got millions of, say, 1,000 records. I'm just, for simplicity, I've got 1,000 records of this data from an HR company. And as a data scientist, I need to come out with a model, right? So first and foremost things I need to do is I need to do some data pre-processing. What is this data pre-processing? I could have a situation where my data is some data is missing. I could have some amount of outliers in my data. Anybody knows what is an outlier? Anybody knows what is outlier?
The noise.
Yeah, give me an example in this example. Give me an example here.
So if a data contains some unwanted data, which we call it as noise, that can be considered as one of the outliers, unwanted data which is not
So
required.
in this specific example, what could be one of the outliers?
It depends on the data set.
Yeah, just guess. See, for example, if I have a data which it says 90 years of age, okay, and it says, okay, maybe their salary is some whatever X amount. I mean, that's an outlier, right? I mean, practically you cannot have anybody who's got 90 years of age because it's outside your normal range of maybe 30 or 40 years of experience, right? Maximum that much you may have. So you have outliers. So identification of outliers is very important. If there are some missing data, or if there is some data which is not clean, which you're not able to make out because it's some junk data, for example, right? So you need to clear this, you need to take care of this data, right? So you need to clean the junk data, right? Now these form what is called part of a data preparation phase. In any project lifecycle of machine learning, first and most important is obviously you need to have somebody who understands the data. He has to be a domain expert, right? I mean, obviously, if I'm a healthcare guy, I need to be somebody from the healthcare who understands the data, right? And secondly, as part of data preparation, I need to ensure my data is totally cleaned before I feed into a model. If my data is not clean, I will not get proper output. It will give me some incorrect patterns, and obviously the very purpose of a machine learning model is defeated. Okay, so most important thing is you need to ensure my data is clean, the data is well processed, and I get what is called a processed data. Okay, so I get what is called a processed data. Now what I do is I then split my data into a training set and test set. Can anybody tell me why this is done? Why do you split the data into training and test set?
So for validation.
What validation?
Validation and test. Predicting the new data. We keep some data for testing purpose because whether our model is working properly or not, we need some new data. So first we will test on the portion of the data which we have kept as for the testing purpose. Whether the model is working or not for testing purpose, we want to test on new data. So before deploying it actual on the we separate our training data into two parts, training and testing.
Fine. So you have some test data which you will use to predict the efficiency of the model, right? Okay. So what I will do is typically in my industry, the ratio typically is minimum 70 to 30. At least 70% should be training set and test set could be 30%. I mean, your training set could be even 80, 90%, depending on the volume of the records, depending on the experience. But typically you will have a ratio of at least 70 to 30 for training to test set. Okay. So assuming that you have got 700 records of training set and 300 records of test set out of 1000. Okay. Now what I'm doing is I will take these 700 records. Now, before I feed into the model, I need to first identify which is the independent variable and which is the dependent variable. Typically in industry, we use Y and X. Okay, X is your independent variable and Y is your dependent variable. And obviously you could have n number of independent variables, but you'll have only one dependent variable. Okay, so Y will be always single, but X could be multiple. Now what I do is I take Y and X, I feed into the machine, and then the machine will derive a pattern. Okay, and I have a model created. So what I've done, I've taken the 700 records of my training set. I feed my independent and dependent variable into my machine model. The machine gets trained based on the 700 records and tries to come out with some pattern. Okay. Now, once the pattern is this, so what is the next step? Can anybody guess? What will I do with after I train the model? What do I do now?
Check the accuracy of the output.
How will you do that?
Based on the scores that is obtained.
Sorry, based on
the scores that we get, the predicted scores.
No, see these 700 records, the machine has come out with some pattern, right? Based on these years of experience, this is the salary. Based on these years of experience, this is the salary. Now to test the data with the 300 records, what do you do? What do you feed into the model?
Sir, after the model is ready, the portion of the data which we call it as the testing data, which we have kept it initially separately, we will provide that data as input.
So which data? So which of that? Correct, you're in the right direction. But out of the test data, which data you will feed into the model?
The X portion of it, X variable, not the target variable, and we'll find the Y, sir. The X text will be given as input for predicting, sir.
So you
initially we use the X train part. First we model using the X train portion of the data, and while testing we provide the X test portion of the data for testing our model how it is performed.
Very good, very good. Your good name?
Sir, I'm Dr. Sharda Chabaria.
Yeah, Sharda, good. So what we are doing is that this concept is very, very important. So you take the independent variable of the test data, you feed into the model, and the model will give you a predicted output. And then I will compare the predicted output with the actual test data. Actual salary. Salary is my dependent variable. So I will do Y test. I will compare Y test with Y pred. This is how we give a naming convention, Y pred, Y predicted. So I compare Y pred with the Y test. And if my Y pred and Y test are aligned, or I can get an efficiency of at least 95%. Now, how the efficiency is calculated, I'll come to that, which means that my model is, I can recommend this model to my client saying that this is the model which you can use for predicting your new set of data, and it will give you a very likely accurate outcome or a prediction of the output value. Okay. So this is typically a flow you need to understand. If you understand this flow, any algorithm you run is just a question of what class you're going to use, whether you are going to use a linear regression or you're going to use decision tree, random forest. It's just a different algorithm you use. But this concept is very, very important. You should understand.
Sir,
Yeah.
sorry to interrupt. Can you please explain independent variable of test data?
See, you had this 300 records, remember, test data?
Right, right.
So in your 300 test records, you had years of experience and salary.
Yes.
So which is your independent variable?
These two.
No, both are not, right? Which of the two is the independent variable? Years of experience is
This is what
independent
I
or the
have.
salary is independent? Is salary depend on years of experience or years of experience depend on salary?
All right. So years of experience is independent.
Correct. So your years of experience is independent and your salary is dependent.
Okay.
So what I will do is I will feed my years of experience of the test data in from the 300 records. I will feed that into the model, and then I will get a predicted
And salary
salary
will
of
be
the 300
predicted.
records.
Okay. All right, sir.
And then I will compare the predicted output of that salary, which is coming out of the model, with the actual test data of these 300 records. This 300 records. This is the one. I will compare it with
All
this.
right, sir.
And then this will tell you my efficiency of the model.
Okay. Thank you, sir.
Have everybody have got this concept? Anybody has any questions on this flow?
Yes, sir. I want to ask, sir. Sir, if suppose you said ki, like if there is a small data set out of 10, I can decide ki, what are the important attributes. But if I have a very big data set consisting of 1,000, 2,000 attributes, in that, how will I decide? How will the model decide ki, which attributes are important automatically? Like as a developer, manually it's okay. I can depending upon the program statement, I can find out what are important. But how can the model takes automatically which attributes are important in a very big data set?
So does anybody know the concept of backward elimination?
I don't know.
Okay, so we'll come to that. So I think let's do one thing. I will. So you got this concept of workflow clear, right? This workflow, is it clear? Anybody has any questions before I jump into a particular script in regression? I'll come to a regression model. I'll show you in Python. Any questions? Or can I get anybody if okay, so if there's no questions, let me go ahead. So what I'm going to do here is that this is Python Spider. I think all of you can see this. Okay, and what I'm going to do is I'm going to open a regression. Let me first open a simple linear regression, right? Okay. And here, this is my script. Let me close this. Now, there are some of the things Okay, let me just open here. This is my salary data. This is my data set. Okay. It's a very simple example where I've got the years of experience and salary, which I've already explained to you. I've explained you the workflow. Now I want to show it to you how this is executed in Python. Okay. So what I do is there are important libraries which I have to import. Okay. I mean, many of you may be technical or non-technical. Just to give an example, there are some important libraries like NumPy, Matplot, Pandas. These are the very important libraries in Python which we use. For example, Python Pandas is used for manipulating the data set. So any import of the data into the program, whether it's a CSV file or Excel file, is done by Pandas. Matplotlib is basically for plotting any graph, and NumPy is for doing any numeric calculations, right? So these are the very important libraries in Python you use in any Python script. Okay, so typically what I will do is I will first execute. I will import the library. So whatever I do on the left hand side, when I execute that command, it is executed on the right side bottom, which is called the Python console. Okay, and if there is some error or anything, which will get reflected in this console. So as of now, you don't see an error, means everything is fine. I import my data set. Okay, once I import this data set and I go to my variable explorer, I can see my data set here. Okay, this is how it looks. This is my years of experience. This is my salary. Okay, and typically what happens is that this is just a small set of data, but typically when you are actually getting into an industry, you have to do some initial analysis out of the data. It is called the EDA. Anybody understands what is EDA? Anybody knows what is EDA? Am I audible, guys?
Yes, sir.
Okay. So EDA stands for exploratory data analysis, right? So typically when you have data, you have to first check out whether there is some null data, whether there is some missing data, whether there is some outliers. Okay, so there are various statistical commands which you can give, which you can find out whether what is the mean, what is the median, what is the range. Okay, there are various there is something called coefficient of variance. Okay, there are various ways to find out whether there are two independent variables are related to each other, or a dependent and independent variable are related to each other. Are they positively related or are they negatively related? When I say positively, means if x increases, y also increases in the same direction, or if it's negative, means whenever x increases, y reduces, so it's in the opposite direction. So there are ways to find out. So very important, if you want to really pursue machine learning as part of your career, you need to have a very strong fundamentals on statistics. You cannot compromise on your statistical knowledge and get into machine learning in your career. So you have to spend 2-3 months understanding the various concepts of statistics. Okay, that's very important. Okay, now what I do is I identify which is my dependent and independent variable. So obviously I know that my dependent variable, my independent variable x is my years of experience, and my dependent variable is my salary. Okay, now what I'm doing here is that I'm splitting the data into training and test set. I split it into training and test set. You're all aware. So when I typically do a split, I do it into 4 variables: X train and Y train, which are my dependent and independent variables of the training set, and X test and Y test, which is my independent and dependent variable of the test set, right? And if I have to go to my variable explorer, here I'll be able to see that out of 30 records, 10 records are test set because I've taken 30%, and 70% I've taken training set. That's why it is called 20 records for the training set, right? Once I've done that, now see what I'm doing. I'm taking the X train and Y train. That means I'm taking the full test set, training set, and I'm basically feeding this into the linear regression model or the class, where the the model will be able to derive some pattern out of this data. Okay, so now it is going through the 20 records and has come out with a pattern. And now if you remember, I talked to you, I take X test as my input to this prediction model, and I do a prediction of the salary. Okay, once I do this prediction, if I want to compare my X spread and Y spread, what I can do is what I can simply do, I take Y spread here, I take Y test. Where is Y test? Okay, Y test. And so I do some sort of a visual comparison where I can say that, okay, where my actual value was 37,731, the model predicted the value of 40,835. Similarly, if I see here, if the model was predicting, but the actual data was 60,218, my actual data was 63,264 or whatever. So in this way, I can find out visually, which is generally not their practical way, but there is one way I can compare the actual result with the predicted output. Okay. Another way of finding out this is through a graph. So what I will do is I will plot this graph of the training set. Can somebody tell me what is this blue line and what is this red line, red dots? Can somebody tell me what is the blue line and what is the red dots?
Blue line is the patterns. It is following that function.
So blue line is coming from where?
Prediction, sir.
Prediction, perfect. So this blue line is my predicted line, which is coming out of the model, and this red dots is the actual training data. So this shows how much my training data is away from this predicted line. Okay. In machine learning algorithm in regression, there is something called a cost function, or it is also called the mean square error, MSE. Okay. So how far this predicted point, that is this point in this yellow line, in this blue line, how far my actual is far away from the prediction, that is my yi minus y predict. That basically gives me the error. Okay, it is called the error. Okay, and the main objective is you have to eliminate this error, or you have to reduce the cost function. When I say cost function is yi minus y predict the whole square, sigma. If I want to have my yi and y predict close to each other, my sigma yi and y predict also has to be close to 0. Okay, and that's where I want to eliminate or reduce my cost function, or which is also called the mean square error in regression. Okay, so similarly, if I were to do this in my test data, if I take this, now see how the test data is fitting pretty well, right? This test data is fitting pretty well. If you see, these dots are the actual test data, and the blue line is the predicted line coming out of the model. Now, if I want to find out the efficiency of a regression model, I use what is called something called the R square. Okay, R square, and R square is a formula which is used in machine learning. And if you see here in R square, the parameters are the Y test, which is the actual test data, and Y pred is the predicted data which is coming out of the model. Now, if I were to take this and I can print, you see my R square is 97%. That means this is a very good model, which is this model. I mean, this linear regression model befits this data very well. Okay, so this is the way I calculate the efficiency of the model. Now, if I want to calculate how the R square is calculated, I will show you. This R square is calculated using this formula. Okay, R square is 1 minus sum of the square residual divided by sum of the square total, where sum of the square residual is sum of yi minus y predict the whole square. What is y predict? The y coming out of the model of the test data, and yi is the actual test data. So this sum of yi minus y predict the whole square is called the cost function. So if you want to reduce the cost function, that means if you want to make this close to 0, that means 1 minus this should be close to 1. So the closer R square is close to 1, the higher is the efficiency of the regression model. Okay, have you guys understood this concept? Any questions on this, how you measure the efficiency of a regression model? Have you understood the concept when I ran the script and you want to compare with the workflow which I had explained to you before that? Does it now make sense? Am I audible? I need some, initially I was
Yes,
in a
sir.
lot of enthusiasm. What happened to all of you? I want that enthusiasm to remain till 12:30.
Sir, can you briefly summarize this program once more? Very briefly, sir.
Okay, sure, no worries. So what I did was this is my data. So I imported the data, okay, using this pandas library. Okay, PD is the pandas. Then I defined what is my independent variable, which is X, and my dependent variable, which is Y. Then I split the data into training set and test set. If you remember, I had explained to you the workflow. So I've taken 70% training set and 30% test set. Then what I did, I fed my X train and Y train, which is my training set, into the model and got the model trained and came out with some patterns. Then I inputted the X test, which is my test data, into the model. The model has got trained, right? So I feed this model, I feed the test data from the independent variable of the test data into the model, and the model will predict me the salary based on the learning or based on the pattern it has derived. And then I will compare the y spread with y test here using this R square function. And this will tell me whether the model is efficient or not. And there, if you see, I received an R square percentage of 97%, 0.97 or 97%, close to 1, which means this model is pretty, anything above 95% is typically a very good model. Please understand that no model is 100% accurate. Today also you have not come, will not come across any algorithm which can give you 100% accuracy. Though the aim is to get to that 100%, but we are still far away from that, right? So coming to an efficiency of even 97% is good enough for you to recommend this model to your client. Have I made you understand, guys? Is it
Yes,
clear?
sir. It's clear, sir. It's clear, sir. Thank you, sir.
Yes, sir.
Great. Now I will show you a multi-regression model. This is another very interesting, and this is something you need to understand. I think that was one very valid question which was asked by one of the participants, is that in a multiple regression model, how do you find out which feature has the highest impact on the output, right? There are so many features, right? So what I will do is I will go to this. I will open multiple linear regression. I will select this folder. I will go to files. Okay. Now, can somebody tell me, now there are 50 startup companies. Okay. Now these startup companies they're spending some money on R&D. They're spending some money on administration. They're spending some money on marketing. And that startup companies are in a specific state. Okay. And then you have a profit of the company. Okay. Now, can you tell me what sort of data is this? And which is the independent variable and which is the dependent variable?
So can you repeat the question, please?
The question
Sir,
is, if you were to
except profit, other variables are independent, and the profit is the dependent variable.
correct. So the question was that from this data, which data is the independent variable and which data is the dependent variable? So yes, profit, because profit depends on your R&D spend. Profit could depend on administration spend. Profit could also depend on marketing spend. You may spend more in marketing, okay, so that you may come out with a lot of professional offers, which might increase your sales, and even in turn, which may increase your profit. Okay, so what happens is, if this is a data given to you and you need to come out with a model, okay, so the first and foremost what I will do is I will open this. Now the concept remains the same. I have this data, so I import my libraries first. I'm running this full setup again. Now I have taken my independent variable is all my, if I see my dependent variable x, y is my profit. Okay. And if I take x, which is my independent variable, it is a combination of the three amounts, that is your whatever that R&D spend, marketing spend, and third is your admin spend, sorry, and then you have the state, correct? Now this 4 becomes your independent variable and profit becomes your dependent variable. Now there is something as part of data pre-processing, which I will not get into that depth, but I'll just give you an idea. See, typically what happens in machine learning, this text field like New York, Florida, machine learning does not understand any text. So you will have to convert it into a binary format. Okay, and this process of converting into a binary format is called data categorization. Okay, that's why there are some libraries which are called like the label encoder and one in hot encoder. These are the various libraries which are available in Python, which helps to convert your text field into a binary field. Now, typically, if you see this is California, Florida, and if I were to execute this, you will see that, and now if I see the value of x, you will see that x, my California, all that New York, all that has gone, it has got converted into a binary format. Now this is an internal algorithm, so you really don't have to really much really get into the depth of that, but you need to understand that there are libraries within Python which converts any text field into a binary format, and this has to be done as part of your data pre-processing step. Before feeding your data into the model or before splitting your data into training set and test set, you need to ensure this data categorization is already done. Okay. Once you have done that, then see the process again remains the same here. Now what I do here is I again take X train, Y train. I use the linear regression. I predict, take the X test and I do a Y predict, and I then calculate the R square, and I basically try to find out my efficiency of the model. Now, if I have to just run this once, so I ran this. Now, what I will do is I will just execute this. And I execute ypred. I take X test. Remember, we talked about I take X test and I do a Y prediction, and now I calculate R square. It is showing 97%. So even with the current set of data, my current model, which I'm using for linear regression, is giving me an efficiency of 97%, which is good enough for me to propose this model. One of the practical things which you need to understand here is that if imagine there are 100 features, means 100 independent variables, and you want to know, this is a very, very common ask, is out of these 100 features, which feature has got the highest impact on the profit, which is my dependent variable. Okay, so there is a process whereby what is called a backward elimination. Now, this is something, this is sort of a statistical thing. I will explain to you briefly, just try to understand. So in statistics, there is something called a null hypothesis, and there is something called an alternate hypothesis. Okay, now what happens is that every feature can everybody go on mute? I think I see a lot of noise. Can others please go on mute if you're not talking? Thank you. So for every feature, like for example, you have got R&D spend, you have got marketing spend, you got admin spend. In this specific example, you'd like to know which feature has got the highest impact on profit. So based on which, as a decision maker, I can know that, okay, I need to focus more on my R&D spend or whatever, so that my profit enhances, right? Now, every feature has something called a p-value. This is again a statistical term. It is called a p-value. Can the host please mute everybody else? Okay, thank you. Now you have every feature has got something called a p-value, and there is something called a significant level, or which is also called the error rate, which is typically it is 5% or 0.05. What the statistics says is that if my p-value of a feature, now what does the null hypothesis say? Null hypothesis says that the variable or the feature has no impact on the dependent variable. And my alternate hypothesis says, let me get this down. And my alternate hypothesis says that this feature has a significant impact on the dependent variable, which is my profit. So what I do is, if the p-value of my feature is less than the error rate, means my alternate hypothesis is applicable. if my p-value is greater than error rate, then my null hypothesis is applicable, which means that that particular feature has no relevance or no impact on the dependent variable. Have you guys understood this concept?
Yes, sir.
Yes, sir.
Okay. This is very, very important. This is how the null hypothesis and alternate hypothesis. So if my p-value is less than my error rate, or this, which is also called the significant level, which means that that particular feature has got an impact on the dependent variable, which gets translated into saying that my alternate hypothesis is applicable. And if my p-value is greater than 0.05, then my null hypothesis is applicable, which means that particular feature has no impact on the dependent variable. So typically what happens is that, suppose you had R&D spend, you have got, which was the second? Admin spend. And the third one was the marketing spend, right? And imagine there are multiple such features. I'm just giving an example. So I will calculate the p-value for each of these features. Suppose I say calculate the p-value is 0.08, 0.07, and 0.06. I'm giving an example, right? Now, typically you will say that all these are more than 0.05, right? Then obviously none of these will have any impact on the profit. Okay. So what typically I will do is I will take the feature which is having the highest p-value greater than 0.05. Okay. And I will eliminate that. So in this case, let's say my R&D spend is got high. So I will eliminate R&D spend is eliminated. Okay. I will eliminate. This is called backward elimination. Okay. So I eliminate the R&D spend. I take the others like admin, marketing, so on. And again, I recalculate the p-value. There is a formula for doing that. It is called the ordinary least squares, OLS. So when I calculate the p-value, I recalculate the p-value. And then I continue this process till the time I get a particular p-value of a feature which will be generally less than the significant level of 0.05. And that particular feature basically tells me has got the highest impact on the dependent variable, in which case, in this case, is the profit of the startup company. So this is a very, very important concept called the backward elimination, where using the null hypothesis and alternate hypothesis concept or principle, you try to understand or try to find out which variable has got the most significant impact on the dependent variable, or which feature has got the most significant impact on the dependent variable. And this is how a backward elimination works. Is very, very important. It's a very important concept you need to know when you're dealing with multiple regression where you have multiple features. Any questions on this concept of
Sir,
backward elimination?
can you please explain this last point again? I'm sorry, sir.
Which point you're talking about? The p-value?
No, after p-value, sir. If p-value is less than and greater than that, understood. But after that, I'm sorry,
See,
sir.
you will, if you got 100 features, you will calculate the p-value of each feature. And you will eliminate one variable at a time. So you take the variable with the highest p-value greater than 0.05, eliminate that. Take the remaining features, recalculate the p-value, take the highest p-value greater than 0.05, eliminate that. Take the next set of features after eliminating. So you go through the process of elimination. This is called backward elimination. So you go to the process of eliminating each feature till you come across one feature which is having the lowest p-value.
Okay.
And that p-value will typically be less than 0.05, which shows that that particular variable or the feature has the highest impact on the profit or the dependent variable. Does that make sense?
Yes, thank you so much.
Yes, sir.
Anybody else has any questions on this concept of hypothesis, null and alternate hypothesis, and how p-value?
Hello.
Kindly request you to share the code if you have for calculation of p-value, sir. If you can share, if it is possible.
Yes, I will do that at the end of the session. I will send it to sir. I will send you these scripts along with the PPT, so you can have a look at it, and I'll be happy to share it after the session.
Thank you so much.
Sir, I have one question.
Yeah.
Am I audible to you, sir?
Yes.
Sir, as we have seen the linear regression and the multiple regression.
Yeah.
So I'm new to this machine learning topic. So
Okay.
just for the clarification, I am asking that. So if there are the only one dependent variable and one independent variable, then we have to go for the linear regression. And if there are the multiple values of the independent variable, and then one dependent variable, then we have to go for the multiple regression. So
No. Linear regression is one common class for both. See, if you see my script, right? This linear regression, I use both for my linear univariate regression as well as for multivariate regression. There is no different class I've used here. I've used the same.
Yes.
It's not different. So whether I use a single independent variable or if I use multiple independent variable, it does not matter. I use one single class, which is a linear regression. Only what differently I did in the case of multiple regression. See the concept, everything is the same. I did the R square, everything is the same. There is no difference. Only thing in multiple regression, what I additionally did was, if there are so many features, which features has got the most impact on the dependent variable? That's what I use the concept of backward elimination. Because if there's a single variable, then there's no question of using backward elimination, right? Where I'm using multiple features as independent variables, I need to know which feature has got the highest impact on my profit. That is where as a company, I need to strategize accordingly.
Sorry to interrupt in between, sir. That
Sure.
means that whenever we have a single variable which is dependent, so the p-value will always be less than 0.5.
The p-value is not relevant at all there, no? Because you have only one independent variable.
All right. Okay, sir.
See, dependent variable is always one. Don't get confused. My dependent variable will always be one.
Okay.
Independent variable can be multiple.
Yeah.
Your dependent
I mean
variable
to say
cannot
the
be.
p-value for the independent variable when it is only
Yes,
one independent
it makes sense
variable.
only if there are multiple features. It doesn't make sense there's only one feature, right?
Sir, so in both the case, linear regression and multiple regression, your dependent variable will be only one.
Dependent variable is always one.
Always one. Okay.
It cannot be more than one. Never.
And for an independent variable can be more than one for the multiple regression.
Exactly. That's why it is called multivariate. That means multiple independent variables.
Thank you, sir. Thank you for clarification.
Yeah. So is this clear, guys? I mean, all of you, have you understood this concept of multiple regression, the process of backward elimination? Very, very important.
Yes.
Great. So now I'll get into classification, right? I'll show you some very interesting classification. Now let me go back to my Python script. Now I will close this. Again, the concept of the approach, the workflow which I'm using for classification is absolutely the same. No difference in the workflow. Whether you're using regression, you're using classification, and I will show you how it works. So let me go back and I will open something called classification. And there is something called logistic regression. This is one of the important classification methods. Okay. So what I do is, this is my data set. Now the data set says that there is an automotive company. That automotive company wants the customers to log into their portal and show the preference of buying a particular brand of car. Okay, so you have user ID, you have gender, you have age, you have salary and purchase, yes or no. Now, is this a classification data or a regression data?
Classification.
So which is the dependent variable? Which will be the dependent variable in this case?
Type of
Salary.
Sorry.
Estimated salary.
Estimated salary is your independent variable. Anybody else has different thoughts?
Type of the car
purchased
the
will
customer want to
be
buy.
No,
dependent
estimated
variable.
salary is the dependent variable.
Which one? Which is the dependent variable?
The car customer wanted to buy,
Estimated
sir. Model number.
So the purchased, yes or no, 0 or 1 is your dependent variable. Because this is a classification data where your dependent variable has a discrete set of values. And my age, estimated salary, okay, see, user ID does not have any relevance because user ID is for logging in into the system, right? So this does not make any sense from an analysis standpoint. Gender generally, okay, in this case, I'm assuming that I don't really care about the sex. I only care about the age and the estimated salary. So my age and estimated salary will determine whether I'm going to buy a particular car, that particular brand of car or not. So my age and estimated salary becomes my independent variable, and my purchased 0 or 1. 0 means he's not buying the car and 1 means he's buying the car is my dependent variable. Is this clear?
Yes, sir.
Clear.
So we can right away
Yes,
eliminate
sir.
the user ID and my gender category.
Yeah, because I don't, it doesn't make, user ID doesn't make sense. No, it's anyway unique for any, it has just a user logging into the system. So it has no relevance as far as my analysis is concerned, right? And the customer is also saying that I don't want to know whether it's a male or female. I am only concerned about his profile in terms of his income and the age, right? Which will decide whether then accordingly I need to have some promotional campaigns for that group of people, for example, right? So having said that, now what I will do is I will open this logical regression, this script file. Okay, now again, as I said, the concept is the same. Now, what is the difference here? You remember we had talked about a predicted Y. The model, when you had fed X train and Y train into the system, you had trained the model which had come out with some sort of a pattern. And then using X test, you had predicted Y, correct? In the case of classification in this example, what could be the possible values of Y pred? Anybody?
0 and 1.
Or 1.
Absolutely right. So your predicted value of Y will be always also 0 and 1. It cannot be anything else, right? So again, what I will do is I will import my libraries. I will import my data set. Then I will see, I will take only age and salary as my independent variable because I had not really bothered about the user ID and the sex. So this is my X, this is my age and salary, and my Y is my purchase, yes or no. So if I go to Y, 0 and 1, right? 0 means he's not buying the car, 1 is going to buy the car, right? Then I do my split into X train, X test, Y train, Y test. Now, there is some process as part of data pre-processing. If you remember, we spoke about a data categorization where I had a text field like a state. Since machine learning language, machine learning algorithm doesn't understand text field, you have to convert into a binary format. Similarly, in the case of machine learning, there is something called feature scaling. Anybody knows what is feature scaling? Anybody knows what is feature scaling?
Is it that we give them numbers instead of values?
No, these are numbers only, na? Your age and salary are numbers, right?
I think the different features have different ranges, so we use some normalization, min-max normalization during scaling. I'm not right. I think these kind of techniques are used for scaling to bring it into a common range.
Perfect, perfectly right, absolutely right. So essentially what happens, this age and salary are in different ranges. Your age will be typically from 21 to 60, but your salary could be from 10,000 to maybe 1 million or 10 million or whatever, right? As a CEO of company, you must be earning how much, whatever the money you earn. So machine learning, what they say is that if there are features with different scales, you need to bring it to a common base scale for the machine learning algorithm to do a proper comparative analysis. And that process is called feature scaling. So once you do the feature scaling, you bring all the values to a common base scale so that it's easy for the machine learning algorithm to interpret and do an analysis. Now, you as a consultant, you need to know that this has to be done. But internally, what is happening is, again, is a different algorithm. There are some classes, various programs which are running in the background. If you want to get into the depth of that, you can certainly do that. But there are functions which are there which help to convert these high values or values with different ranges into a common scale. And that feature is called feature scaling. And feature scaling is also one of the data pre-processing steps that you need to do before you actually feed the training data into the model. Okay. So this is what it is doing here. This is called feature scaling. So I'm just giving an example here. Then what I do is I feed, again, the same concept. I feed my X train and Y train into the model. I predict Y. I predict Y. Okay. And now I want to explain to you something called a confusion matrix. Okay. In the case of regression, you came across what you call the R square, which was used to measure the efficiency of a regression model. In the case of classification, what you have is a confusion matrix, and I'll spend some time on this. Now, what is a confusion matrix? Okay, so typically this is how it represents. Now 0 and 1 are the expected values of your output, right? In this case, 0 and 1. 0 means he's not buying a car and 1 is buying a car. So you have a predicted value and you have an actual value, right? This is the test data. I'm considering only the test data here. Now what it says that out of state, this is how much, 40, 90, 100, there are 35 cases where my predicted and actual value says that he is not going to buy the car. So my prediction, the model is giving a perfect prediction in 35 cases. In the case of 50, again, my predicted value says that he is going to buy the car and actually also he's bought the car. So my model is also working perfectly fine here. There are 5 cases where my predicted value is 1. That means he is going to buy the car, but actually he has not bought the car. But actually he has not bought the car. And there are 10 cases here where he has predicted that he is not going to buy the car, but actually he has bought the car. Okay. Now, if I were to translate this into a healthcare problem, where I say 1 means he is having malignant cancer and 0 means he does not have cancer or it is benign, right? Now this 1 there are 50 cases where the model has predicted that he has got cancer, and actually also he has got cancer. Now these 50 in machine learning terms is called true positive. It is called true positive. That means it is predicting that he has got the disease, and actually also he has the disease. Perfect. Now there are 35 cases where he does not have the disease actually, and in the prediction the model also says he does not have the disease. This is also fine. So this is basically called the true negative. So one, you have the true positive where the prediction and actual says that he has a disease, and there are 35 cases which are true negative where the actual and predicted also says that he does not have the disease. Now let's take this 5. This 5 says that he predicted that he has got the disease, but actually he does not have the disease. This is still okay. That means I predicted that he has disease, but actually does not have. Okay, so this is still okay, but this is an error. Okay, and this error is called false positive, or it is also called the type 1 error. The other one, which is more critical, is that I have predicted that he does not have cancer, but actually he has got cancer. This is a very problem, right? If the model says that he does not have cancer, but actually he has cancer, it's a big problem, right? So the model is not behaving the way it should. And this is the most critical error which needs to be eliminated. And this error is called false negative, or it is also called the type 2 error. Have you got this concept clear? False positive, false negative.
Yes,
Sorry,
sir.
true positive,
Yes,
true
sir.
negative, false positive, false negative.
Yes,
Have
sir.
you got this concept
Yes.
clear?
Yes, sir. Yes. Yes.
Okay, so now if I have to calculate, so my main intention is to eliminate this type 1 and type 2 errors. So these errors are very, very critical. And my model should be such that if I have to calculate the accuracy, in this case, accuracy is 85%. And my error is 15%. My accuracy has to be at least 95% to recommend this model to the client. So typically what I would really do is I will run with this set of data, I will run various types of classification models. So I will run decision tree, I will run random forest, I will run support vector matrix, there are various algorithms available. I will try all those algorithms and see the one which is giving me the highest accuracy rate. Okay, so confusion matrix is a very, very important parameter to measure the efficiency of a classification model. Okay, so now if I go back to my script and I execute this line and I calculate, and if I put CM here, so what is the accuracy in this case?
50.
What is the accuracy in this case?
65 plus 24.
So how much is that?
That comes out to be 89.
So how much percent I'm saying?
89%.
Correct, 89%, right? Because my total sample size is 100, no? Right? So my efficiency or the accuracy is 89% and my error is 11%.
11%.
Okay. Now, if I want to plot this, see how interesting it looks. Now, if I want to plot the training set, if I want to plot this training set, so now if you see here, this is called a decision boundary, this line. Okay. To the left of the decision boundary is the predicted value of 0. And to the right of the decision boundary is the predicted value of 1, the green color. And the red dots are essentially the actual value, training data. So there are red dots in red, there are some red dots in green, there are some green dots. In this green also there are some red dots. Okay, so these are the type 1, type 2 errors, right? Wherever you have some red dots in green or green dots in red, where my predicted and actual value is not the same, these are the type 1 and the type 2 errors, right? Similarly, if I want to run this for a test set, if I go down, this is how it looks. And if you probably count, there'll be 11 cases, 89%, right? There were 11 cases where there are some green in red and there'll be red in green. So these could be those 11 cases out of 100, which shows you the accuracy or the error rate of 11%. Okay, this is how you use logistic regression to basically find out whether that model fits, and you use confusion metrics to measure the efficiency of the classification model. Okay, any questions at this point of time?
So how do we improve that efficiency by including more of the training data?
See, one, if you have more of the training data, obviously your model will get trained better. Okay, but if there is some data, okay, if there is a test data which is, you have to, this test data which you are having, which is giving the type 1 and type 2 errors, you need to really investigate those data and first of all see whether those data is correct or not. Okay, this is the actual data, right? So you need to discuss with the client and say that why is this the right data, because my prediction is giving something incorrect. And if the data is correct and if my prediction is wrong, that means this model is not perfect for this data. That specific logistic regression model that is not the right model for this data. So it's again basically based on a lot of trial and errors. You need to try out, and obviously your main objective is to see that a doctor should not get misguided by the model.
Right.
And you cannot afford to do that. Then the patient will never go back to the doctor the next time, right? So you will have to, so in this case, maybe the doctor is your customer. So you have to make sure that the doctor has got the right model with the highest accuracy. See, as I said, no model is 100% perfect. That's okay. Even if you have 95% is still okay. But if you cannot afford to have a model of 89%, nobody will accept it. Or neither you will recommend that to your client, which is incorrect. Right? So this is all trial and error. And as I told you, very important, the quality of your data is very, very important. The quality of your data. If my data is not good, if my data is not correct, my model will give you wrong results. Okay, so you have to ensure, that's why I said 60 to 75% of your time. If I go back to this particular graph, I will show you this very interesting graph. Yeah, this is the graph. Okay, this is your project life cycle. Your business understanding the data comes from the domain. You collect the data preparation. This phase is the maximum time this one and the exploratory data analysis. This is the maximum time you have to spend on the quality, which decides the quality of your data. Once you have done this, you have taken care of your data, then the modeling, then the model evaluation and model deployment. The model deployment is you make it live. This becomes easy once you have taken care of these two steps. So this is the major time which is spent in any project life cycle for a machine learning project, right? So any questions at this point of time?
Excuse me, sir.
Yeah.
So if we have two data sets, one a very big one and one a small, and in both the cases, 40% of the attributes have missing values. So can you compare the performance of the model in these two cases? How will it affect the performance of the model?
So what you're saying, you have two different sets of data.
Yes.
Okay. And then you have got, say, one set of data which has got a missing data and other does not have missing data.
No, both have missing data.
Okay.
On that to 40% we consider, but
Okay.
one is a very large data set and one is a smaller data set in which 40% is missing. And in another case, there are two cases. I wonder how will the model performance first question is, will the performance be affected, and in which case it will be more, and
Again,
what will be the
as I said, again, it depends on the quality of the data. See, if there is a missing data, you have to first eliminate that. You cannot have a missing data and you feed into the model. That is not possible.
So in both the cases, the solution will be to do the pre-processing and remove.
Yes. Pre-processing is a must.
But does it affect the with the pre-processing time and all with the size of the data, like larger data set and smaller data sets? Does it affect?
Nowadays it doesn't matter because nowadays you have GPUs. You have got graphical process units. You have got artificial neural networks, which is speeding up your processing of your data. So nowadays speed is really not the matter. It's the quality of the data that matters. You will get that speed to process millions, trillions of data. That is not a problem. But the question remains,
the larger data set is preferable or a smaller data set is preferable for?
See, you should always start with a smaller data set. Okay, and then you try out the various combination, various models and see which is the giving, and then you try with larger data sets.
Okay.
Right?
Right, sir. Thank you.
So this is what I wanted to ask about quality of data. So that we have a good quality data, we should always start with smaller one and then see how much accuracy it is giving us and then increase the size.
Yes, that's how you should do it. Yeah.
Thank you so much.
Okay, so let me do one thing. Let me go through some quiz. Let us see how much you guys have learned. Let me give me 1 minute. Let me open any one of these. Okay, I think let me open this. Sorry, not this. Let me open any one of them. Okay. Let me see how much you remembers. Okay. Let's go question number 1. And this is a multiple choice. So you need to tell me which is the right answers. Okay. So if I go to question number 1, what are the examples of machine learning applications? Could you tell me which is the right answer?
All of these, sir.
Anybody has got a different answer to this?
Chatbot.
Only chatbot. Okay. Anybody else?
It says application search fraud detection.
Fraud detection also, sir. All above, sir, actually.
So it is the prediction model also, fraud detection.
So prediction model, is it an application?
It says the machine learning application. So when it says application, it should be only fraud detection.
Yeah, so the question is, which of these examples are machine learning applications? I'm not talking about model, right? So fraud detection, Google search, yes, these are all machine learning application. Chatbot, yes, but prediction model is not an application, it's a model, right? So the questions were specific to what are the examples of machine learning applications. So the answer is fraud detection, Google search, and chatbot. Now let me see who is smart enough to give me the second answer. What are the various machine learning types?
Supervised learning.
Okay.
Then
Reinforcement learning.
Supervised and reinforcement, sir.
Reinforcement learning.
Very
A
good.
and D.
Very good. Anybody else has got a better answer?
Learning association is again.
Why you are saying learning association?
Association rules.
I'm sure 99% of you will miss out on something. So what is the right answer?
ABD.
A and D.
A and D.
A and D, sir.
A and D. Who differs?
Yes.
A and D. Who differs?
A, B, and D.
Sir, ABD.
A, B, D.
Why B?
Learning association is also a part of the day-to-day application where we do the product recommendation, and it is also, it is
Unsupervised.
Correct. That's what I wanted to hear, that word. So learning association is part of unsupervised learning. So people always look at the header, not the subsections, right? So typically I will always say supervise and reinforcement. Okay, but I will never get into a subsection like learning association, which is part of unsupervised learning. Okay, so the answer is A, B, and D. Okay. Question number 3, which of the following library can help manage data sets?
Pandas.
Pandas.
Pandas. Perfect. So pandas is the right answer. Let me see, guys. I don't know whether you'll be able to answer this. Let me see how much of you can answer question number 4. Sequence the following data pre-processing steps.
First one, import data set.
Importing data set.
Okay.
Categorizing data. But then missing data, then categorizing data.
Okay. After that?
Then featuring, scaling. And lastly, splitting data into the training and test data set.
Okay, good attempt. Anybody else?
It will be importing data set.
Okay.
And A, missing data.
Okay.
Then D, feature scaling. Then C, splitting the data into training and test. And finally, B, that is categorizing the data.
Okay. Anybody else?
I would go to importing data set, missing data set, features categorizing, then feature scaling, and then splitting into training and test data set.
Okay. So you're not, all of you are not very far away, but it's importing data set is obviously absolutely right. Then you take care of missing data. Then you take care of data characterization to eliminate any text fields which need to be converted into binary. Now, before you do feature scaling, you need to do the splitting. So you have to do xtrain, xtest, ytrain, ytest. And then only after that you do feature scaling on the xtrain or xtest. Okay.
Okay.
So it will be always E, A, B, C, D in this case. Okay. So let me see who can answer this question. Which of the following is not a recommended strategy to take care of missing data?
Sir, it's B.
Yes, sir. B. Delete the observation that contains the missing data, because we can miss the remaining data also if you delete.
Okay. What about the other ones? Replaced by the median or the mode or the mean?
By taking the mean, we can replace that data. If it is suppose 0, so certain suppose 5 values are 0, suppose in your data, So we can replace that 5 values by taking mean of rest of the values, and we can put there, we can replace that 0 by mean value. So that is one, means we cannot miss the remaining data of that particular table. So
correct. So typically what happens is there are some missing values, right? You generally go back to the client saying that there are some missing values. As I told you, you cannot afford to have missing values, right? You need to have a very clean data. And if the client says that, okay, you can come out with your own assumptions, then I can say, okay, I can replace it by the median or the mean of the remaining values, or I can do the median, or I could do the mode. Okay, I could decide. But the last thing you should ever do is to delete, because as you delete the observation, unless it's really, really critical, again, if you have to delete the observation, you have to take the permission of the customer. That is this okay if I can delete it? You should not do anything as long as you are in the data preparation phase. That is the time you have maximum collaboration with the customer. Okay, once you're into the modeling, then obviously client is not into it because the model is yours, right? But the data preparation phase is the most important, where you need to have a constant interaction with the client. Okay, so absolutely. So the answer right is B. Okay, I will not. Question number 6. Okay, can anybody guess where a dummy variable is used?
Data categorization.
no, sir.
Why are you saying that? I know there are only 2 options.
I would choose feature scaling because when I have to bring all the values into a base scale, so in that case, I can use a dummy variable and find out the base scale between the two, the x and the y, using while doing the feature scaling.
To decide how many, if there is 3 variables, you will have an array of 3, where, for example, if I have say I've got France, I got Germany, and I got, say, Italy, these 3 countries, just for example, right? So what I will do is I will create an array of 3, and I will say 1 0 0 means it is France, 0 1 0 0 1 0 0 1 0, it is Germany, and 0 0 1 0 0 1 is Italy. So what I do is I build an array, and each value, wherever there's a value of 1, represents that particular country is present, and wherever the country is not present, it is value 0. Okay, so 1 0 0 means France, 0 0 1 0 could be Germany, and 0 0 1 could be Italy. So these are called the dummy variables, which is used in data categorization. So I mean, I was not expecting you guys to know it, but just to get a feel of where a dummy variable is used, yes, it is used in data categorization. Which are the Python libraries here?
Sir,
Sir, all of the above.
sklearn, pandas.
All of the above.
All of them, all of above. All of.
Correct. So NumPy, Matplotlib, Pandas is there, and sklearn is also called the scikit-learn. Very, very important library in Python for doing various type of calculations, like your training test plate, then your data categorization. Okay, all that you had used scikit-learn library. Yeah. Question number 8, I think we can omit. Okay, let's see question number 9. Which is the recommended ratio of splitting training and test set?
80,
Sir,
20,
A.
80 20.
80, 20.
80-20.
Only 80-20?
Number,
Why only 80-20?
80-20
because beyond 80, it can result error data set, means error result, and below 80 also it can generate I mean, on error.
See, it depends really on the volume of data, right? If you have maybe millions of records, then I could as well take 80% as my training set and 20% as my test set. Okay, I could also have 90-10. For example, if I got large volume of records, I could take 90% as my training set and 10% as my test set. So typically, it depends on the volume of records, and recommended could be 70-30, 80-20, and 90-10. Obviously, you cannot have 30-70, and obviously you cannot have 100-0 because you cannot have a data without a test set, right? To test the efficiency of the model, right? Question number 10, which are the various algorithms used in supervised learning?
Linear regression.
Okay, that's it.
Linear and logistic.
Linear and logistics. Okay. Anybody else had different thoughts? So linear regression, absolutely right, because it is part of regression. Logistic regression is part of. Where did you hear about logistic regression?
Classification.
Classification. Perfectly. Perfect. Associated learning is part of unsupervised model. Associated learning is like your learning association, right? NLP is also one of the important things, which is a practical example. I go to a restaurant, and in the restaurant, most of the big restaurants, they ask you to fill up a feedback form, right? At the end, which tells you to judge the quality of the food. So you may write some various sentences that this food is spicy, this food is sweet, the food is sour, and all that. Okay. So using most of these big restaurants, they have some NLP algorithms, okay, which helps to detect using various concepts like bag of words and all the stuffs, which helps you to determine whether the feedback is good or a feedback is bad. Okay, so this is an example of a classification model where using NLP libraries, the machine learning algorithm can say whether a feedback about a particular from a particular customer is good or bad. Okay, so this is called NLP, natural language processing. So it's so Jenny, NLP also is used in supervised learning. Okay, and the last question is, what is true about classification?
Confusion matrix.
Prediction boundary, sir.
Okay, so what are the options? What are the right answers? What are the right answers?
Prediction boundary.
Prediction boundary. Okay.
Confusion matrix.
So one is unlabeled data. Obviously, that is not correct. Labeled data, yes, because you have a labeled data. You have confusion matrix because that is used to measure the efficiency of the model. And the third is the prediction boundary. Because if you remember in the logistic regression, I showed you a prediction boundary where on the left-hand side, you had the red, which was 0. And on the right-hand side, you had the green, which was 1. And then you had the dots in and around that, which was your to determine the type 1, type 2 errors. Correct? If you remember that prediction boundary, that graph, which you saw in the logistic regression, right? So that is an example of a prediction boundary. Okay. So this was just to give you an idea. So what we covered today is we covered some of the data pre-processing steps. What is machine learning? We covered some machine learning live applications. We talked about supervised model where we talked about regression. We went through some examples of simple linear regression and multiple regression where we used backward elimination to find out the variable which has got the highest impact on the dependent variable. And we touched upon classification where we hit upon logistic regression. And obviously, as I'm telling you multiple times, remember the workflow. Keep it in your mind. That's very, very important. If you have that in mind, it's easy to appreciate any machine learning algorithm. Okay. And Obviously, the more you practice and importantly, have a good knowledge on statistics if you want to really pursue machine learning as part of your career. Okay. I think that's it from my side. Any questions before we wind up? Did you guys enjoy this session?
Yes, sir.
Yes, sir.
A lot.
Very much.
Yes, sir.
We have
Yes, sir.
learned a
Very
lot.
much.
Thank you so much, sir.
Okay, you guys have at least you got something to take back with you as a knowledge, right? Good. That's
Yes,
what is
sir.
important. Okay, great. Any questions? Anybody has any last thoughts? Anybody wants to share something before we close for the day?
There is answer 8 label encoder. The answer 8.
Yeah, it is label encoder and one hot encoder, both. Both are used for categorizing. There are two classes. One is label encoder and one is one hot encoder.
Hello, sir.
Yeah.
Yeah, sir, can you give any example or some new project related things that we can merge with NLP with the machine learning?
So I talked to you about the restaurant reviews, right? That is a classical example of using NLP. So if you can do some study on NLP, natural language processing, NLPs, the libraries which are used, and take an example of a restaurant review. There are various data sets available, and you can use NLP to find out, to judge the whether the quality of the food, okay, whether the feedback is good or bad. So there's you can use those data sets. Anything else? Anybody has any questions?
Sir, do you can you explain one more project? I mean, small project only. Under your,
See, there are
you shared
various
in your
projects.
collection.
For example, I gave you this example of this logistic regression, right? You can use the same data to run various other algorithms. You can run the support vector matrix. You can learn the decision tree, random forest, calculate the confusion matrix, and see how good or bad the model is. So use the same set of data and run different models. That is how you do it in industry.
Yes.
Any more questions? Participant, please, if you have any query, you can ask. So
Okay, then.
Yes, sir.
Thank you, sir. Thank you very much. Thank you, everybody, for your time, and hope you guys enjoyed this session and go back with some knowledge which you can apply in your day-to-day learning.
So before we wind up, just I want to thank you, sir, for the wonderful session. And actually, it was really very informative, and you have showed the participant small things with the help of demonstration. And I should say that you have made it as simple as possible. So with this note, we'll stop here. Thank you once again.
Thank you very much. Thank you for your time, everybody. Bye-bye.
Thank you. Bye. Dear participant, the next session will start at 2. Okay.
Sir, please share your mail address in the chat box, sir.
Chat box, actually, in the morning itself, I have put my mail address. Okay, but still, again, in the morning, you can just go through only one message I have sent. Okay, it is there. Okay, otherwise, again, I'll resend it. Okay, that's not a big deal. Apart from that, I want to share one more thing, that is, I am sharing certain stuff on the Google Classroom. Okay, but around 100 or 101 participants are registered for the class, Google class. So I request the rest of the participants, those who have not registered, to register for the Google class. Okay, so that you can have all those things available at your disposal. Right.
Okay, sir.
So,
Sir, on that regard,
sorry.
Sir, on that regard, I joined the Google Classroom using that code given, but it is not showing in that list, sir. My name is not showing in that list.
Sir, but whether you have successfully joined the class?
Yeah.
Acha, whether you have used your official email ID or personal email ID?
Yes, yes. So with that email ID, the we means
Which one?
what I have
Official
joined
one
this
you have
one.
used or the personal one?
No, my personal one, sir.
You use your personal one. I'll check out your name. What is your name, sir?
Sir, Soumitra Saha.
I'll
So the
get
email ID is saumitrasaha1177@gmail.com.
Soumitra Saha 11
77
1177.
1177@gmail.com.
I'll check it out, sir, and let you know.
Excuse me,
Okay.
sir.
Yeah, please.
Thank you.
Sir, can you please share the Google Classroom code again?
Google Classroom code. Just hold on, okay? I'll paste it. I'm sharing the code in the chat box, okay? Hello?
It's
Yes,
not
sir.
available.
Yeah, I'm just, hold on.
Okay, sir.
Okay. Now
Can you please reveal the Google Classroom code?
I'm sharing it. It is VRGRMTH. I'll spell it out.
Sir, with this code only, I have joined the classroom.
Okay, sir, in your case, I'll check it out because I have got 101 participants there. Okay, maybe
Okay.
issue with your particular case. I'll check it out and then we'll just
Okay.
resolve it. Okay, sir.
Okay. Thank you.
And with regard to, as I've told you, that is the afternoon session will start from 2 to 4 and then 4 to 6. So we'll have in a single go. So we'll break for lunch now.
Okay, sir. Okay.
Okay, sir.
Thank you, sir.
1 hour 15 minutes is more than enough for getting lunch.
Yes, sir. Yes, sir.
Thank you, sir.
Thank you, sir.
2 p.m. sharp will start. I request all of you to please join on time.
Yes, sir.
That is my humble request.
Yes, sir.
Thank you once again.
Thank you.
I think it's better you can leave all of you. Again, you join at 2. Okay.
Okay, sir. Okay.
Yeah. We will start at 1:45. Okay, 1:45, 1:50. I will start 10 minutes earlier, and then up to 2, you please join.
Yes, sir. Yes.
Okay.
Okay.
Thank you. Kaha, sir, you were asking about your Google Classroom status. You are very much there, sir, in the class.
Now, sir, I have applied again. Joined it again, sir.
I have admitted you, and then I realized that you were having some queries. So you are there, no worries, right? You can see the content. Okay, sir?
Yes, sir. Yes, sir. Thank you so much.
There are few difficulties which I am facing basically with regard to tomorrow's session. Whether all of you are there?
Yes, sir.
Yes, sir.
तो issue ऐसा है कि कल one of our resource person, that is Mr. Agau, he is from Singapore. Okay, so he said he has rescheduled his slot. Earlier it was 10:30 to 12:30. Now he is saying due to some other assignment, he is not in a position to conduct from 10:30 to 12:30. So we need to reschedule it to 4 to 6. Right, that is one thing. And then again in the afternoon, 2 to 3 and 3 to 4, we'll have 2 sessions. Okay. So I am planning for valedictory function as well as your feedback and evaluation in the first session. Is it okay for everyone?
No issues.
Because the problem is we don't have any options left. Okay. Because these resource person, there are 3 people, right? One is a ma'am from COEP, another is from Buldana, Maharashtra only, and this Agau sir is from Singapore. So he said 4 to 6. So 3 to 4, 2 to 3, 3 to 4, and 4 to 6. So this way we'll have our session. Okay. And in the morning we will have your valedictory as well as evaluation, everything, right? So you just be prepared for that.
At what time? 10:30?
10:30 will start. Okay. We'll have a MCQ type question paper. Okay. So I'm planning to give you around 50 odd questions. Okay, and you have to attempt it. And apart from that, within 1 hour, we will have the valedictory function. So we'll have valedictory in the beginning, and then it will be followed by, I should say, you just suggest me. It is open for discussion. Okay, whatever you suggest. Okay, we'll do it.
Sir, can you give some study material?
Study material is very much there, sir. Okay, you need not worry. What if you have attended all the sessions? Because what is my strategy is I am gathering questions from the resource person, right? So whatever they have covered, only those questions will be there. Okay, and whatever resource material have got, I am putting it onto the Google Classroom. Okay, I have not still received many things. Okay, but whatever I'll receive, I'll put it onto the Google Classroom. Okay, certain things I am keeping there. Okay. Tomorrow morning we will have.
Sir, have you already given or you are supposed to?
No, I have posted certain things. Okay.
In the Google Classroom.
Google Classroom, yes.
Sir, I have not got it yet.
No, sir, you simply join the Google Classroom, okay, and then you just look at my post. You will find 3 different posts over there. में आपको PPT मिल जाएंगे, ठीक है?
Just now, a few minutes back, I have checked, sir. I have not got it, sir.
अच्छा, okay. Somebody is saying, sir,
maybe you have allowed it later on. So that's why the earlier post I have not got.
Sorry, I am not able to understand what you are saying.
Means you have approved me now, sir.
Acha. Maybe that
So
means
probably that's why earlier post I means it was I have not got.
you are not able to see the earlier post. That is what. Again, I'll repost it. Don't worry. Okay.
Okay, sir. Thank you.
The other people are simply mum. I wanted to know your opinion whether we should have the test in the morning, yes or no. Or otherwise, we have to extend from 6 p.m. onwards. 10:30 is okay for exam, somebody is saying.
Yes,
Okay.
Sir.
Yes,
It
sir.
is
10:30
okay.
is okay.
10:30 is okay?
Yes,
yes,
sir.
sir.
10:30,
Yes, sir.
not exactly. We'll start at 10:45 or 11. Okay, no, not an issue, right? And again, it will be a Google form. Okay,
Yes, sir.
Yes,
Google
sir. No
form.
issue.
Okay. ऐसा है.
Sir, whether you are sharing the link in the classroom or in this particular Zoom meeting.
Sir, please speak loudly, sir. Ashish.
Sir, you are sharing that particular link of test in the classroom or in this Zoom meeting.
Google Classroom, sir, I am sharing. Google Classroom.
Okay, sir. Thank you.
It is there. If you have joined, you can see over there.
No, exam link.
Otherwise, what I'll do, sir, if it is convenient for you, I'll put it on WhatsApp as well. Is this okay?
Yes, sir. Yes, sir. That is okay.
So
Yes,
that,
That will be better. That will be better.
That
That
will
is
be
okay, sir.
okay. So our guest is there. I think resource person is there for next session. Okay, I am admitting him.
Okay, sir.
Dr. Rizwan, very good afternoon and welcome. Hello.
Good afternoon, Dr. Atik. Thanks for having me here. I hope I'm audible.
Yeah, you are very much audible. How are you, sir?
I'm good, thank you. I
Yes, sir.
joined in few minutes early, so that we should be good with the setup.
Yes. We will start dot at 2, sir. We have to wait for few more minutes, right?
Sure, absolutely, sir. Yes.
Okay. Thank you. Okay. Very good afternoon to one and all present here, and I hope I am audible to all of you.
Yes, sir. You are audible, sir.
Thank you. So today we have with us Dr. Rizwan Ahmed, who is the CTO, that is the Chief Technology Officer at Delaplex. Rizwan sir has close to 2 decades of professional experience in IT industry as innovative hands-on technology executive with a proven track record of leading the design, development, and program project management of high technology projects and solutions. Apart from that, he has been a part of Delaplex founding team, which is driving force in growing the company from its inception in 2008. Dr. Rizwan also worked as independent consultant for cybersecurity and digital and mobile forensic investigator for various private, government, and law enforcement agencies in India and abroad. So Dr. Rizwan also has an experience in academia and has been associated with many top institutes from Central India. Dr. Rizwan has been awarded as IT Technology Hero Award 2008 by Microsoft from over 900 technologists and more than 10,000 developers. Apart from that, Dr. Rizwan is regularly invited as speakers at many national and international conferences, events, and panel discussions in India and abroad, and has delivered more than 250 talks so far. So Dr. Rizwan has been appointed as Distinguished Speaker of ACM, Association of Computing Machinery, New York, where he is amongst very few chosen and accomplished technical speaker worldwide. So with this brief introduction, I welcome you, sir. Today he will be talking on analysis of various algorithms and models for image segmentation using artificial intelligence, machine learning, and deep learning. It's over to you, Dr. Rizwan. Thank you.
Thank you, Dr. Atik. Thanks for that introduction. And at the outset, I feel really humbled to be part of this STTP. And especially this is being conducted by my alma mater, right, which is Shri Sant Gadge Baba Amravati University. I have been fortunate to be a student of this university way back almost 20 years back. And that's where my journey of artificial intelligence also started. So I really feel humbled to be here and interacting with all the people through this forum. So I remember, right, when I was a computer science and engineering undergrad, we had a lot of interesting computer science subjects. And one of those subjects at that time was artificial intelligence. And I was really fascinated about what potential artificial intelligence has and how it could help us solve a lot of real world problems. And with that fascination, I got involved in this field and I started my journey with artificial intelligence as a student. And one of the first things what I did is just to explore this field is I started doing a lot of research, looking at what others are doing. And I came up with an idea way back when I was in my 3rd year of engineering. And I wrote my first paper and it was titled as Automatic Programming. And I tried to make use of heuristic algorithms like genetic programming and genetic algorithm, right? And the concept was very simple, that you tell the computer what your input is and you tell your computer, right, what output it should give. And computer is going to write the program for you. And fortunately, that's how I started my journey. And I presented that paper at one of the national conferences. And I was at just the 2nd winner, right? And that maybe really, maybe I was feeling really happy about my initial journey. And that's how I got involved more into other areas, right? And I started working on other areas of artificial intelligence, machine learning, deep learning, right? And we are still utilizing it to solve a lot of real world problems. So I think we have already talked about some of the introduction about me. So again, one thing I would like to highlight here is there are like a lot of business use cases which me and myself have been involved in last 2 decades, wherein we have utilized artificial intelligence, machine learning, and deep learning to solve some of the real world use cases. And I'm going to talk about some of those use cases during our interaction today. But there's so many more use cases which I've personally got to work through. And I really feel excited about that. So as all of you know, right now we are in the fourth industrial revolution. If you look at the previous industrial revolutions, basically the first industrial revolution kind of liberated our humankind from animal power. If you look at the second industrial revolution, that made mass production possible, wherein we had assembly lines and things like that. And in the third industrial revolution, we were able to get all the digital capabilities through power of internet, wherein billions of people were able to interact with each other and use power of internet. But this fourth industrial revolution, what we are going through right now, it's going to be fundamentally very different. And it's going to be combination of multiple technologies, and that's why I'm giving you a reference of a very good paper which is written by Professor Klaus Schwab, who is from World Economic Forum, and he has talked about his idea of the fourth industrial revolution. And there are going to be two things which are going to be prominent in this fourth industrial revolution, as we're already seeing around us. So first thing is, it's going to be involving extreme automation and connectivity. Anything what we are doing, we'll try to automate. Anything which is repeatable and there is no human involvement required in that, those things are going to be becoming better and better. And second thing is, we'll have some kind of cyber physical systems which are going to be combined with use of artificial intelligence and robots, wherein we live in our physical world, but we'll somehow have some kind of interaction with the cyber world. And for that, we'll come up with a lot of AI driven technologies, and a lot of that has been already happening around us. And if you look at IDC's prediction, right, this AI technologies, we'll see almost $100 billion to be spent in 2020. One request to all the participants, please, if you're not speaking, I see some background noise. I think it is Arvind. So, Mr. Arvind, if you can please mute yourself. Thanks for that. And one request to all the participants, please keep yourself mute. And in between, if you have any questions, you can use the chat window, right? And you can post your questions there. And with organizers and moderation, right, I'll try and take those questions. Sir, can you mute Arvind Kumar? I hope you have the controls.
Yes. I'll take care, sir. Don't worry.
Sorry about that. So we already know a lot about artificial intelligence. I believe this is what the STTP is trying to cover, right? And maybe one thing we all need to understand is the core definition of artificial intelligence, right? So with AI, we are trying to basically make computers, computer control robots, and any software which we have right now, and we are trying to make it think wisely. And thought process behind that is always that we are trying to make it work like humans, like as how maybe humans are intelligent, and the way we think, the way we act, right, that is the same level of intelligence we are trying to bring in computers, machines, robots, software around us. And thought process here is to make our life easier and better. So generally I'm given afternoon sessions to interact, and maybe I try to keep it interactive as much as possible. So I'm sharing a photo on my screen, right? Does anyone know this gentleman? If you know the answer, I would request you to maybe share the answer through chat window and get the bragging rights. And he's the person maybe who is attributed to the coining of term of artificial intelligence. A lot of you might already know him, and if you know the answer, maybe you can maybe get yourself bragging rights by entering the name in the chat window. So in the interest of time, I'm just moving forward. His name is John McCarthy, and he's also called as father of artificial intelligence, wherein he coined this term around 1956. And why I'm again citing his name here is we need to carefully understand how John defined artificial intelligence way back in 1956, almost 7-8 decades back, right? And what he said is artificial intelligence is science and engineering of making intelligent machines, especially intelligent computer programs. Can you believe this, right? I mean, it was just early days of computers, right? And we were not able to even realize full potential of computers. And this person, he was able to come up with this term, as well as again maybe come up with this unique definition which is still relevant now. If you look at artificial intelligence, basically there are 3 or 4 areas which are very important if we want to be successful. So as humans, we are able to sense, think, learn, and maybe individually we can take action based on sensing, thinking, and learning. So that is what we are trying to do using artificial intelligence. And that's where a lot of different foundational branches come into picture, as well as other branches of artificial intelligence come into picture, right? So if you see this schematic, what I'm showing on this slide, for sensing, we should be able to maybe hear, see, speak, right? And maybe as well as feel. So the image segmentation topic, what I'm going to talk about today, right? It comes under this section wherein we should be able to have some kind of machine vision or computer vision, wherein I'm able to look at the video or images and I'm able to find out maybe some kind of contextual information which is going to solve real world problem. And same thing we can go for thinking, wherein once we are able to collect the data, our AI based system should be able to have knowledge representation in place. We should be able to do reasoning, and for that we use machine learning and deep learning, right, wherein we create the knowledge base, and on the basis of the model what we are creating, we are able to solve some of the problems wherein we can act on some of that. So I'm going to talk about some of the specific models and algorithms in this talk, right, which is relevant for more importantly image segmentation and how it helps specifically in machine vision or computer vision as we call it. Again, one more important thing we all need to understand is the categories of artificial intelligence and the way these systems are being designed, and why image segmentation is important is something which we need to be looking at from this categories perspective. So if you look at this diagram, basically we have 4 quadrants here, right? And maybe we have certain factors using which certain systems will go in certain quadrant. So as you can see on top here, right, if we have no humans in the loop, we can have 2 types of artificial intelligence. One is called as automated intelligence, and second is called as autonomous intelligence. So thought process here is whatever AI system we are developing, it's not going to have any kind of human intervention involved. These systems can work on their own. So example of, say, suppose automated intelligence is maybe as a if I'm in a manufacturing industry and there is a robot which is required to do manufacturing, right? So what I could do is I can program that robot, right? And when I start the machine, the basis of on the basis of how I have maybe programmed that robot, it is going to automatically do everything what I've asked that robot to do. Similarly, the second category is wherein we need to have human as well as maybe artificial intelligence involved together. And that is where we have assisted intelligence and augmented intelligence. So what we are trying to do is we are having certain generalized problems, and these systems which are based on artificial intelligence can basically solve some of those problems for us using some of these specific models and algorithms, but they cannot work on their own. For the decision making or driving or using those systems, humans need to be involved. So there are a lot of examples for these assisted intelligence and augmented intelligence, wherein for assisted intelligence, right, you know Siri, Cortana, and various types of digital assistants. They help you, right, in terms of day to day. So if you're looking for something, they'll find information for you, right? But how you consume that information is still on you. Same is for augmented intelligence. This is something which we do all the time, use all the time, and wherein we are building certain regression models or predictive analytics model, using which we are able to maybe collate the data we already have and make some future predictions, which is there. And the most prime example here is the autonomous intelligence. So all of you know we have driverless cars. So these cars can work on their own, and how they're able to work on their own is they're able to maybe sense everything around it, and they're able to make those decisions on its own in terms of when the car is on the road, how it should be driven and things like that. And why it is important to understand this autonomous intelligence is when we go for image segmentation, we are trying to identify contextual information. So as humans, we are able to find the context, the semantics behind what we are seeing around us. And based on that, we are able to take decisions. Same thing is necessary, right, in terms of when we're utilizing any AI-based autonomous intelligence-based system, so that it can make decision on its own. And that's where image segmentation comes into picture. So let me go into more details one by one. So another trivia, I think, so that we keep it interactive, and a lot of you might know the gentleman in the photo. Does anyone recognize who is in the photo? If you know the answer, maybe please share it in the chat window, so that you can get another bragging right for yourself in a way, if you know this person. A lot of you must have watched him on television or maybe in movie theater, if I need to give it a guess. And this person is shown as a savior for our world, right? I mean, he is able to maybe save us from a lot of things which should not happen. So anyone knows Tony Stark, right? I see some answers from Vasudha. Anuja has also answered Iron Man. Yes. So that's a very good answer. So you guys know about him. Very good. So now what I want you to know is he's interacting with the system in this picture, and that system is called as Jarvis. And this is from his famous movie Iron Man, right? Does anyone know what Jarvis stands for? If you know the answer, right, get the bragging rights again. So this is a typical question, and why I'm bringing it up is if you know the answer, right, even what I'm trying to show here is even from movies and things what we see around us, right, we can get a lot of inspiration. And a lot of things what we see in these movies, right, they could become reality one day, right? That is something we need to keep in mind. So I don't see answers coming in chat. So in interest of time, right, I'll go ahead and get going with the answer. Someone said it's about his suit. Yes, suit is one part of Jarvis, but Jarvis stands for just a rather very intelligent system. So through his suit, he is able to interact with this system, as is being shown in the screen. So Tony Stark built this Jarvis system so that he can basically do everything, right, what he's trying to do as an Iron Man. And it's a very, very advanced computerized AI system wherein you can basically interact with that system. That system has a lot of data about him. If he's trying to maybe attack an enemy, he is able to take a lot of decisions more quickly, right? And that system is helping him, right, fight the enemies and things like that. So I'm giving this example here is we see a lot of such examples coming in our real world life, right? Maybe somewhere in movies, but slowly these systems become reality. A lot of you might not know, right? Maybe all of you use Facebook, right? And the Facebook CEO's name is Mark Zuckerberg. So even Mark was able to create a system like Jarvis in almost less than a month, and it could have almost all the features what we have seen in the movie, and he did it on his own and basically utilized a lot of open source solutions which are out there. So that is an inspiration for all of us, using which even we can develop some of these similar systems. And I hope this is what this STTP is about, wherein we are able to learn about artificial intelligence more and maybe implement a lot of those things in our real world use cases so that we are able to solve some of these problems. So I'll walk you through some of the real world problems which are relevant to my session today. So another trivia, a lot of you might have seen this logo somewhere. Anyone knows this logo? If you know the logo, I would expect an answer in the chat to keep it interactive. Google Lens, yes, very good, Vasudha. I think you are very interactive. Thanks for that. And I'm expecting others to interact as well. So Google Lens is an application which is developed by Google. And what basically they say is search what you see. So using this application, basically I can point my phone against anything what I see around me, right? And basically Google is going to tell me more information about it. So I was visiting US before this pandemic in 2020. I specifically remember I was there in February, and coincidentally I curtailed my trip and came back to India, right, considering the COVID threat. And when I was in US, this was my best buddy, right? I was able to use this app for solving many things around me, right? I can point this app against a building, right? And I could see all the information about that building. Or if I'm maybe looking at a menu, right, which I'm not able to understand, right? I was able to solve it possibly for my Japan visit in past and things like that. So basically using this app, we can translate. If you see something in Japanese, it can automatically translate it for you in English. We can also do some kind of smart text selection, wherein if you see something and you have more interest and you want to search about that on Google, you point your camera there and it's going to help you easily to do that search and things like that. And more importantly, I'm sure, as I'm showing on my screen, you are doing a Google search or something and you use Lens there, right? And if you find something which is of interest to you, right? In this case, I'm showing a sofa which you like. So you can select that sofa using Google Lens, and it's going to tell you from where you can buy that sofa online. Isn't it amazing, right? I mean, you can basically just do a selection with a simple maybe way, as I'm showing in this maybe interactive GIF schematic, right? And it's going to find that item online for you. And this is becoming bigger and better, right? So another example which is relevant to all the faculty members who are here is, it can basically help you do you or maybe your students even more better research, right? So as you see, if you're reading a book and you come across an equation which you're not completely clear about, so you can point your phone there and it's going to maybe help you search that equation online. It can point you to YouTube videos. It can point you to maybe some of the websites where you can find more information, some books where you'll find more information and things like that. So this is where the world is going as far as artificial intelligence and use of image segmentation and other things goes. One more trivia to keep it interactive again. And maybe Vasudha, I mean, this is again a question I hope you can answer. How many objects Google Lens can detect? Does anyone know this? If you know the answer, maybe I'll request you to use the chat window, right? And maybe give that as an answer. You can even go for some guesses as well. That's fine. And this tells us, right, how this technology is becoming more and more advanced. If you don't know the answer, simply say that, okay, you don't know the answer, but this answer might astonish all of you, right? So using Google Lens, as on today, basically you can detect more than billion objects. Can you imagine? They have already built a system which can detect more than billions of objects, and it's becoming even better and better. Okay, again, another example, these are again a lot of AI solutions which Google is developing. So again, when I'm trying to go through a country, right, where you see a speed sign or maybe a road sign which you're not able to understand, you can point your maybe phone and you can get the answer. So there are many use cases wherein AI is being used by Google. They have a dedicated website wherein they have got maybe a lot of open source tools which they themselves use at Google, and they provide inputs for that for others to use. And one of the great frameworks what they have to do this is TensorFlow. So you'll find a lot of resources if you go to ai.google here. Some more examples. Does anyone recognize this logo? If you know the answer, right, use the chat window again to get the bragging rights. You must have seen this somewhere.
Pinterest.
Yes. So this is again a very good software app which we use all the time, right? So kudos to you. And again, they have a lot of good features, right, which is around visual search, wherein, as I've showcased for Google Lens, we can even use this app, right, and maybe point it to some of the objects as I see, and it is going to help me find those objects online, and I can basically buy those objects. So there's something again which is an action which is being already used. And how this is possible is we can do image segmentation, and using which these applications are able to find that information for us. And basically these visual search capabilities are like based on many complex algorithms and models wherein we do image segmentation, image recognition, right? And from
some connectivity issues, sir.
So Amazon has a voice search capability as well as you can see, visual search capability. So maybe this is not launched in India yet, but any countries where you see this icon, instead of voice, you see a camera. So basically you can click on that camera icon and click a picture, and Amazon is going to tell you, right, if they have that product in their inventory. As you can see in this example, what I'm showing, basically I'm able to find out what kind of suit a person is wearing, what color it has, and things like that. And we'll see in a while, right, how this basically works. Again, we're able to detect objects like laptops and other things, or maybe some kind of bags if someone is having, right, and things like that. And using that image segmentation product available on Amazon. So this is something which is already in use. Again, at Delaplex, we have worked on, as I said, many such use cases. So one use case again is we have also built a visual search engine for retail products. So I'm sharing a link here. So you'll find a case study about that online, wherein this product is able to basically help you search anything what you like through an app. And maybe we have a marketplace through which curated marketplace you can buy some of those products through our client portal, or maybe other portals like Amazon, and we can go on. And this is something which is a great hit in terms of user adoptability and things like that. One more example here. Does anyone recognize the baby in the picture? Or maybe have you heard about the company, as you can see in the photo? If you know the answer, what this baby is called as, again, you can use the bragging rights for that. Okay. Are you all able to hear me?
Yes, sir. Yes, sir.
Zoom is frozen on me. That's why I'm just checking. Okay, so this baby is called as Baby X, and it has its own digital brain. And basically, there is a company by name Soul Machines, as I'm showing here. This digital baby has been created by Mark Sagar. He is the CEO of this company. And basically, the image what you see in the photo, it mimics his own baby. And what he has done is he's created a virtual baby with whom basically you can interact, as you can interact with as human babies around us. And this baby has a human brain. It can sense, learn, adapt, and communicate in a very, very interactive way. And basically, it is able to automate the animations as well. So if you interact with our baby, so they can have some kind of reactions. So this baby is able to even do that reaction for us. So I highly recommend you go and visit this website, Soul Machines. And here is the small schematic, right, how they have created that digital brain. And why I'm giving all these examples is, if this thing needs to work, right, that complete architecture what you're showing here, right, in this example, this needs to have proper computer vision in place. More importantly, image segmentation, using which we are able to find out contextual information which is important, and on the basis of that our system should react. Another example which I gave in my personal case as well as a student, right, where I said we can write automated code, right? And maybe that was something which was very difficult to do when I was a student. Now, things what you see around us, a lot of things are being maybe developed automatically by AI and ML based models. And I've shared a link here which is based on OpenCV. If you have not heard about OpenCV, I highly recommend you to go and check OpenCV, right? And using which basically you can write your own code as well. So let's jump into now the image segmentation aspects and why it is important. So I'm showing an image here, right? So maybe if I'm an expert doctor or maybe a radiologist, for me, if I look at this image, I'll be able to maybe find out what the abnormality is and maybe pinpoint that abnormality and maybe diagnose if there is some kind of tumor in my brain or something like that. But for normal humans like you and me, right, who don't understand some of these concepts, if I ask you to mark any abnormal regions as shown in this photo, and you need to do it manually on your own, so can you do that? It's going to be, the answer could be maybe, right? And maybe what kind of accuracy you might have.
Sir, not visible.
There's some internet issue that is in problem. He will join, don't you? Yeah. Spoke to him, he is joining, okay? Yes, please.
Okay, sir.
Okay, sorry about that. I hope there was a technical glitch on my side. So let me share my screen one more time. So please confirm if you're able to see my screen.
Yes, it is visible, sir. You can go ahead. No. Visible, sir.
Visible.
Hello.
Yes, give me a moment, sir. Yes. Okay, so I hope you can see the full screen, right? Just confirm one more time.
Yes, sir. Yes, sir.
Okay, thank you. So I was talking about the need for the assisted intelligence for medical imaging. So I'll continue from there. So I'm showing one more example here. So if you remember the previous image which I showcased, it's important that we are able to find out the abnormal regions, right, and maybe mark them correctly, so that if you're supposed to do a robotic surgery, right, or if you need to identify where the tumor is, this needs to work properly. So in this example, as you can see, we are able to mark where the tumor is, and maybe even we are able to do image segmentation, and that's where computers or artificial intelligence based systems could be even better to help us. Now, if we need to make this even more complicated, let's look at another example, right, wherein we have 3D images, as you can see. So in 2D, it was already difficult, but if we need to do the same thing in 3D, it could be even more difficult for humans like you and me. And that's where, if we need better accuracy, we can involve artificial intelligence based systems. So that's where image segmentation comes into picture, and we need to understand what image segmentation is. So at a high level, basically what we're trying to do here is we are taking the big image, a digital image, and try to maybe divide it into multiple segments. And this complete process of partitioning an image into multiple segments is called as image segmentation. And for that, what we do is we try to identify set of pixels who could be part of an image, and maybe we use that as an image object, right? So that this could basically work. So I have a power cut here. I'm not sure, it looks like a typical day. It generally never happens. I hope you're able to still hear me. Atik sir?
Yes, sir, you are audible.
Yes, sir.
Right. So sorry about that. So again, the goal of segmentation here is we need to basically simplify the image recognition and computer vision part so that we can get the contextual and meaningful information out of that. So what we are trying to do is we are trying to locate different objects, and we are trying to identify those objects through things like their own boundaries, using their lines or curves around those objects. And in the specific image, those things could be maybe marked as different objects and things like that. So once the image segmentation is done, basically the bigger image what we have, that could be divided into multiple objects, and every object could be detected from the original image. And for that, we use various characteristics for those objects. So it could be like maybe its color, its intensity, its texture, and things like that. And basically what we are trying to do is we are trying to do some kind of edge detection so that this could work properly. So I'll show you visually so that we are able to understand this. So in this example, if you see maybe a human bone, right? And this is for left human femur, which is off your hand. So in this image, if I need to do segmentation, so basically it has three bigger parts, right? So first part is we have the outer surface, which is shown in red. Again, you can have a surface in between the compact bone and spongy bone, which is shown in little green. And then we have the surface of bone marrow, which is every bone has some kind of bone marrow, which is shown in dark blue here. So this is what image segmentation does. We are able to identify different objects in bigger objects which are out there. So another example. So this is an example of brain's image segmentation, wherein we can look at the various objects inside your brain, and anything what you see which is not normal, those things could be segmented properly, as is being shown in this case. So different colors what you see, that basically denote the different objects which we are able to detect inside the brain. And anything which is not normal according to your knowledge base, that gets marked so that we know this is not normal, and we are able to maybe look at it as a tumor and maybe do further action as a surgery and things like that. So when we do this image segmentation, it involves a lot of different things, like based on what organ we are trying to do segmentation on, we need to do tissue classes, what kind of organ it is, right? And maybe we need to also look at various biological and pathological structures into mind. And this really helps us in doing better surgery planning, simulation planning, or maybe if you are doing a robotic surgery, we are able to do intra-surgery navigation, which really helps the doctor to carry out the surgery in a better way. So another example here is, this is a human retina, wherein we can look at the retina, and there are various diseases which can be there related to eye, like glaucoma and other things. So that is something, again, it can be detected using image segmentation. So as you can see here, right, we can see various veins which we have in our eyes and things like that. So if anything is abnormal here, we are able to basically detect that using image segmentation. So again, at a high level in image segmentation, we are trying to basically do a better diagnosis. And thought process here is, once we do a better diagnosis, we identify what the real issue is, we'll be able to come up with right treatment, right cure. And more importantly, when we are doing these investigations, they are not going to be invasive in nature. We are just clicking some photos, so it's not going to have that harmful effect on human body. And more importantly, with the help of computer vision technologies like artificial intelligence, machine learning, and deep learning, we're basically able to identify 3D and 4D information which is going to be difficult for humans to understand, and maybe use that information to carry out maybe robotic surgeries and things like that. So in nutshell, using image segmentation, we are able to see inside patient's body without to cut them open. This was something which was not possible in past. Basically, if we need to do an operation on someone, they used to first cut that part, look at what is inside, and then take a decision. Right now, using this medical imaging and image segmentation, we are able to look at a lot of these finer details ahead of time, and we are able to make a better clinical decision in terms of a surgery is needed or not needed and things like that. And again, more importantly, using this medical imaging solution and image segmentation, we are able to even save a lot of high medical cost as well, wherein if the surgery is not required, we are able to find that beforehand using image segmentation to make a better informed decision. And this is something which we have also noticed during pandemic. All of you must have heard about HRCT scans. Even personally, in my case, some of my family members, they were infected with COVID or coronavirus, and their COVID tests were negative, but they were having other symptoms. And the tests were just not negative once, twice, thrice, right? They were negative multiple times. And only way to find out if they have infection was or not, we need to do HRCT scans. And as you know, these HRCT scans, right, give you a real picture inside your lungs in terms of if you have some kind of infection in your body or there is no infection in your body and things like that. And that's why this image segmentation has been a savior for a lot of people during even corona time as well. So as you can see in this image, this basically shows you a 3D CT scan of your chest, wherein you can see basically all the different parts, including your lungs, thorax, and other parts. So here we are able to see basically various features like what's the volume, what's the intensity and homogeneity inside, right, which is important for detecting issues like corona and other diseases which could impact your lungs and other places. So that's where image segmentation is really helpful. So at a high level, when we do image segmentation, there are various stages. So if you look at this schematic, this is going to tell you where image segmentation comes into picture in the complete architecture if we develop any system. So as you all know, initially we need to start with image acquisition, wherein you should have, say, suppose a camera in place using which you are acquiring the image, right? Or maybe radio imaging software using which you are able to acquire the image. And once the image acquisition is done, you do some kind of pre-processing on those images. If something is not relevant to you, you remove those images and things like that. So that is something which happens at the first step. Once you have a digital image which is already pre-processed, and you submit that to that for doing intermediate level processing, and wherein we have the concept of image segmentation which comes into picture. And this is where what we try and do is we try to identify different objects within that image, and we try to segregate them using different image segmentation algorithms and models. So I'm just going to come to that in a while, in a way, how this works, how we do it, right, and things like that. And once this segmentation is done, we do representation and description of these different objects which are already segmented also try to identify certain contextual information which is going to be helpful for us. So going back to the example of human brain where I showed if you have a tumor or not, and if you're able to mark that tumor in that brain, so you basically tell where the tumor is, how big the tumor is, what's the size, what's the location, and things like that. And all that information is basically stored in your knowledge base so that your model can maybe work properly. And once that is done, you need to have some kind of recognition and interpretation engine, which is going to basically help you as human and provide assisted intelligence which is needed. So maybe if I need to give you end-to-end example, you just give the human brain image at the start, then that human brain image is segmented in the intermediate level processing. And when you have the recognition and interpretation done, you basically get an output wherein you come to know that you have a tumor in the brain of the patient whose image is being submitted to investigation here. So this is the process at a high level wherein we do image segmentation to recognize different objects. And I'm giving a very, very peculiar example of doing this in medical imaging. So there are a variety of image segmentation methods. They're just not applicable to just medical images, but other images as well. So here I'm showing the classification of that. So at high level, basically you can say there could be 4 methods, algorithms or models. So first method is called as region-based method. Second is clustering methods, which is more towards heuristic AI ML based technologies. And again, third category is classifier method, which is again based on your heuristic methods, AI ML based methods. And fourth is we use hybrid methods, which are combination of other technologies so that we can do image segmentation better. So let's look at all these algorithms and models one by one. So let's start with region-based methods first. So here is an example of region-based method, wherein if you look at the images below, basically you have 2 approaches. If you look at the region-based methods, one is called as thresholding, and second one is called as region growing. So I have given more details one by one about all of these. So in simplest term, what a region-based method is, basically you look at an image and you try to identify an image which is homogeneous in nature, object in an image which is homogeneous in nature. So example could be if you have a photo as you're seeing on in the case of thresholding on the left side. So you see that 2 prominent objects which are being shown there, and they have their gray levels or texture maybe different than the other image part which is there. So what we try to do is, using this information, we try to create certain regions within that image so that we identify a group of connected pixels with similar value. Okay, and we are able to identify if that pixel is part of that object or not. So, and that's how that segmentation method works, wherein we try to identify the boundary of that object so that we can identify that object or a region. And for that, we use 2 techniques. One is thresholding technique and region growing technique. So I see some background noise. I'm requesting everyone to be on mute, please. Soumitra Saha, if you're able to hear me, please mute yourself.
I'll take care, sir. You continue.
Yeah, so in thresholding, what happens is basically it's one of the simplest and fastest segmentation method, wherein what we do is you take an image and you try to look at their gray level to identify different regions or objects within that. So the simplest way is what you do is you look at the histogram of that image, as you can see in this example, and through that intensity of that histogram, you're able to find out if an object is in foreground or is in background. And if you see a peak, as you can see in this case, right? So you identify that peak where that threshold is. And around that threshold value, we are able to maybe identify the object. So using this histogram, we are able to maybe divide the image, right, with say maybe a foreground object or a background object. And that is what is shown here. So if you have a city image and we create a uh, histogram of that. So we basically try to identify a threshold. So as you can see in this example, there is a dotted line in the graph. So that dotted line basically shows us the threshold. So think to that dotted line which is on the left is basically our object of interest, and anything which is on the right, possibilities of our interest, but it is not that prominent. So we try to divide every pixel as foreground and background based on that threshold, which is the dotted line as you are seeing here. So as you can see, this function is very simple, g of xy, and anything which is in foreground, wherein that threshold value should be greater than the t, as you see in the dotted line, and anything which is less than that t is going to be in the background function. And based on the basis of that, we identify the intensity, position of all the relevant pixels, and we are able to basically divide the image into two parts, foreground and background, and basically detect those objects. Again, to identify the gray levels and identify these thresholds, we can also have something called as multi-thresholding. Right now in this example, we only have two types of intensities. So it works really well, but if you have multiple intensities, so in that case, we may need to have multiple thresholds so that we can identify different threshold values and different objects using that. So one example of this is local thresholding. So again, I'm giving a link. I hope all of you must have heard a very good site called as Kaggle. So if you have not heard about Kaggle, I request all of you to visit Kaggle. And basically what Kaggle provides you is all the source code, the platform need what you have for developing your AI ML based projects and models, and it also gives you the data what you need to run your models. So in this case, the link what I'm showing here, right, it basically has a notebook, right, wherein you can basically look how local thresholding works using the relevant algorithm, and the complete source code is also provided. So in interest of time, I'm not going into all the individual examples, but at a high level, once you visit these links, you'll get all the source code, you'll get all the data, and you'll also see the working model, and basically you can actually play with that. So again, local thresholding. So in this, what we try to do is, if we have a different areas or different images, so we try to divide that image into sub images, right? And for that particular image what we have, we try to identify a local threshold. So if I have a bigger image with multiple intensities, as I showed in the previous graph, we'll try to create smaller images of the bigger image, and again we'll try to identify maybe some kind of threshold around that. And that is what is called as local thresholding, so that we are able to maybe do um, identification of different regions and objects on the basis of background and foreground objects, and apply interpolation techniques so that we get better results and maybe get those more quickly. And again, we can use various statistical methods so that we are able to maybe predict the threshold value, right, for each sub image, using techniques like standard deviation, mean and standard deviation together, right? So that we can get the proper threshold value, which helps us in getting those objects identified more quickly. Again, this technique has one limitation. This technique of local thresholding, we need to do segmentation of all the images, and maybe once we do that segmentation, we need to do comparison between my local threshold as well as global threshold value, and keep doing that till the time I'm not able to see a lot of variance. And it could only work properly in case where I have images wherein with varying background, right? If I have complicated histogram, this image is not going to work very efficiently. So this is about local thresholding. Second algorithm is it's called as obtuse thresholding, and again this method is something which is used for identifying the optimal value of the global threshold, so that I'm able to maybe get the different objects identified in my image. So again, what you do here is you look at the histogram of your image, and you try to minimize the interclass variance of maybe between two objects. That is what our maybe objective function here is. So what you try to do is, if I have an image, so it has, say, suppose certain black pixels and certain white pixels. So I'll select pixels in a way that the class variance between the pixels what I'm selecting from black region and the white region should be minimum, and I'm able to identify the objects using this technique. So basically, you apply your objective function in a way that interclass variance should be minimal, and you are able to identify a foreground as well as background object within the same image. And using the objective function of minimizing the intra-class variance, we identify those objects. Again, I have given a Kaggle notebook here, wherein we can actually see how Otsu's thresholding and segmentation work. So you'll see the complete source code, relevant data, right? And you can actually see this in action there. Next technique is region growing. Again, this is an interesting technique wherein what you do is you have something called as you can see in the image on the right, we have something called as seed pixel. So what you do is that seed pixel or seed point, you try to select it maybe from a region which is going to give you the object what you're looking for. And you try to keep looking for the neighboring pixels till the time you don't find maybe a pixel value which is having value different than what you already have. So if you look at this image carefully, right, our job is to identify all the pixels which are black, and maybe as soon as we are done identifying those black pixels and anything which is touching white, we are able to ignore and maybe stop there. And that is what this region growing technique is about. We start with a seed point, keep looking for surrounding pixels one by one till the time we are able to identify the objects here. So I'm also showing a very simple algorithm how it works. In a way, we are starting with our seed point. You give that as an input. So you start with the seed point in the region, and you keep looking for your neighbors till the time the neighbors are not part of the same object with the same pixel intensity. And you keep doing that, and you keep creating your object, right, which is going to be having the same value. So this is again a very good technique wherein you get better results if you're able to identify a good seed point. Again, I'm giving a Kaggle notebook link here wherein it shows how 3D region growing flood fill algorithm works, as I'm showing in my example on the slide here, wherein you're able to identify a specific region and the object using this region growing methods. So far we have seen region-based methods. So in that we have seen how thresholding works. So in thresholding, we had local thresholding as well as global or Otsu's thresholding. We have also seen region growing using the seed point method. Now slowly we'll move towards the clustering methods. Okay, so let's look at the different types of clustering and classification methods. So first example here is we have different types of models or methods which can be act as a classifier or pattern recognition methods. And again, in this, we use supervised learning techniques, wherein what you do is once you build your model, you need to train it initially. And maybe once you have done with the training, that model can work on its own and it could follow an automatic process. So it's very, very important in this classification methods. You create a model, and that model, once it is created, you need to have a training data which is going to help train your model to do the classification and image segmentation. And once that is done using the proper features and labels, it is able to work on its own. So there are many classification methods which are prominently used, but two of them are very famous. There are a lot of variations of these two methods. So first is called as K nearest neighbor, or we call it as KNN, and second is maximum likelihood method. So we'll slowly look into the KNN and maximum likelihood method. So again, what we need to keep in mind is this classification methods, they do have some disadvantages. These methods at times are not able to consider special information. So what special information means is you have an image which is a digital image, but if you have additional information about that image, So that information cannot be considered. So example of this could be, say, suppose you all know GIS or maps based information, wherein we can have a lot of layers on top of our existing image. So that kind of information cannot be inputted to such classification methods, and they don't work accurately on that. Another problem is their accuracy is going to be subjective to our training data. So if our training data of doing image segmentation is really good and the accuracy is really good and our training is good, so these techniques are going to work really well after the training is over. If that is not the case, the segmentation sample data is not right, they are not going to be maybe working as accurately as they should be. So let's go into both the techniques one by one. So first is KNN method. So this is again a classification method. So if you look at the diagram on the right side, what basically we are trying to do is we're looking at different pixels within the image, and we are trying to classify them into different classes. That is what at high level it is, right? So as you can see in this image, you see plus, minus, and question mark. So anything which is in plus, it belongs to class 1. Anything which is in minus belongs to class 2. And anywhere you have question mark, right, we're trying to determine it's going to be in class plus, class 1, or maybe it's going to go in class minus. That is what at high level we try to do in K nearest neighbor or KNN based classification method. So what we do here is we start initially wherein we create a large sample data, which is called as labeled data or a training data, and we subject our model or algorithm to do that classification. So in the training part, we tell our model, right, okay, this particular pixel belongs to class 1 and this particular pixel belongs to class 2. And based on that, we keep on refining our model, keep on training our model, using which it is able to do the classification for us. And I'm again giving a Kaggle link here, wherein you are able to use KNN algorithm to do step-by-step diabetes classification. So depending upon certain input parameters for each patient, we are basically able to maybe classify if the person is having one kind of disease or other kind of disease or something like that. So there is an good explanation for KNN there. Okay, second category is called as maximum likelihood. And again, what we are trying to do here is KNN has a lot of limitations. If we are not able to train it initially properly, the training data is not right, it's not going to work properly once it is put to use. And if you have a lot of data which needs to be subjected, it's not going to work. And that's where we try to use maximum likelihood model, which is based on the statistical modeling concepts, wherein what we try to do is we try to do some kind of best estimation using the sample data what we have, using which we can generate some kind of nearest data model, wherein we are able to find out if a pixel is being divided, right, from one class to the other class. Instead of doing it randomly or through our training method, we try to apply statistical model and maybe try to make better prediction about that, so that the run rate of my model is better and I'm able to classify that properly. Again, we have a lot of advantages if you use this method. It can be basically deployed for a wide range of situations, unlike KNN. And again, we are able to look at the normal distribution and sample variances, which we can look at the image histogram, and we're able to basically do that in a better way. Only difficulty here is, again, we need to ensure that our starting value of this algorithm or model needs to be accurate. If it is into an outlier case, this will not work. Again, there is one disadvantage of this method is it cannot be applied for small sample of data. It doesn't work really well in that case. For that, KNN is better suited. Wherein if you have large volume of data, maximum likelihood is basically a better algorithm to maybe use with some small training data initially, and after that we can go for the actual results. Again, here I'm sharing one Kaggle link, wherein you can basically look at various heart images, and by looking at those heart images, we are able to classify whether the person has heart disease or he doesn't have a heart disease. So basically you will get all the training data, sample data, how this complete model works, and how that classification happens once you visit this link. Okay, so moving on, next method is clustering method. So again, clustering, unlike classification method, is unsupervised method wherein you don't need to do training, because at times if your training is not right, your model is not going to work. And that's where clustering methods are more prominently used and found more mainstream usage, and their accuracy is also better. So again, the simple idea behind clustering method is we try to do segmentation or partition of our image into some kind of coherent regions. So when we say coherent regions, so we have seen the previous algorithms or methods where we are trying to identify things which are matching with each other. So we look at the pixel intensities, and based on that we try to identify different coherent regions which could be part of the same object. And for that we apply clustering procedure, so that the segmentation could be done by extracting some of the global characteristics at the original image level, but at the same time we are able to separate the regions of interest from our background, right, by applying the segmentation and partitioning and clustering methods what we have. And again, what we do here is our classification technique works in a way wherein we are trying to use our clustering to divide our images into coherent regions. So there are three prominent algorithms or models which come into picture. First is k-means, second is fuzzy c-mean, and third is expectation maximization. And again, for all these methods, a lot of variations which a lot of researchers have come up with to improve the accuracy. Again, these clustering methods are more efficient as compared to the previous methods like classification method, because you don't require to prepare any sample data. You don't need to do any kind of training initially. On the other hand, these methods, these algorithms are also able to consider any special information, right, which could be useful, including the other information which is going to be helping them to identify different coherent regions. Only difficulty here is these methods could be sensitive to noise and intensity issues in homogeneities. So I'll show that with an example in my next slide. So if you look at the k-means clustering algorithm, how it works is basically you use maybe different sections of your image, you divide that. So what you do is basically in your image you give input as k, and you start with a value, right, which is random in nature. So say suppose my k value is 5. So in my input space we try to randomly identify those k points, and we try to create some kind of cluster around those k points, and we see based on the next pixel which I'm seeing in my model whether it should be part of one of those 5 clusters or k clusters which we already have. So how you do that is basically you try to compute the distance between the current pixel and the nearest k class which is close to it. So if we find a minimum distance of the current pixel with one of the closest clusters which are there, we put that pixel in that cluster which is close to the pixel which is there. So here in this example, as you can see, I'm showing how k-means is being applied to MRI of knee bone, wherein you start with maybe different random points, and after that you keep on doing classification, and once that classification is done, you are able to identify different objects. So here in this knee bone, we are able to identify the different objects inside that knee bone which is there. So again, what we try to do here is when we are calculating the positions or points which I need to consider, we try to optimize those values for the cluster, and we try to minimize the errors which are there. And for that, we try to look at the distance, right? And for that, we have the objective function which helps us in minimizing the errors. And we are able to identify the pixel point getting into a part of a cluster which is the closest. Again, there's some disadvantages to this algorithm. If I don't select a proper key value to segment my image, it might not function properly and the accuracy might go down. Again, this could be sensitive to outliers, noises, and initial values. So if there is a pixel which is not fitting into any clusters what I've created, that could cause my algorithm to not work properly. So that's why it's important to identify any noises or outliers before I get into maybe applying k-means cluster. Again, I have given a link here wherein how image segmentation using k-means clustering can be done along with the complete source code, so that you can maybe do this live on your own and maybe apply k-means clustering for doing image segmentation. So here is an example, live example of k-means clustering. So if you see the image on the left, that has different objects, and these are like basically different kinds of fruits, as you can see, or maybe vegetables. And I mean, our job is to apply this k-means clustering and identify those objects. So there could be various ways. So first way is if I need to do clustering on intensity. So if I do apply that, so I can cluster the objects together who have similar intensity, and I can do image segmentation on that. Second category would be I can do clustering on colors. So if certain objects have same colors, they can become part of the same cluster. So as you can see on the image on right, you can see green cluster, red cluster, and somewhat white cluster, right, or maybe light green cluster. What can be applied? So that is how k-means clustering works, wherein we are able to do image segmentation based on the intensity as well as the color value which is there. Next category here is fuzzy c-means clustering. So as you know, we have some limitations in the previous method. So what we try to do is we try to maybe optimize our model and algorithm so that we can get better results here. So what we do in this case is, again, it's an unsupervised algorithm wherein we try to do clustering and bring in a group of data in same clusters. But what we do here differently is we are trying to maybe identify clusters which are going to be formed, using which in a way we are going to maybe effectively apply our classification or clustering in a maybe more simpler way, and we are trying to minimize the results of corrupted images or objects which are of not interest to us. Again, this is again a very significant method which is used for MRI image analysis, and this works effectively, right, if we use results or effects which are maybe better as compared to the previous method what we have seen. So I have also given a Kaggle notebook here, wherein you can basically apply fuzzy c-means clustering on iris dataset. So if you have iris images and you want to categorize those iris images based on certain kind of disease, right? So this fuzzy c-means clustering has been applied in this example, and we can basically do that. Third category is expectation maximization. Again, this is an example of unsupervised learning model. Again, one of the important differentiators here is it's an iterative process wherein we try to do maximum likelihood estimation, and we apply statistical thinking behind when we are trying to do the classification and clustering in our case. So again, this is very popular method. We use density estimation of data pixels. So we look at different pixel value, what their density value is, and we try to divide them into different classes. So basically it has two steps which run iteratively to get the desired results. So first step is called as E step, in which we try to calculate the expectation of likelihood. And the second step is called as M step, wherein we try to calculate the maximum likelihood estimation. So basically what we do in these two steps is, in the E step, we try to identify if there is a pixel which is going to be found in the next step. And we try to identify that, and we try to maximize the likelihood of that getting included in some of the clusters which have been already created. So we need to have a proper seed point so that we are able to get the desired results by applying the relevant objective function. And we keep on doing these iterations through various steps till the time we are able to minimize our mistakes and decrease our execution time, and maybe do the classification of all the pixels and identify all the objects. Again, I'm giving a Kaggle link here, using which we are able to do application of expectation maximization, and you could see in action how it actually works. So far we have seen region-based methods, then again clustering methods, as well as classifier methods. Now there is the fourth category, which is called as hybrid methods. So if you look at hybrid methods, basically what we try and do here is it tries to use combination of the prior three methods what we have seen. So example could be, we can use two models or two algorithms together, right? So we can basically use region growing, right, and region merging together, and we could get better results. And these hybrid methods kind of give us those region of interest and boundaries more quickly. So again, in these methods, we try to look at boundary and regional information to segment the image. And what we notice is the results of these hybrid methods are better as compared to those individual algorithms or method which are already being discussed in the previous slides. So there are various examples. So one of the example is called as graph cut segmentation, which is a combination of region merging technique, and this gives us better results for medical image segmentation. So what you do here is you start by applying this algorithm or model, wherein you try to identify different objects in foreground and background, and you try to choose the seed point for region growing, identify a region or object like that. And from other side, you identify the boundary of that object or region, and then you try to maybe again identify what is there in foreground or what is there in background. So these hybrid methods give us better accuracy, right? So let's look at the graph cut segmentation method, right? So in this method, as I already said, right, we're trying to divide our image into two parts: the objects, which is of our interest, what we're trying to identify through segmentation, and certain background information which is not of our use. So again, what we do here is we apply the seed point as we have seen in the previous methods, and we try to find out the object, and maybe those objects should have the same pixel values. And using those pixel values, we are able to identify they're part of the same objects. And anything which doesn't have the same intensity or same pixel value, we consider them to be part of the background, and that can be simply ignored when we go for the segmentation. Again, this method uses minimum cut algorithm, wherein we try to divide our original image into multiple segments, and in that segment we again apply the same logic. So this is something which is more iterative in nature, and this gives us optimum results, wherein we are able to cut our original image and apply the same logic in the multiple image segments, and maybe do it more quickly and identify the objects which we are trying to do. Again, here I have given a link using which you can basically look how graph cut based image segmentation works. Even there is an interactive example, you can actually play with it. You have all the source code available, including the data set using which you can actually see how this method works. So far we have seen AI ML based heuristic algorithms and models. Now let's look at some of the deep learning based techniques for doing image segmentation. And as you all know, maybe neural networks have been in place for several years, but we always had limitations, and these neural networks and models were not that efficient. But around 2000, we have seen a lot of improvement in hardware, wherein these deep learning approaches, previously they used to take a lot of time to do processing. but after we had improved hardware, including GPUs, these become more promising and they were able to solve a lot of real world problems. More importantly, image segmentation in the field of biomedical image segmentation. So here you'll see a lot of variations, a lot of different types of deep learning techniques. So I'm going to talk about some of them here, how they work and maybe how they're basically applied in solving the image segmentation problem. So starting with convolution neural network. So again, this is a specific type of neural network which basically consists of multiple layers inside the neural network, right? And each layer basically performs a specific type of operation. So we have different types of operations. So first operation is called as convolution, second is called as pooling, and third is called as loss calculation. So basically, what we try to do in these each operations is something which is very important to understand, and this really helps the image segmentation to work in a better way. So what we do here is we have multiple layers. So in every intermediate layer, we try to give output of the previous layer as input, and that's why these CNN based network models are giving us better accuracy and better results as far as image segmentation is concerned. So what we do is in these CNN models, we take the original image. That original image is divided into multiple segments, and those segments are given as input to our convolution neural network. And what CNN does is the CNN is able to maybe basically label the pixels, and based on that, we are able to look at the whole image at once, but at the same time, we are able to divide it into multiple segments by applying the scanning. And once the scanning is being done through multiple layers, what we have, we can filter certain pixels which belong to one particular object and maybe bring that object together and maybe look at such objects by applying multiple uh, uh, pooling and loss calculations concepts of convolutions what we have. So I've given here two examples wherein you have how CNN works using PyTorch, which is one of the prominent Python frameworks. And second example, again, I've given another tutorial wherein how to build a CNN using Python. So both these links have the source code and other details available. But if you look at the concept of the convolution neural networks, so as I was explaining earlier, right? So you have this bigger image, which is an input image in this case. So we try to divide that into multiple segments, as you can see here, and again apply different layers and try to identify those objects using different convolutions. And once one convolution is done, you give that as an input to the next layer, and we apply concept of pooling. So as you can see, we have first divided our pixels or pools into 2 by 2 matrix. Similarly, we can make it 3 by 3, 4 by 4, right? And based on that, we can see basically if that object is matching, right? And we're able to identify the object what we are looking for. So in this case, the image on the bottom, what I'm trying to do is I'm trying to identify this yacht, and maybe in that yacht, if there are different objects which are of my interest, right? Maybe a helicopter which is on top of yacht. So what I'll try and do is I'll try and divide that into different convolution layers using pixels, and then I'll apply pooling, and maybe I'll keep on doing that through fully connected CNN network what I have till the time I'm able to maybe divide my original image into different objects. So instead of shapes, assume we have an image wherein I have in a single picture, I have a dog, I have a cat, right? Maybe a goat or a bird. So what it would do is it's going to maybe identify those objects through me, for me through these different layers what we have. So it's a very prominent technique which is used everywhere, and it has good accuracy as far as image segmentation goes. The next category is fully convolution network, which is called as FCN. So we do have some limitations, right, in the previous method in convolution neural network. So FCN tries to cover that, because what we noticed is in the previous method, we can only give input of next layer to the previous layer, right? Output of the next layer to output of the previous layer to the next layer in the convolution neural network. But in fully convolution neural network, we can basically go back to even my older maybe networks or layers, so that I can get better performance. Because if I'm not able to do proper segmentation, I may need to restart and maybe do better localization if this needs to work. So CNN is better suited for I would say 2D images, but FCN is something which can give us even better accuracy, just not for 2D images, even 3D images, because we have the complete fully convolution layer, right, using which we can get connected to the previous layers and maybe correct ourselves if something is not working. So again, this improvement of FCN which we have, right, we are able to do predictions from full size image instead of patch wise prediction, which was in case of the convolution neural network CNN based method, wherein we used to divide the image into different parts. Here we are able to take the full image and still able to find the different segments in that. So this is something which is a huge advantage as compared to the previous CNN method. Again, I have given a Kaggle link here. So if you go to this Kaggle link, you'll actually see how semantic segmentation works using fully convolution neural network, and we are able to identify different objects. So here is an example. So in this case, you can see there is a cat, and maybe possibly there are two cats in this image. So I should be able to identify those two cats from that image, right? And I should be able to do that, right, using maybe foreground, background, the color of cat and things like that. So that's how this FCN works, right? So you give the input image and you take the complete image. And while you're taking that complete image, you can still apply the concept of pooling, right? And maybe proper feedback using the matrix, using which you are able to get the different objects within the same image. So one major difference here is we are having the connections to the older layers what I have, right? The prior layers what I have in the fully convolution network, which helps me in doing the segmentation better. Next is unit. Again, this is a further improvement as compared to CNN and FCN, as we have seen. Unit is something which has got even better accuracy as compared to FCN. And what we have seen is one difference between CNN and FCN was maybe we can only go back to one layer, right? Or maybe give some kind of output as input to one of the old layers. So in unit, what they have done is these authors, they are basically able to connect end to end, right? And we are going to have maybe multiple fully convolution networks which can be talking to each other. So we can have multiple layers, and at the same time these layers can maybe give input and output to each other. So this makes the job even more better, wherein we are able to basically do the image segmentation more quickly, at the same time with better accuracy. So in this unit architecture, we have two parts. First is called as encoder and second is called as decoder. So in the encoder, we are trying to basically identify maybe objects within our original image, and once those objects are marked and identified, then we try to do classification and identification of those objects in terms of what those are and things like that. So this is completely a new way which is being followed by everyone for image segmentation, and this gives us the best accuracy what we need. So I've given here 3 links, including a Kaggle link where you'll get the uh, complete source code in terms of how this unit model could work. So as you can see, there are two layers, as I said, encoder and decoder. So on the left hand side, you have the encoder logic in this image, and on the right hand side, you have the decoder logic. So you initially take your input image, which is a big tile, and you try to divide that image into multiple tiles. So say suppose my original image size, as you can see here, is 572 by 572. So what I'll try and do is I'll try to keep dividing it into multiple image tiles, and I'll keep on doing it till the time I'm not able to find the object of my interest in one of those tiles. And we keep on applying convolution. We try to give feedback, right, from one layer to the other layer, right, and this keeps working so that we are able to get better accuracy. And this is also possible using the computing power of GPUs which are available now. So far we have seen CNN, FCN, UNet. Now one more extension to the previous model, it's called as CRN, convolutional residual networks. So as you can see in the flow chart here, so what we can do basically here is we can have a feedback loop from my convolution layer to previous convolution layer. So again, this is not something which you do randomly as we have in the previous cases. Here it's a constant loop wherein we are giving the residual feedback, right, all the time. So this is one of the biggest advantages wherein we get the best accuracy using CRM. So again, in what we do here is in residual maps, we skip some of the connections, and basically we can redirect our network to certain derivatives or certain specific layers wherein we could get the outcome what we are looking for. So this specific design of CRM basically gives us better accuracy as compared to even the previous methods which are out there. So I have also shared a Kaggle link here wherein we have a specific type of CRN. It's called as ResNet. Even companies like Google, right, they use ResNet for doing image segmentation and image recognition. So in this example, you'll see the source code using Keras and how this CRN works for doing image segmentation. Okay, so so far we have seen all the other methods. So one last method, which is the most promising method and which is being now used with close to 100% accuracy, it's called as RNN. And the RNN stands for recurrent neural network. And this is something which has basically in this model, we have been empowered, right, wherein we can have recurrent connections, wherein basically these networks are able to memorize the patterns from last inputs. And that's where the real magic is, wherein these networks are able to understand and learn patterns from the previous inputs what they're getting, and they're able to maybe use that memorized patterns or learnings as inputs to my next layer and maybe do the image segmentation in a better way. So this really works really well in terms of identifying regions of interest properly from medical images, which could be in multiple slices, especially in cases like MRI scans, CT scans, right, which are two-dimensional, three-dimensional, at times four-dimensional, wherein we have multiple slices. And if we don't have RNNs, maybe evaluating or maybe doing segmentation on those slices could be very, very difficult with the accuracy. So these RNNs are able to extract interslice context in terms of if I'm having my heart image, right, and it has been sliced, and I'll be able to correlate one slice in one dimension with another slice in another dimension. And maybe I can do extraction of interslice information from multiple images. And maybe for that, again, I can use a combination of CNN and RNN for maintaining that interslice extraction of information. And I can get even better results. And this is something again which is very prominently used in industry to solve many difficult problems. So companies like Google, Microsoft, and others, they have also come up with, apart from us researchers, they have also come up with various versions of RNNs. So some of the famous RNN models are LSTM and GRU, gated recurrent unit. So you can go and read about it more online. So these methods are again something which everyone is using all the time. But these recurrent neural networks are also being used for doing predictive analytics. So I've given one example here, right? So you see a lot of people are able to predict, right, that there is going to be maybe a third wave of COVID and things like that. So how they're able to do that is using the prior data what we have, we are able to maybe even make those predictions better and things like that. And that is all based on RNNs. So a lot of predictive analytics and prescriptive analytics, what we do in real world business use cases, that also utilizes RNNs in most cases. Okay, so here is the schematic in a way how this works. So as you can see on the left, these are different slices of my heart. In this case, these are different images what you have. So these are taken in different, maybe different versions of my slices what we have, right? So you subject that to your RNN network, right, as an input, and that RNN again divides that RNN network again divides that into maybe smaller objects, as you can see in this diagram, right? And you keep on doing it till the time you don't get the object of interest as an outcome on the right hand side. And as you can see, there is a feedback loop here in the yellow, right, which is the RNN. So you basically have in these layers you have convolutions happening. Once the convolution is done, you do pooling in between, and you basically keep sharing the data from previous layers to the next layer, and you're able to memorize what is coming out. So there again, as I said, variety of versions of RNN models which are out there. So in this example, basically, we are trying to identify if the person is having some kind of blockage in their heart, right, using different segmentations and slices, as you can see. And this has better accuracy. Even I've given a paper here, right, wherein using this research paper, the researchers have demonstrated how RNNs are able to accurately find out if someone is having some kind of heart blockage using the image segmentation techniques. So those are most of the algorithms and models which are very prominently used. There is a lot of research going on. So through this forum of STTP, I highly request all of you to go through all the links which I've shared, download the source code, right, and experiment yourself, right, some of those things, so that you can apply these image segmentation techniques to solve real world problems. And again, image segmentation really helps in recognizing some of the scanned images, what as humans we might not be able to maybe pinpoint where we have the actual tumor or actual issue, right? So this really helps in doing the effective treatment. And this techniques would be useful for a variety of medical image segmentations, as I already said, X-ray, sonography, magnetic resonance imaging, CT scans, and many more. And if we are able to do these image segmentations using these assisted intelligence or augmented intelligence algorithms, models, and techniques which I described, this is going to make a doctor's job really easier. And this is something which is already happening. So I'm going to show you some examples so that we can correlate to what we just discussed so far. So I'm showing some examples here. So as you can see here, right, here is an example of cancer classification. So what you'll do is you'll give certain images as input to some of our models and algorithms what we discussed, and based on that image, the AI-based, AI-assisted model is going to tell you whether you have cancer which is benignant in nature, or whether it is malignant in nature, and things like that. So here, all the images what you see here, right, these are like more like a skin cancer kind of images which is there. And there is a huge breakthrough around this, wherein a lot of people are already doing a lot of research. But again, companies like Google have open sourced their solution, and they have already provided this solution online, so people like you and me can also use it without any human intervention. So you can go to a site called as health.google, and what you can do is they have a simple app, and on that app you can basically upload a photo of say suppose any skin variation you have, and using this app, basically they can tell you whether what kind of skin disease you have, whether it is some kind of cancer, whether you have malignancy and things like that. And they have close to 100% accuracy, which is out there. So they have also used some of the specific models which I've just described, like RNN, FCN, and CNN in combination to solve some of these problems. And some of these solutions, if you visit this site, health.google, even they have open sourced it in a way you can basically actually use that source code for yourself and maybe do that. So I'm right now showing on my screen, right, in a way how this works, right? In a way you can take a photo and it automatically is able to detect if I have some kind of cancer or not. If I have a cancer, it's going to tell me what kind of cancer I have and things like that. So look at how technology is being utilized, right? Maybe to make human lives better, right? In a way, you don't even need to go to a doctor, right? And maybe understand what kind of disease you have. So that is where everything is going, and this is always possible because of image segmentation. Okay. So generally, I get asked a lot of questions during such sessions, right? So in a way, people ask me all the time, right? So if I'm new to artificial intelligence, machine learning, or deep learning, so what I should do, right? Or if I'm new to some of these things, so what I should do. So generally, what I recommend everyone is you should try and attend STTPs like these, what we have. Also, go and enroll for a lot of courses online wherein you get to learn about artificial intelligence, machine learning, and deep learning, all the relevant models and algorithms, source code, and things like that. And once you have that knowledge, you could be at level 1, right? Wherein once you have that knowledge under your belt, you can go and participate in various open competitions. So there are like many competitions which are hosted on Kaggle, wherein you get maybe a lot of data and they tell what their problem is. And as a researcher, you can use some of the existing pre-trained models or maybe any open source algorithms, and you can solve that. Once you have that knowledge, you can also go to an intermediate level wherein you use some specialized models as we discussed, right? UNet, VNet, right? And use combination of that and maybe come up with newer versions of those models and algorithms, and combine this with third-party data sets what you have. So you might have certain open source database, but you also try to look for your own data set which is not available and see how those functions. Because generally what is noticed is one model could work better on your existing data source you have, right? But generally, if you use a new data source, you might have some issues with accuracy and things like that. And that's where you go for maybe the level 3, wherein you experiment building your own new model from scratch, which is going to be something which is going to be solving some of the problems which you noticed in the previous models which are there. And again, once you have this level of maturity, you become an advanced user. You go to the 4th level, which is the most mature user, right? Wherein you are able to use techniques like deep reinforcement learning. You're able to create MLDL pipelines online using cloud, right? You can create a shared model repository wherein you can collaborate with researchers at multiple levels, just not in India and outside India and things like that. So that is what I generally recommend everyone in a way how you should get started. And maybe if you follow the right methodology, it's not that difficult to become experts in these things. Here are some of the learning resources. Most of these are focused towards maybe medical diagnosis, which was the focus of image segmentation in my talk today. And some of them also give you some kind of nano degrees, right? From even from Stanford or maybe big places which are out there, right? And you can basically use these certificates and the knowledge what you're gaining here, right, to maybe apply what you're learning through these STTPs and the examples that I've shared to maybe actual use and maybe solve some of the real world problems. So here are some of the very good resources which you can use. Go and apply your learning, right, by enrolling for these courses, and you can basically become even better. So as I already said, there are many competitions which are out there. So you can go and check on kaggle.com/competitions. you'll find many competitions which could be relevant based on what we just talked during this interaction today, and at the same time use your knowledge and maybe win prizes. Some of these competitions even at times have maybe 60,000, 50,000, $100,000 as prize money, as you can see. And once you win this competition, and you prove your worth, right? Instead of you looking for a job, right? People will come to you and tell you that, okay, I have a job for you, right? Or you can be an advisor or a consultant, or maybe someone as an AI/ML expert who could help us solve some of the problems, right? And they'll be ready to pay you maybe thousands of dollars to solve their problems. So this is generally when I advise everyone to maybe participate in competition, learn, right? And maybe see how others have solved the problems. One important thing is if you go to these pages, you'll also be able to see old competitions, old problems, and how some of the researchers or competitors have really solved those problems. Even most of the source code, model, and other things are already available there. You can learn from that. Again, one more example. This is a site called as Grand Challenge. So every year they come up with Grand Challenge. They give you a new set of data using which basically you can come up with a new model and maybe solve the problem what they're trying to solve here. And again, this Grand Challenge website, right? They have a lot of different challenges and algorithms and models which are listed. And at the same time, if you solve some of these challenges which are listed here, there is huge prize money which is given to you, and maybe you can get yourself enrolled in maybe a league of extraordinary people, right, who use AI/ML in solving some of these complex problems. So just to summarize my talk, I would say today is I have given a lot of pointers, a lot of resources to you, so you can learn many more things practically. You can go and experiment with the code which is available online, and you can basically become experts in this field. So there is huge implementation as far as image segmentation is considered in various kind of diagnosis, clinical studies, treatment planning, or maybe other real world examples like driverless cars. Computer vision and machine vision is something which is going to be a huge area. A lot of people are already doing a lot of active research in this. This field is not going to go anywhere, right? So if you're looking for a career which is going to be something which you want to be everlasting, so you could basically pursue your interest in this field and maybe prepare future researchers or students to even join this field, and maybe use your knowledge and benefit, right? So that you become better in this study. So as we have seen during my session today, there are various image segmentation methods, algorithms, models which are there. But depending upon what's our goal, what kind of image types we have, image characteristics we have, what kind of problem we are trying to solve, right? Depending upon that, we may need to choose the right image segmentation methodology so that we are able to get the contextual information what we are looking for, and maybe we are able to get better at that. And I tell all my audience, right, we should ride the train and become experts before anybody else is going to do that, right? And you need to possibly jump in front of it. So since we are in fourth industrial revolution, it is very, very critical that we are learning and educating ourselves on all the modern technologies like artificial intelligence, machine learning, deep learning, and maybe utilizing those to solve real world business use cases. At the same time, we are also preparing future generation, which is dependent on, as I know, most of the people who are attending here are faculties from a lot of known colleges from India. So it's our prime responsibility that even we as teachers, professors, we are preparing our students for some of those future challenges. So with that, I would like to quote our beloved ex-president, Dr. APJ Abdul Kalam. So what he said is, excellence is a continuous process and not an accident. So you all need to ensure that you are pursuing excellence in everything what you're doing in your life, and you need to believe in your vision. And for that, we need to put in a lot of efforts, a lot of hard work, so that we can become successful. So I'm sharing my LinkedIn profile as well as Twitter profile links here. Uh, along with that, I'm also sharing my email address. So any of you, I'll try to answer some of the questions here, but any of you or your students have some research problems, or they want to collaborate with me, or maybe they want to take my help, I'll be more than happy to help them through emails. I might be a little delayed, but I'll try and answer and help as much as possible. So once again, I would like to thank Dr. Mohammad Atiq and others at Amravati University for inviting me and having me here for this session. And thanks for everyone for attending and maybe being interactive during the session as well. So with permission of the organizers, if there are any questions which you want to take, right, so we can take that now. Thank you once again.
Thanks, Dr. Rizwan. Audience, if you have any question, please ask. Am I audible?
Yes, you are audible.
Yes, sir. Yes, sir.
So you are audible. Thank you. And if you don't have questions now, if you have questions in future, please do reach out. I'll be more than happy to help.
Thank you very much, Dr. Rizwan, for sparing your valuable time and presenting. I should say you have shared lot many things. The only thing is that these participants, they need to explore, and because the stuff whatever I could see here on the screen is so much that if they explore it, it will require at least 15 or 1 month minimum, right? So
right.
Thank you once again, and we'll be in touch. Okay, and participant, please don't go away. We'll have next session within few minutes. Thank you, Dr.
Sir, thank you, sir. Thank you.
Thank you, everyone. Stay safe. Take care. Bye-bye.
Thank you.
Please wait. We will start our next session very soon. Okay.
Yes, sir. Yes.
Actually, in the chat box, I have received a lot many things with regard to RNN and all, right? So I have requested our actually the speaker for this session is you are well acquainted with is Mr. Vivek Nikam, who has conducted yesterday's session, afternoon session. Okay, but today he'll be talking on sentiment analysis using RNN, right? So there were some issues raised by the participant, something on sentiment analysis, right? So I am trying to accommodate as many things as possible. Okay. I don't remember the name, but somebody has raised. There are a few more people again. They have raised that we must have something on sentiment analysis, right? Again, it will be a hands-on session.
Okay, sir. Okay.
By the time he joins, anything else you want to have? We have got one more day with us. Or otherwise, how the things are moving? Satisfied?
Yes, sir.
Okay. So shall we get the code files from Vikram sir and others? I'll try, madam. Who is there? Anuja. I'll try.
Yes, sir.
हाँ,
Okay.
देखिए इशू कैसा है, मैं बताऊं कि अपन अभी मैं यहाँ चैट बॉक्स में देख रहा हूँ, वी फोकस ऑन हाउ टू गेट द स्लाइड्स. I am repeatedly telling you all these videos are live available on our channel, right? So if you go through the videos again and again, I think you can find everything worth it. Anyway.
Okay, sir.
Okay, chaliye. Anyway, I'll try and I'll put everything on the Google Classroom. Don't worry. Okay.
Okay, sir. Okay, thank you.
Now our guest is there. Okay, I'm admitting him. I request all of you to please switch off your cameras. Many time I am switching it off from my end, but it's better that you switch it off. Right. Welcome, Nikam sir, once again.
Hello, sir.
Yes. Hope you can hear me. Right. How are you?
Yeah.
How are you?
I'm good, sir. How are you?
Fine. Thank you. So without wasting much of our time, because I have already introduced you yesterday itself, I'll just tell you the participant inform you that the topic for today's hands-on session is sentiment analysis using RNN.
Yeah.
Okay.
Yeah.
So it's over to you, Nikam sir, please.
Yeah. Thank you, sir. Hello, everyone. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
So yesterday we discussed about what is a recurrent neural network. So quite the mathematical definition we discussed yesterday. So what is RNN basically? So mathematical definition is that your output at time t depends on your input at time t as well as previous output at time t minus 1. So this is what RNN is basically. This is one line definition for recurrent neural networks. So that we discussed, and then after that later on we discuss about stock price prediction. Then after that we discuss about stock price prediction. So I hope you understood that one. And today we are going to discuss about next application of RNN, and that is from the NLP, let me tell you. So that is from the NLP. So without wasting time, I think we should go ahead with that topic. Today we are going to discuss about sentiment analysis. Sentiment analysis. So sentiment analysis on IMDb dataset. So this is well-known dataset. Let me tell you, this is very well-known dataset. So sentiment analysis on IMDb dataset. Now this particular project or this particular assignment belongs to natural language processing. That belongs to natural language processing. Now to solve this assignment or to solve this problem, we need the RNN. We need the recurrent neural network. Obviously, that means we need a LSTM. Obviously, for that purpose, we need LSTM. Now, obviously, in your mind, that be the question like, why we need RNN to solve this problem? So let me tell you, we use RNN for the problems which are having time series data. It always like question from freshers or questions from many people that when to use which model we generally don't understand. So let me tell you, RNN we always use when your input data is time series data basically. So it operates on time series data, RNN. CNN, when CNN we have to work whenever we are going to have the data like images kind of data, whenever you are going to have, then we have to use CNN, convolutional neural network. So likewise, RNN we are going to use whenever we are going to have time series data. Now, obvious question in your mind, whether NLP data or whether that IMDb reviews, whatever we do have, are they time series? So yeah, that is time series. So I think yesterday we discussed about some time series related examples. So in that example, the best example of time series data is NLP text. NLP text data is always time series data. And let me tell you why it is so. For example, I'm writing one review like let's say the movie was good. So for example, this is what the sentence is. The movie was good. This is what the review, let's say. Now this is what you call as a W0, first word. Let me call it as a W1, that is second word. Let me call it as W2, third word. And let me call it as W4, that is the fourth word. Now here at time T0, yes, that is word 0. Let me call it as time T1. This is time T2. This is time T3. This time axis is very important. These words are on the basis of time. It doesn't mean that we can just write was first, was, the, good, movie. We cannot rearrange that one. We cannot rearrange it. It is not possible because it must be time specific. That is time specific. Likewise, first of all, the must be that this particular word must go as an input to the system. Next iteration, movie must go as an input word. Next iteration, that means iteration means I'm talking about timestamp. Okay, so in next timestamp, was must be the word that should go as an input to the system, and next timestamp, good must be the word that should go as an input to the system. So the movie was good. So this is what, like word 0, word 1, word 2, word 3, that should be given as an input to our system. That should be given as an input to our system. Now, yes, I hope you understood that NLP data is time series. NLP data is time series. Now, if you want to work on NLP data, there are some specific challenges. If you are working on NLP related data or text data, let me call it as. Whenever we are going to deal with text data, there are some specific challenges that we have to deal with. There are specific challenges that we have to deal with. What are those challenges for text data? For text data, what are the challenges? So let me tell you, if your data is text data, the main problem is that we cannot provide this data directly for machine learning model. So if it is going to be machine learning, whenever I'm going to call it as machine learning, it means ultimately it is also going to be like deep learning. Both are same thing, machine learning model or deep learning model. Both could be the same thing. So this text data we cannot provide directly to machine learning model or deep learning model. This is not possible. This machine learning and deep learning model, these are mathematical models. These are mathematical models. And obviously, if these are going to be mathematical models, the input to these models are should be numeric in nature. Only numeric features we can deal using mathematics. Only numeric data we can deal using mathematics. I hope you know numeric features. We do have integers, we do have float. These we call it as numeric data. These we call it as numeric data. So if you want to work on machine learning or deep learning model, basically work on means first of all we need to train this model, and later on we have to use this model for prediction purpose as a predictive model. Prediction purpose. So obviously to train the model as well as for the prediction purpose, this model only work on the numeric data. But the problem in our case is that our data is text data. So how we can work on this text data, how to work on this text data. So that is one of the challenge in NLP, natural language processing. That is one of the challenge in natural language processing. So let me tell you that this is the bigger challenge over here. So how we can handle this challenge? So the machine learning, deep learning, so we need to use this model for prediction. If you want to implement predictive model, if you want to predict sentiment from the given review, then we must train our model from the given sentiments. So if this is going to be machine learning or deep learning model, we cannot directly train it using text data. We cannot directly train it using text data. This text data we have to convert that into numeric data. This text data you have to convert into numeric data, and this numeric data we are going to provide to machine learning, deep learning model. Now it's fine. Now it's fine because what is going to happen? What is going to happen is that this deep learning and machine learning model can only understand numeric data. It cannot understand text data. So first of all, we have to convert text data into numeric data, and then on that numeric data we have to train the model. Okay, so that is what the system is. So here the basic solution is that to convert text data to numeric first, and then that numeric data we can use over machine learning or deep learning model. So our minor goal over here is that to convert text data to numeric data. That is what the primary goal in NLP. Basically, this is not needed in any other kind of applications. Let's say we do have applications in like basic problems, like whatever the data we do have. Let's say COVID data set we do have. Yeah, so we do have data set with respect to house price prediction, whatever that is. There is such kind of problem is not there. Even if you just have images data, I hope you know that images are ultimately numeric data. Why? Because the images means what? These are just set of pixels. It is just like matrix of pixels we do. And what is this pixel? It is the single pixel is always going to be numeric value. I hope you know that. Single pixel is always numeric value. So there is no problem with images. Because it is ultimately numeric data. Now speech data, or we can just say vocal data, we can say. This data is also in numeric form. We don't have to convert that in numeric. This is by default in numeric form. Yeah, other things we may need like scaling, all those kind of things. So yesterday we did scaling, that kind of thing we may need to do, but this is already in numeric. We don't have to worry about it. But in case of NLP, this is what like the different thing we are going to do in this project. Okay. So that is what bigger challenge in NLP. And that is why to solve this problem we do have many kind of NLP models. Let me tell you, we are going to discuss about NLP models. It means what? To convert text to numeric data. Now obviously it might be the doubt in your mind, how we can convert text data into numeric. To do that, we have many models, like we call it as NLP models. So that are specifically designed for natural language processing, yeah, to text related data. So how we can convert text into numeric data? To convert text into numeric. So the basic model is bag of words model. Now what is this model? That I will tell you. Then after that we do have TF-IDF model. So this model means it converts text into numeric format. Then after that we do have word to vec model. Then after that we do have word to vec model. And after that we do have some advanced models like transformers and birth. So these are very, very advanced models we do have over there to convert text data into numeric data. Now what are the difference between these models? Let me tell you what is the difference between these models. थोड़ा सा बेसिक आइडिया में बता दूंगा. We do have time, so ज़्यादा implementation के लिए ज़्यादा time नहीं लगेगा. So what is the problem over here? Like what is the difference between these models is that in bag of words, basically in bag of I will tell you advantages as well as disadvantage. In bag of words, we generally do consider data as a non-time series. Non-time series इससे better way word में use करता हूँ, non-sequence data. Let me consider as non-sequential data. Sequence data मतलब time series data we can say. Every time series data is sequence data. Now in TF IDF model also, we do consider it as a non-sequence data, as a non-sequence data. Basically, these are drawbacks. These are drawbacks. Let me tell you, these are drawbacks. In word to wake, we consider it as a sequence data. We do consider it as a sequence data. We do consider it as a sequence data. And in advanced models also, we do consider it as a sequence data. Now, whenever we are going to convert your text to numeric, whenever we are going to convert that into text to numeric, basically text is your sequence data. Your text is sequence data. But if you are using bag of words, the output numeric data is no more going to be sequence data. Is no more going to be sequence. I will give you example. Don't worry. I will give you example. In TF-IDF model, TF-IDF is just the extended version of bag of words model. TF-IDF is just the extended version of your bag of words model. Okay. And then after that, we do have word to wake model. That is very interesting model, word to wake. So this word to wake model is it is going to convert the numeric data into numeric data. That is like sequence data basically. This is the best model that we can use over here. Obviously, transformers and BERT is also best, but the thing is that for BERT and for transformers, we don't have that much data. We don't have that much data. So let's discuss about top 3 models. Let's discuss about top 3 models, exactly what they are going to do. Now, to understand these models, let me just give you expression in 5 minutes. To understand this model, basically, let me take one data. Let me take one data. So what I will do, I will take one reviews data set, a reviews data set, and I will convert that reviews data set. I will just convert that reviews data set into bag of words or TF-IDF. TF-IDF, I will give you an idea because we don't have that much time key. We can convert that into TF-IDF, but I will give you an idea. And then after that, we do have word to wake model. So let me just take reviews data set. Paila review, first review, we do have first review. So let me just have that review. What I'm going to consider, I'm not going to write here the movie was good, critics was good, kind of thing. I'm not going to write those things. I'm just going to take generalized example. In review 0, we do have words like W0, W2. Review 1, we do have words. W0 is going to be one unique word. W2 is going to be another word. So for example, W0 is good, W2 is movie, let's say, kind of thing. Let me have some reviews like that. W1, W2, sorry, W1, W2, W3, let's say. Review 2. So this could be like W0, W2, W4. Review 4, 3. So it is going to be W0, W1, W3. And review 4, let's say. So it is going to be almost review, sorry, W1, W2, W3, W4. So that these are going to be reviews. This is going to be the data set. So I just consider a very small data set here so that I can draw a table over here, because if we just consider a real data set over here, we are not able to draw the bag of words table. Okay. So now my question to you is that, in these reviews, so number of reviews are going to be 1, 2, 3, 4, 5. Number of reviews are going to be 5. Number of unique words, W. Can you tell me how many number of unique words are there in total? 5 reviews.
5 words, sir.
These are W1, W0, W1, W2, W3, W4. So total 5 words.
5 words.
Yeah, perfect. Now what we have to do in bag of words model, we have to create a table, and we have to create table with respect to number of words. So this must be number of columns. Number of words is going to be number of columns, and number of reviews is going to be number of rows. So I need here 5 by 5 ka table. So I need over here 5 by 5 ka table. Let's say this is going to be 5 by 5 ka table. 5 by 5 ka table. So let's have that one. This is W0, W1, W2, W3, and W4. So these are the words W0, W1, W2, W3, W0. So for every unique word, I have put that onto the column side. For every unique word, I have just put that onto the column side. Okay, so that is columns. Now the rows I'm going to have. So for R0, we do have row number 0. For R1, we do have row number 1, 2, 3, 4, let's say. So these are number of rows. These are number of rows. Now what we are going to do, this data, this text data, I'm going to convert into now numeric data. So this is what text data is. This is what text data is. That text data now I'm going to convert into numeric. How? Let me tell you. Here you can just see W0 and W2 are the words that are available in R0. So in R0 we do have W0 and W2. Other words are not available. In R1 we do have W1, W2, W3. W1, W2, W3. Other words are not available. Likewise, in R2 we do have W0, W2, W4. W0, W2, W4. Other words are not available. In R3 we do have W0, W1 and W3. Others are not available. Then after that W1, W2, W3, W4. So it is not available. W1, W2, W3, W4. That's it. Done. And for example, this is what your text data, they're labels. Let's say this is what negative sentiment, this is negative sentiment, this is positive, this is positive, this is negative. So it is going to be Y. Let me just have a Y over here. The first review is going to be negative, second is negative, third is positive, fourth is positive, fifth is negative. Likewise. So this data is ready. Now this data, in this data, this would be used as X and this would be used as a Y. And now this X and Y, whatever data we do have right now, that we can use to train the machine learning model. Now it means that we basically in machine learning model, I already told you that what is machine learning model is to find out Y is equal to F of X, the relationship between X and Y. Here, what is X? X is going to be unique words, and Y is going to be your sentiment, positive or negative. It means that whenever we are going to train the model on the basis of this given data, we are trying to build the relationship between output and that is sentiment and the words available. That means, for example, in the review, whenever we are going to have word good, अगर आपके review में good word है, so obviously it means that there are higher chances that your review is going to be positive. If your review is going to contain the bad word, that means there are higher chances that your review is going to be negative. So like that. So such kind of relations we try to find out. Here we do have only 5 unique words. That is why this is the small table. So this data structure, we call it as a bag of words table. This is what we call it as a bag of words table. Now, whatever the concept I told you, I hope you understood that one. And अगर इसमें कुछ doubt है तो please ask. And अगर doubt नहीं है तो let me ask you one question. What do you think? What is going to be the problem with this model? इस model में problem क्या हो सकता है? अगर कुछ doubt है तो you can ask doubt. And if you don't have doubt, you can tell me what is the problem with this kind of encoding, or we can say text to numeric conversion. Yes.
Can you just explain this part again, because I got disconnected. I mean, the device was shut down.
Yeah.
That's why I could not hear this part, sir.
Sir, don't worry. Okay, because these videos are recorded. Okay, later on you can go through it. That would be my suggestion.
Okay, okay, sir.
Please.
Basically, this slide is also self-explanatory. You can just see these are reviews. So W0, if in review 0 we do have word W0, so W0's column is going to have 1. W2 word is there in review 0. So for review 0, W1's entry is going to be 1. All other words are unavailable. That is why it is going to be 0. So it is just like self-explanatory. So even you can understand that one.
Sir, excuse me.
Yeah.
Sir, our statement was the movie was good.
Yeah.
So here we label that word W0, W2, W1, W3, W4 like this.
Yeah.
But suppose these words are not repeated by R1 suppose.
Yeah.
Or R2 suppose. Then how we can form this table, BOW table?
That means the number of whatever the words we are having in R0, same words will be there into R2.
If it is not there, suppose the review is something different, then in that case,
I think it is different review. So this is going to have two different words in sequence, W0 and W2.
Then we have to increase the number of W0, W1, W2, W3, W4, W5 like this.
Yeah, this is going to have 5 unique words. If you have more words, then number of words is going to increase, and obviously because of that, number of columns are going to increase.
Oh, okay, sir. Okay, thank you, sir. Got it.
So we decided number of columns on the basis of unique words, basically.
Yes, sir. Yes, sir. Got it.
So problem in that particular model is non-sequential data.
Perfect. Non-sequential data. Can you tell me specific example where this model fails? Specific example, specific review or something like that.
Sir, it is depend upon ones and zeros. So in that case, zeros and ones are common for different words also.
Yeah, but then that location we are going to have location information. So at this location 1 means it is W0.
Okay.
At this location 1 means it is W1.
Yeah. Then it is quite difficult for train the machine.
Okay. That means you are ultimately trying to say that number of ones and zeros are quite large, because whatever the data we are going to have, that data is going to have number of unique words more than like 10,000, 20,000, 30,000 in lakhs also.
Yes.
Number of unique words. So that is going to be huge in data set, like number of columns.
Yes. So in that case, train to that particular machine is difficult or it's a tedious?
Yes, definitely you can say. It is going to be difficult, but definitely it is going to be difficult.
Yes.
Anything else? W2 W0. Review 5 is going to be W2 W0. These words are into review 5. Now as a human being, what do you think? Review 0 and review 5 are same or different?
Different, sir.
That is different. That is just like sequence of words. Whenever we are going to change the sequence of words, its meaning gets changed. Okay, so
Yes.
these are different. What is its bag of words representation for review 5? If I just maintain review 5 over here, so देखो W2 है, so for W2 it is going to be 1. W0 है, W0 is going to be 1. What about others? It is going to be zeros. Whatever its label is going to be, let's say 1 here, 1. If you just see review 5's representation, this is what review 5's representation in numeric form, and this is what review 0's representation in numeric form.
But sir, in another case also, if you observe the reviews, in another case also, if here R1 suppose W1, W2, W3, the movie was good. The good word is missing here.
Yeah.
The meaning is completely changed. Means you are not giving any kind of review about that movie. The movie was.
Yeah.
So here also the meaning is going to be changed to movie was.
Yeah.
The movie was. The movie was.
Yeah.
Not good. Nothing. No review is there. Means no clarification is there.
Yeah.
So these problems means this review. How can we analyze it?
Oh yeah. So with this specific problem, sir, I will call it as problem with data preparation. I will call that as a data problem with the data preparation, because see, this data is being generated. These reviews labels are being given manually. These are being given manually. So ये जो Y label है ना, ये manually देखना पड़ता है as a human being. So whatever reviews we do have, uska jo like label hai, that we have to decide manually. And on the basis of this, we train the machine learning model. Once we train machine learning model, abhi aadmi ki zarurat nahi. We don't need human being to label that particular review.
Yes, yes.
Now here in this particular data set, so that has been prepared by human beings. In that data set, if we are going to have the statement like that the movie was. So this is like neutral statement. This is what neutral statement. So in that case, I will call it as, for example, this has been included into the data set. So obviously it will be either having 0 or 1 as a label because it is part of training data set.
Yeah.
In that case, I will call it as it is the problem with the data preparation because it should not be included in your data set for training the data set. So obviously it is problem of data preparation. Here it is not going to be the problem of bag of words in that case. पहले इसको हटा देना चाहिए. We should not include such kind of statements. These are like neutral statements, so we should not consider that for building machine learning model. Because what will happen if we include them? Our machine learning model will try to establish a relationship between these words and this label. So if that label is 0, that means your machine learning model will understand these 3 words are negative words. That is why your review is negative. So that may like misguide our model. So that is why we should not consider such kind of statements in training data set.
Yes, sir. Yes, sir. Got it, sir. Got it. Yeah. Thank you, sir.
Now here, I hope all of you understood that this review 5 and review 0 are completely different. That means in meaning, I can say. But their bag of words representation is going to be same. That means whenever we are going to provide this data, this table to the machine learning model, that means machine learning model is not going to understand the sequence of words. Here, the sequence of words is different, still the same representation. That means your machine learning model is going to only understand which words are there into your input data. And on the basis of that only, it is going to decide what is the sentiment. Let me tell you realistically example. एक realistic example में देता हूँ what is the problem is. For example, I do have one statement like I am hungry, but you are not. This is what the statement is. This is first statement. Let me call it as statement 1. And let's say we do have another statement, statement 2. Statement 2 is like this. I am not hungry, but you are. Now, if we just see this statement as a human being, we can understand this. Both the statements are exactly opposite in meaning. These both statements are exactly opposite in meaning because first statement is saying that I am hungry, but you are not. And second statement is saying that I'm not hungry, but you are. So these two statements are exactly opposite in meaning. Now, if I ask you, what would be these two statements bag of words representation? Bag of words representation. Are that same? Is that going to be same or different? It's bag of words representation.
The sequence should be different.
The sequence will be different.
Yes.
But tables are same. But tables are showing same value.
Yeah. What I'm asking you is that the table entry. This is what we call as a numeric representation for that tree.
Same, sir. Same.
Yeah. So in that case, for this first review or whatever the sentence, we do have some ones and zeros sequence, right? Whatever it is, whatever that sequence is. So जहाँ पे I है वहाँ पे 1 रहेगा, जहाँ पे M है नहीं है उसके हिसाब से 1010 रहने वाला. So this is what the representation for first statement. Can I say that the representation for second statement is going to be same or different? ऐसे कि as it is जैसे ऐसे ही आएगा कि different आएगा?
Sir, different आएगा. It will be different, sir, because two statements are different. So we have to create bag of word different for these two separate bag of word statement. We have to create separately for these two statements. Is it, sir?
It will be the same.
It will showing same, sir, in the table.
It will be the same. We are just mapping the words. We are not doing
because
anything else.
Table
We are not
entry we are
seeing the
created.
sequence.
But numbering, if you observe here, we are giving W1, W2, W3, W4, W5, W6, W7. So here in this case, not is at W7. In this case, not is at, in second case, not is at W3. So if we create separate statement, separate BOF, that bag of statement, so then it will be possible, or is it possible to create separate bag of statement for both?
No, let me see what is going to happen. For example, this is the only review. So I'm just going to consider the locations for only these words. So M ke liye, this is what the location, not ke liye, this is location, hungry ke liye, this is location, but ke liye, this is location, or agar koi repeat ho raha hai, to this one, R ke liye, this location. So all are unique words, right? Now, as per statement 2, I hai kya? Yes. M hai kya? Yes. Not hai kya? Yes. Hungry hai kya? Yes. But hai kya? Yes. You hai kya? Yes. Are hai kya? Yes. Now, for this is for statement 2. What for statement 1? Statement 1 mein I hai kya? Yes. So yahan pe 1, because this is for I. This column is for I. Then for M hai kya yahan pe? Yes. So it could be 1. Then not hai kya isme not? Yes hai yahan pe. So it is going to be 1, because not ke liye, this is what the column for not. Try to understand. Then hungry hai kya? Yes. So hungry ke liye be 1. Then after that, but yahan pe hai kya? Yes. So it could be 1. Then you is there? Yes. So ye be 1 time. R hai kya isme? Yes hai yahan pe. So it is going to be 1. So it is going to be same. It is going to be same, because the sequence of words, whenever we are going to design the table, the sequence of words is same for all the reviews. W0 का पहला column, W1 का दूसरा column, W2 का दूसरा column, and next column, W3 is going to have different column, W4 is going to be a next column. And obviously, wherever that W0 is, you can just see statement R2 is. R2 mein, we can just see W0 is over here as a very first word. And in R5, we do have W0 as the last statement. W0 is. It is going to only mention whether that W0 is there or not. That's it. So that this location is not important in case of bag of words.
Okay, sir.
And that is why,
important.
Yeah, it is going to have same representation for two statements over here. For these two different statements, we will be having the same representation. And as a human being, we know that these are opposite in meaning. Still, we do have same representation. That means ultimately in numeric format, both statements are equal. As a human being, we know that these are different. Matlab, exactly opposite in the nature. But your bag of words is going to tell us that both are same. So this is what the problem of bag of words. This is what the problem of bag of words. This is what the problem of. Now this is what the problem of bag of words model. Okay, that's fine. So I hope you understood bag of words model is not going to maintain. It is not maintaining sequence information. It does not maintain sequence information. This does not maintain sequence information. That is what the problem with bag of words model. That is what the problem is with bag of words model. Okay. So yeah, that is what bag of words. And let me tell you, in bag of words model, it is simple machine learning model. Y is equal to f of x. It is not, we don't need RNN to implement bag of words. Basically, we cannot use RNN or bag of words table. These are not machine learning models. I try to understand. I have just mentioned them as NLP models. So they are only converting your text data into numeric data. So whatever the data that is being generated by bag of words that we cannot use in RNN, try to understand. We cannot use this data in RNN because it is not a sequence data. In bag of words, we don't have a sequence data. In bag of words, we don't have a sequence data. So that is what bag of words, and that is what the problem is. It is basically trying to find out the relations between existence of a word and your label. So it is not going to maintain the sequence. Basically, on the basis of sequence, your meaning of statement changes like this. Sequence of word change किया, आपका meaning change हुआ, completely change हुआ. So obviously, इस case में, in such kind of problems, in such kind of issues, your bag of words model is going to be not a good choice. It is not going to be a good choice. Okay, that is one thing. So that is about bag of words model. Now after that, if we just discuss about TF-IDF model. Let me just tell you introductory things because we are not enough time to explain each and everything in very detail. So what I will do, I will just tell you what is the idea TF-IDF. Let me tell you, TF-IDF may be table ही होता है. TF-IDF. It is also going to have a table. TF-IDF also going to have a table, same like table. Let me tell you, it is same like bag of words table. It is same like bag of words table. But the problem in bag of words is that we are using 1 for existence of word, 0 for non-existence of word in bag of words. Instead of using these ones and zeros, instead of using this TF, instead of using these ones and zeros directly, I'm going to use TF-IDF value. TF-IDF value. So your table will be same. So that is what table. This is going to have W0, W1 till W4. Here we do have 1 0 1 0 0 0 1 1 1 0 1 kind of table we do have. So instead of this is storing these ones and zeros directly, we are going to use their TF-IDF values. So let me tell you what is TF-IDF is that. TF stands for term frequency. Term frequency. And IDF stands for inverse document frequency. अब ये दोनों frequencies क्या है? So first frequency, term frequency is that, let's say I want to find out what is the value for W0 in review 0. This is what review 0, review 1, review 2, let's say. So what I want to find out the entry for W0 in review 0. So this entry I want to find out. So first of all, I will find out term frequency of W0 in R0. Means what? How many times W0 appears divided by number of words in R0. So let's say R0 में है 2 words, उसमें से एक word है आपका W0. R0 likewise here, जैसे मैंने यहाँ पे लिखा है, R0 में we do have 2 different words, उसमें से एक W0 है. So it is going to be like term frequency means how many times that W0 is appearing in this R0. So R0 में total 2 words out of that one. That means 50% W0s we do have in R0. So that is what term frequency for R0 for W0 in R0. Then after that, inverse document frequency. Now what is inverse document frequency? This is very interesting concept. Inverse document frequency. This is very interesting. So inverse document frequency is going to tell us that. So how rare given word in all over document, पूरे डॉक्यूमेंट में ये जो गिवन वर्ड है वो कितना रेयर है. So that has been measured using inverse document frequency. So let me tell you how do we find out inverse document frequency. So IDF, inverse document frequency of word 0 in whole document means all reviews. तो यहाँ पे मैंने दिखा है. So all documents mean all reviews. So whole document is been defined using D. So W0 कितने reviews में? So let me just write down here. Let me find out IDF value. It is log of number of reviews divided by the number of reviews in which W0 is there. Okay. So now you can just see, for example, number of reviews are 5 and W सिर्फ एक ही review में. So what we can say, it is going to be IDF of W0 in document. Whole document is going to be 5 by 1. So it is log of 5. ऐसे consider करके W0 हर एक review में. If W0 is going to be there in every review, so what is going to be IDF of W0? Can anybody tell me? If W0 is in each and every review, W0 is there in each and every review, so what is IDF of W0? Which is equal to log of
1.
Okay. So number of
It is
reviews.
0.
Let's say we do have n number of reviews. Let's say we
N
do
by
have
n is
total.
1. Log of
Yeah.
n will be 0. Value
Yeah,
will be 0.
Yeah, perfect. So log of n. Let's say log of reviews. Number of reviews is n. Let's say. सारे reviews में W0 है. In every review we do have W0 is there. That means W0 is in their n reviews. So it is going to be log of n by n. So it is going to be log of 1. So ultimately it is going to be 0. So that is what. How much it is rare. ये बिल्कुल भी rare नहीं. In that case, can I say that W0 is not at all rare in the review because it is everywhere. That is why its measure is 0. On the other side, log of 5 means whatever that number of reviews, let's say 5 के जगह पे मैं number of reviews n लिखता हूँ. W0 is only in the one review. W0 is only in the one review. So in that case, it is log of n. So can I say that log n means it is going to be the maximum possible value. It is maximum possible value. Obviously, W0 कभी 0 count नहीं हो सकता. If it is going to be a 0 count, W0 obviously we are not going to have in bag of words. If W0 is not in any single review, so obviously उसका कोई column ही नहीं बनेगा नहीं bag of words में. So obviously W0 का count at least 1 तो आएगा. At least in one review we are going to have W0. So that is why denominator is going to be 1. And in the numerator we are going to have n. So maximum possible value for very rare word is going to be log of n, and minimum possible value is 0. So this is how we find out the rareness of the word in the given document. Document means all reviews. So that is being found out using inverse document frequency. Now it is also having meanings like why we are using this one. So if you want to find out this value, what we do, we find out TF into IDF, that is TF IDF value of W0 in R0. So just for your reference, let me tell you that value. If you want to put value of W0 in review 0, if you want to find out W0 value in R0, so that means ये वाला value. If you want to find out W0's value in review 0, how do you find that out? We found it out like this, like it is equal to term frequency of W0 in review 0. That means how many times W0 appears in review 0 divided by number of words in review 0 into inverse document frequency of of W0, word W0 in the document D. So this is going to find out W0's rareness in the document. And this term frequency is going to identify how much frequent that word in that particular review. So just try to understand. Here I have written R0, here I have written T. Everything has meaning. Everything has meaning. And this multiplication is going to give us whatever that value is. For example, W0 appeared only one time and number of words in review 0 is going to be 4, let's say, into inverse document frequency of W0. It is equal to log of total number of reviews. Let's say we do have 100. We do 100 reviews. And out of 100 reviews, W0 came into 10 reviews. W0 is there into 10 reviews. Out of 100 reviews, W0 is there in 10 reviews. So let me just have 10 over here. So what it is going to be 1 by 4 into log of 10. So log of 10, obviously, if I just consider log to the base 10, generally we consider it as a log to the base e, whatever it is. If you just consider log to the base 10, then it is going to be 1 by 4, that is 0.25. So this is what the value that we are going to put at this location, W0 R0 location. मतलब यहाँ पे मैं रखूंगा 0.25. Here I am going to have 0.25. Sorry, here I am going to have 0.25. So all values will be like this: 0.25, 1.3, minus 1 point, minus नहीं आएगा, minus नहीं आ सकता. Then after that, 0.75 kind of thing. So it is not only about ones and zeros. We are all researchers. Obviously, doubt in your mind, why TF-IDF? Why TF-IDF? Bag of words तो आपको बता देता कि ये word है या उस particular review में कि नहीं. So what is benefit of using TF-IDF? The benefit of TF-IDF is that it is going to provide us the importance of word. So for example, what is importance of W0 and R0? That we are finding out and that we are putting into that particular column. So if we even know what is importance of that word, it is going to help the machine learning model. So if this value is going to be greater, machine learning model is going to focus on this kind of words. That is, it is going to be important. Now you'll say that how it is important, how we do find out whether it is important or not. Term frequency is going to tell us that how many times that word is repeating in that review. If this word is repeating many times in review 0, that means this word is dominating review 0. That means review 0's entire effect is dependent on W0. That is what term frequency is. Into IDF. IDF is going to tell us how much that word is rare in the given document. Now, jitna rare hoga word, utna zyada important hoga. अब बोलेंगे how? Let me tell you one thing. यहाँ पे देखा हमने I think कहाँ पे आया था 0 here. So for example, one word is there that is appearing in each and every review. There is one word that is appearing in each and every review. Whether it is important for machine learning model, what do you think? If any word is appearing in each and every review in a whole data set, what do you think? Whether that word is important to predict the class of that particular review?
No, sir, not important.
It is completely useless. In that case, I will say that it is completely useless because your Y is not at all dependent on that word 0 because it is there into each and every review. So it is not going to give us any information कि W0 है तो कौन सा class है, W0 नहीं है तो कौन सा class है. It is completely becomes meaningless. And that is why if your words are going to be rarer, then it is going to have higher importance. If your word is going to be more frequent, then it is going to be of less importance. So that is what the concept they have used to find out TF-IDF model. So instead of using straightaway straightaway bag of words, we are putting values, TF-IDF values into bag of words, and that is what we call it as a TF-IDF model. That is what we call it as a TF-IDF model. Let it be. I think थोड़ा सा हम ज़्यादा ही इसमें discuss किया हमने. Let me go ahead then. So TF-IDF, can you tell me what is the problem with TF-IDF again?
Same problem, sir. That will be a non-sequential.
Yeah, perfect. The same problem, that is non-sequential. The same problem, that is non-sequential. Now, let's get back to our original problem. That is word to wake. That is word to wake. Now, what is word to wake is? Before going for actual explanation, let me tell you beauty of word to wake. Before going for actual explanation, let me tell you what is beauty of word to wake. The word to wake beauty is that in word to wake model, we find the meaning of words. Meaning of words. It's very interesting. It's very interesting. Meaning of words means exactly what it is going to find out. For example, in word to wake, if I do have two words, like let's say two synonyms, like good and let's say nice, let's say. So here in bag of words or TF-IDF, this would be considered as two different words. That would be considered two different words in bag of words. Obviously, so it would be W0, this would be W1. But in word to wake, this would be considered as like almost same or same in meaning words. That would be considered as same in meaning. Now you'll say that how it is going to be maintained, how it is going to maintain the meaning of words. How it is going to maintain the meaning of words. So let me tell you in short. This good is going to be defined using one vector. This nice word is also defined. Every word is going to be defined using one vector. Vector means, I hope you understood. Vector in programming perspective, you call it as an array. In programming perspective, we call it as array. From a mathematics background or perspective, we call it as a vector. So to represent every word, we are going to use one vector. Now word to vec is going to give us the vectors which are very close to each other. For vector for good is closer to vector for nice. So whatever the vector we do have, these vectors are very like lengthy in nature. Generally, it could be like 256 length wala vector, or sometimes it could be like 300 length wala vector, like this. Here also we do have same length wala vector. It could be any length wala vector. So ये थोड़े से लंबे वाले vectors होते हैं. So that could have any value. It is not only about zeros and ones. This is about any negative value closer to zero, any positive value closer to zero, or zero we can say. Okay, so that is going to have any value. That is going to have any value. कैसे value find out करते हैं वो भी एक concept है that I will also tell you. So to represent good word, the word good, we are going to use one vector. To represent word nice, we are going to have one vector. ये जो दोनों vectors है that are very closer to each other. So now here vector mathematics comes into picture. So we do have two vectors, v1 and v2. How do you find these two vectors are closer to each other? In mathematics or geometry, if we do have two vectors, can anybody tell me how do you find out these two vectors are closer to each other?
By taking union of vector?
No. Basically, union is not the operation that we do on vector. That is set. How do you find out the similarity between two vectors? Let me have one example. You'll understand. Everyone knows this. Everyone knows this. Let me just give you some hints. We do have one vector that is v1. We do have another vector that is v2, and we have another vector that is v3. What I will do that what I will say over here is that vector v1
Find the
and
angle
v2
between the vectors.
and yeah, perfect. That is closer to each other, but v1 and v3 are not same. v1 and v2 are almost same. That is what I'm going to call it as closer to each other. But v1 and v3 are not same. Even v2 and v3 has no any similarity. How I'm going to find out? Using this theta angle between this. If it is going to be zero, if the angle between two vectors is going to be closer to zero, I must say that both vectors are going to be similar. Both are going to be similar. So here v1 represents one word that is good. v2 represents another vector. Let's say nice. And v3 obviously they are not at all similar. So let me just call it as bad. Okay. So these are this is how we find out similarity between vectors. This concept, or how do we find out theta? How do we find out theta? Theta is equal to cos inverse, like v1 dot product v2 divided by v1 ka magnitude into v2 ka magnitude. Something like that. I'm also not exact sure about this. Something kind of concept we do have to find out theta angle, right? So this concept is called as cosine similarity. This is called as cosine similarity, to find out whether both words are similar in nature or not. To find out both words are similar in nature or not. So that concept is there. That concept is there. So this is what your word. So this is what word vectors. In word to vec, this name is coming from that only. So we convert every word into vector. Every word into vector. Now how to find out these vector values? ये v1 and v2 कैसे find out? So for that purpose, we have word to vec model. For that purpose, we do have word to vec model. We don't have that much time to discuss this in detail because word to vec discuss करने के लिए we take a lot much time. Not in hours. I must say that 2-3 days का topic है. Let it be. मैं short में बताता हूँ. To find out the vectors, we are going to use the neural networks. To find out the vectors, we are going to use neural network. And what we are going to do, this neural network we are going to train on the basis of one data set. And this word to wake model is been trained in such a way that it is going to extract the vector representation for each and every word over there. So we do have two models for that. That is CBOW model, that is continuous bag of words model, and another model we do have, that is skipgram model.
Excuse me, sir.
Yes.
This word to wake model is already available, sir.
Yeah, it is already available.
Okay.
Yeah. Basically, just see, if you want to find out the meaning of words, we need huge data set. So whatever the models we do have available in word to wake, these models are being trained on huge data sets like wiki ka data hoga, Wikipedia ka data. And after that, it could be Google News data set. Google News data is huge data set, because the daily news are going to come over there. This huge data set. Or we can say Twitter ka data set. So this is the huge data. So obviously it is enough data set to understand meaning of words. It is enough data set to understand the meaning of words. And to understand the meaning of words, these are two models. So CBOW and skipgram. So internally how they work and all those kind of details, if we get time today, I will tell you. Otherwise, our main focus is to implement sentiment analysis. So basically, this is how do we find out word vectors. Using this, we do find out word vectors. Now, let's come back to our original problem. What is the original problem? The problem is to convert your text data into numeric form. Now let me have two reviews. Review 0, that is have W0, W2. Review 1, we do have W1, W2, W3. Review, let's say 2, we do have, that is W2, W0. Now यहाँ पे तीन ही reviews लेता हूँ मैं, because these are enough to represent. Now here, in case of review 0 and review 2, I hope you understood that bag of words will give us the same representation, because it is just the rearrangement of words. Now what word to wake या तो word embedding will do. Basically, word to wake is also called as word embedding. Word embeddings. Okay. So what this model will do? This model is going to convert this data into vector format. So for W0, we do have what vector V0. For W2, this is the word, and every word is going to have one vector. So for W0, we do have, W2, we do have word V2. So this is what sequence of vectors. The pahla vector, this is second vector. Here we are going to have three vectors in sequence: V1, V2, and V3. So respective vectors for each and every word. And here we are going to have two vectors in sequence. This is V2 and this is V0. Now can I say that this is time series data? This is the word at time T0, this is at time T1. This is at T0, this is at T1, this is T2. This is at T0, this is at T1. So now, can I say that these two representations are same or different?
They're different.
These are now different. That is what the beauty of word embedding or word to wake.
The vectors are not different, but the words are different.
Sequence. Entirely, this is going to be matrix. Basically, if you do have vectors length as, let's say vectors length as 128 values. So vector length is 128 values. So it is going to be 128 by 2. It is 128 by 2. The same matrix we do have, लेकिन यहाँ पे तो matrix होगा 128 by 3 वाला matrix it could be. It is going to be 128 by 2 wala matrix. So if you just look at that in numeric information, that is rearranged, but that is different. Like entirely isko dekho, जो भी arrangement of words है, and entirely isko dekho. These are two things that are entirely different. So that is what it is keeping sequence information. That is why I can say that it is keeping sequence information. So it is going to solve the problem of sequential data. And that is why word embedding is best for implementing NLP related projects. Okay. So this is what word to wake or word embedding is. This concept is called as word embedding. And now we are going to use this concept. To implement our sentiment analysis problem. to implement sentiment analysis problem. So in short, I can say that bag of words we have seen, TF IDF we have seen, and then we have seen about word to wake. Word to wake. Word to wake. Bag of words, it is plain table we say, and it is not or non-sequential data it is going to keep. TF IDF is also table, but is not of ones and zeros. It is of some kind of importance of words. It is going to maintain the importance of word. Importance of words. यहाँ पे वैसे कुछ भी नहीं है. But it is also going to hold non-sequence information. And in word to wake, we are going to have word vectors. We are going to use word vectors in sequence. So it is going to have the data in sequence. It is going to maintain in data in sequence. बाकी के भी issues है bag of words and TF IDF के साथ. The issues are like it is going to have sparse representation of values. Like huge tables we may have in bag of words and TF IDF. If you have number of unique words, large number of unique words. बाकी के issues है for me the important thing is that it is not able to maintain sequential information. And what I want to maintain, I want to maintain sequential information, because if we change the sequence, the meaning of statement may get changed. Yes, kuch doubt?
No, sir. No, sorry, sir.
Yeah. So if you have any doubt, you can ask, no problem. So this is about, basically this is also called as word embedding. This is also called as word embedding. Now we are going to implement, let's now we do have one problem statement that we have to design the model. We have to design the model to do sentiment analysis. Sentiment analysis. We have to do sentiment analysis on IMDb dataset. On IMDb dataset. On IMDb dataset. That is what our problem statement is. Now we are going to implement this problem using word embedding. Now from programming perspective, let me tell you, from programming perspective, things are not going to change much. Things are not going to change much, because only one thing is going to be changed. We are going to use word embeddings. We are going to use word embedding. Otherwise, almost like same, just yesterday we have done pre-processing of data first. We done pre-processing. Second thing is that we did a created model. Likewise, so these are the steps basically. Same steps are also going to be over here. Pre-processing of data is needed, and then after that we are going to create the model. While creating the model, only some lines are going to be there, otherwise same. Pre-processing is going to be different in this case because it is a pre-processing with respect to text. Yesterday, whatever the pre-processing we have done, that is with respect to time series stock price data. Time series stock price data. So pre-processing is going to be changed entirely, but the model, I don't think much it is going to much change. Okay, it is not going to change much. What is important in every project is that pre-processing. It is important part. Many people may say that sir, model is important. See, yeah, that is right. But as a developer, I don't need to waste much time on model. What I need to do, I need to do much time, or I need to give much time for the pre-processing. If it is going to be weaker, if your data pre-processing is weaker, model banana is of no use. It becomes useless. So जितना आपका pre-processing strong है, उतना आपका model बढ़िया accuracy देगा. So always keep that in mind. Always keep that in mind. Okay. So we are going to use IMDb dataset. Now to implement that project, to implement IMDb, let me show you what is IMDb dataset first. So let me just go to Kaggle. You can just see. I don't think इसको open भी करने की जरूरत है, बेवजह ये time देगा. Data size is 1 GB. Very huge data set. It is going to be very huge. इसके छोटे-छोटे like we can say smaller versions are available. That's fine. But almost if you want to use the proper data set, देखो ये बहुत बड़ा data set है. 50 GBs, sorry, 1 GB ka data set it is used. Other versions are also available. Other versions are also Netflix original films and IMDb scores. Okay, that is also there. 5,000 movies ka data set, 554, that is also there. Likewise, you can just see a lot many data sets are available. Now what I'm going to do, I'm going to directly implement that into Kaggle kernel. I'm going to directly implement that into Kaggle kernel. So let me just start implementing the thing. So let me just go to code. Let me create new notebook. I will start coding over here. That sentiment analysis problem. Okay, it has been loaded. Accelerator. Let's use accelerator. Don't. I think है मेरे पास available. Yes, सिर्फ 3 घंटे use किया है कल. That's it. So this is what I'm going to use. Data add करने की जरूरत नहीं, because I will tell you from where we are going to have the data set. Let me run this first. It is going to allocate the instance for me. Yeah. So now here you can just see. Now here you can just see. Now here you can just see key session has been started. Session means जो भी आपका execution session है, that has been started. Now here I'm going to tell you how we can use IMDb dataset also. ठीक है, थोड़े से मैंने सेल बना के रखे ऑलरेडी, बिकॉज ये बाद में स्क्रॉल करना डिफिकल्ट होता है. ठीक है. Now I'm going to load that data directly from TensorFlow. So from TensorFlow.keras.datasets. I will also tell you why I'm going to use this data set from the Keras, yeah, to TensorFlow. Let me import IMDb. Yeah, IMDb. ये import करता हूँ मैं. अभी download नहीं हुआ. I just imported that IMDb module from Keras datasets. Now let me first download the dataset over here. So IMDb में एक function होता है. Unlike IMDb, we do have many other datasets as well. Like well-known datasets are available in TensorFlow itself. So IMDb, how I'm going to download that one? IMDb.load. Yes, load data function is there. Let me see what options are there.
Excuse me, sir.
Yes.
We are using this data set which is already available.
Yeah.
Sir, we need to pay. This is a free of cost available, or
no. These are open source.
Okay, sir. Okay.
We don't have to pay them. These are open. Generally, we use open source data sets only.
Okay, sir. Thank you.
Okay. So, okay, now you can just see the options for this load data function. Now this load data function is going to have option. This path means basically it is the internal path for your TensorFlow. Number of words, that means how many unique number of words you are going to consider. I already told you that. There are lakhs of unique words that people have used in IMDb dataset. So obviously we need to limit that one, because it will make a problem with your word embedding later on. So let me just use some specific maximum number of unique words that are more frequently over there. So that number of unique words I'm going to consider. So we can just set that parameter over here. I don't know exactly how many unique words are there, but I'm going to set that limit, number of words limit to 20,000. इसका रीजन भी आपको बताता हूँ. Why I keep it as 20,000? The reason is that whenever we are going to train the model, it will be faster. First thing is that. Second thing is that whenever we are going to do word embedding, so in word embedding there is one word to vec embedding is also there. Initial word to vec embedding is also there. I think it is not working. I don't understand why it is not working. Okay, let it be. So this is what 20,000 is. Now what it means is that when if you want to implement it using bag of words, 20,000 columns will get created. 20,000. So it is going to consider maximum 20,000 unique words. Even it is necessary for word embedding, because whenever we are going to train word embedding schema model, that is continuous bag of words or skip gram, there internally we are going to use one hot encoded representation of each and every word. So that one hot vector is of 20,000 lets maximum. So वो जितना कम होगा उतना better रहता है for training. It is going to be faster. So for our application, this is sufficient. 20,000, 10,000. If you just keep it as 50,000, it will be very complicated. Yes.
Yeah, as you said, the columns of your word of bag will be 20,000. It is necessary because the words are repeating. So in that case, 20,000 may not be the columns. Is it or
no? Yes, it is there. It is there. The thing is that these are unique words.
Okay, unique.
These are unique words.
Okay.
So if you just see its, I will show you its reviews. People generally write are essays or paragraphs as a review. Generally, it is not like Indian people, like we are just writing a review in one or two statement. They are literally writing the complete essays as an review, as a review. So that is why they are having lot many unique words. Okay, so I'm just going to limit that one here. Okay, so let me just download that one, and it is going to return that into two tuples. So let me just catch that two tuples. Let me call it as extend. We'll say that, sir, from where it has came. So you can just see over here what it is going to return. It is mentioned into its help. So even you can just see over here what it returns. It returns tuple of numpy arrays. So basically these two tuples it is going to return. So if you want, we can just copy them also. So if you want, you can just even copy them. Okay. So extend whiten access whiten. So let me just download that one. Obviously for this purpose, internet must be on. Let me see. अगर internet बंद करके ये करता है क्या? Let me show you. It is telling us that downloading data, and I hope you remember imdb.nps. So this is what the path. I hope that is the default path in load data.
Already it's shown that path.
Yeah, it has already shown that one. But let me tell you, it is not downloading because yes, many internet बंद कर दिया था. I think yesterday I told you that. Yesterday I told you that this internet is necessary if you want to download something over here. तो देख सकते हैं आप URL fetch failure. ठीक है. Now let me just on this internet. Let me make it on. Now if I just run this, देखो internet is enabled. Let me run this. Yeah, it is downloaded. It is getting downloaded. That's completely fine. It is getting down. I think it has finished downloading. So, कुछ तो warning है. I'm not going to look into this warning. No need to waste our time. So our data is available into train for training purpose and test into testing purpose. Let me tell you xtrain. Let me show you what is xtrain is. So how we can check the type of this object. Let me check the type of this object. So it is going to be numpy array. It is going to be numpy array. So let me just see the first object of this xtrain. Let me see the first object of xtrain. That is the first object of xtrain. Now can you tell me what is this object is? Your total collection है, इसका type क्या है? This is what the first object, or let me tell you that this is what your first review is. आप बोलोगे numbers कैसे यहाँ पे? I will tell you, don't worry. But what is this object? जो भी मैंने highlight किया, what is type of this object?
List, sir.
Yeah, perfect. This is list, because you can just see we have mentioned this object using square brackets. So it is just list of numbers. It is going to be list of numbers. Now I will tell you why I have used this IMDb from TensorFlow. So that thing you'll understand now. Now here, if I just show you, these are the numbers. I'm going sir, text data kahan pe? It should be like your text review, right? But here we have already that data available as a numbers. So let me tell you, these are the unique number associated with the words. So this is associated with word 1. This is associated with word 40, whatever it is. It could be like the, good. It could be any words, from, nice. It could be any words. So every word got unique number. Every word got unique number. So you can just see any numbers over here. You can just see all the numbers over here. If you just see all the numbers over here, this is what 1385th word. This is 4468th word. You can just see over here, we do have 4536th word, or maximum value ka aap hai. This you can see 19,193rd word. Likewise, you can just see the value. देखो कितने सारे words, lot many words are there. How many words in this first review? Many words are there. Now, if I ask you one question, that what could be the maximum possible value for these words? To represent these words, we are representing these words using numbers. So पहला word है उसको 1 number मिला, दूसरे को दूसरा, तीसरे को तीसरा. Likewise, what is the maximum possible value for your word? And these words are
number
unique.
of words that we have taken into consideration when you have equated as number 20,000.
Yeah, perfect. That is 20,000. That is 20. Maximum possible value for these words is going to be 20,000. Now, this concept to convert your text data into these unique numbers is called as tokenization. This is called as tokenization. If you want to do this by ourselves, we can do, no problem. ये हम खुद से भी कर सकते हैं. उसका एक 2-4 लाइन का स्क्रिप्ट होता है टोकनाइजेशन, that we can do. But what it exactly does is that, let's say हमारे पास काफी सारे रिव्यूज है, review 0, review 1, review 2, everything like that. From all these reviews, it is going to find out unique words. And it is going to arrange the words as per their frequency. सबसे ज्यादा highest frequency वाला word होगा पहले. Second highest frequency वाला word यहाँ पे. So let me just call it as W13 यहाँ पे. It is going to be W20. Here, third highest frequency वाला word is going to be कोई भी word हो. Let's say W80. Let's say it could be anything. So as per that, we are going to arrange. So for this, like the most frequent word, जो सबसे ज्यादा आया reviews में. So the more frequent word, we are going to give the number 1. So ये जो 1 number है ना, ये 1 पहला word, that is the most frequent word. Then after that, second frequent word को हम number देंगे 2, इसको देंगे 3. And the last or the least frequent word, that is going to be get the number as 20,000 in our case, because हमारा last word, हमारे पास total 20,000 words. तो जो last word है उसके लिए number होगा 20,000. So this is going to be the least frequent word, and that is why in general, if you just see the reviews, आपको ये बड़े बड़े वैल्यूज बहुत कम देखेंगे, because these are very frequent words. लेकिन 1, 2, 3, 4 ये काफी frequent देखेंगे. आप देख सकते हो 1 है यहाँ पे, 16, 14, यहाँ पे 4 दिख रहा है, 5 दिख रहा है. These are very frequent values.
Sir, excuse me, sir.
Yeah.
Sir, how you are deciding the frequency of words? As per their digit value or what, sir?
No. How many times it is appearing into your original reviews? So for example, good.
Sir, excuse me, sir. In that case, the last value may not be 20,000 because each of the word may be repeated for some time. So the last value may be lesser than that.
No. These are unique. 20,000 is the number of unique words. Try to understand. It is not length of total text.
Okay.
It is not total text.
These are unique
words.
I understood, sir. Sir. These are unique words, but these are appearing for for many times. No, it means one unique word may appear for 2 or 3 times.
Yeah. This is only first review. Whatever you are going to see, this is first review. This one is going to be come there in many reviews. This is just the first review.
Okay.
Okay, sir. Okay.
In this column, in this list, all the values are unique here.
It is not like that. For example, this is first review. The word, for example, this is one of the word that might repeat many times in this one review. So for example, for the, we do have number one. So one may repeat many times in the same review, we can say, no problem.
Yeah. Okay.
Just consider one thing. All reviews we do have, whatever number of reviews, let's say, all reviews, let's say we do have 25,000 total reviews, let's say. IMDb reviews, total number of reviews 25,000. From this 25,000 reviews, we are going to find out unique words. How many unique words they have used? Unique words. Unique words, obviously, it is distinct words or non-repeating words. So these are distinct words. So this count is 20,000 in our case. So obviously, 20,000 unique words are represented using 20,000 unique digits. And that digits are from 1 se lekar 20,000. This one number is going to get for the most frequent word in all reviews. So sare reviews mein, 25,000 total reviews hai. In all these reviews, the word, this is one of the word that is coming for example, 5,000 times, let's say. So iska frequency 5,000 times it is coming in the whole data set. Good. It is coming for, let's say, 4,990 times. So it is second frequent word. So D ko milega 1 number, good ko milega 2 number. This is how we have given the numbers 1 to 20,000.
Yes, I understood, sir.
Yeah. So this is what the first review, and this is just been represented using the words. So these are words we can say. These are words we can say. So extent of 0. Extent of 0. Now let me see how many such words are there. How many such reviews are there. So what I will do, I will just see what is extent.shape. So you can just see 25,000 reviews are there. So whatever the data set we are using, in this data set we do have 25,000 reviews. In this data set we do have 25,000 reviews. Now one single review I showed you. Okay. Now then after that, let me tell you, or let me show you the length of very first review. Extend length of very first review. So what this length is going to define? This length is going to define number of words in first review. Number of words in first review. Let me show you. In first review, it is 218 words are there. So I hope you know that essay writing may define hota hai ki maximum 400 words, maximum 200 words. This is almost same like your essay. So 218 words, both bada review. Likewise, let me see for the next review. Let me just write down those things directly over here. पहले 3-4 रिव्यू का मैं लेंथ यहाँ पे देखता हूँ. So length of next review, length of next review. Then after that, length of next review. So पहले 4 रिव्यू का लेंथ यहाँ पे दिखेगा आपको. पहला जो रिव्यू है उसका लेंथ है 218 वर्ड्स. सेकंड रिव्यू में 189 वर्ड्स आर देयर. नेक्स्ट रिव्यू में 141 वर्ड्स आर देयर. नेक्स्ट रिव्यू में वी डू हैव 550 वर्ड्स आर देयर. ये तो देखो, इट इज मोर देन एसे. ये जो फोर्थ रिव्यू है दैट इज मोर देन एसे. सो दैट इज क्वाइट ह्यूज. That is quite huge. Now the problem is that whenever we are going to pass these words or reviews for the training purpose in LSTM. So basically LSTM is going to work on. So this is what LSTM is. Now this is going to be first word at time t0. This is what the word at time t1. This is what the word at time t2. Likewise, this is like a word at time t, and let's say n number of steps we do have. Yesterday we consider number of time steps. Can anybody tell me number of time steps we considered yesterday? For stock price prediction? 60. Yesterday we considered 60 time steps to predict the tomorrow stock price. Here, to predict the sentiment, we are going to consider how many words in sequence that must be fixed. That is what the problem now here. That means the length of each and every review must be same. That is what the problem. And if it is going to be same, then we can pass those words with respect to time. So kitne time steps hai uske hisab se. Here I am going to consider that as a 200. Abhi dekho, sufficient number of words must be there. Sufficient number of words must be there. So that is why 200 words I am going to consider. And that is of fixed length review I am going to consider. Now here we do have some situations where number of words are greater than the fixed size. Here number of words are less than fixed size. Yes? Yes, any doubt? 141 words, that is less than 200. So there is the problem. What we have to do, we have to make the length of all the reviews as same length. Sabka mujhe same length karna, for example 200. Now if I just make its size 200, what is going to happen? First review, so R0, that is originally 218 length. Review 1, that is originally of like 189 length. R2, that is of originally 141 length. R4, R3, let's say, this is of 550 length, huge. Now what I want to do, I want to make all of them of same length, all of them as the same length. So same length is 200. So if I just keep that length, so what is going to happen? In the first review, remaining 18 words we have to ignore. Remaining 18 words. In this case, in this second case, like 189, we have to increase number of words by 11. हमें यहाँ पे dummy words देने पड़ेंगे. In this case, sorry. In this third case, 141 words we do have. So remaining 59 words we have to give us by ourselves. In the third review, if you are considering 200 words, then remaining these many words will be meaningless. So you can just decide how much fixed size or fixed length of a review you have to consider. Now, ये जो problem इसमें कोई दिक्कत नहीं. We are not going to consider the letter words. Problem is that if you have 189 words and if you want 200, what about that 11 words? So let me tell you, for that purpose, we do have one reserved number, that is 0. This 0 number is not given to any word. Try to understand, मैंने बोला था कि पहला जो word होता है topmost frequency वाला, उसको 1 number दिया गया है, second को 2. So 0 is like a reserved number that is used to pad over here. So 0, 0, कितने 11 zeros यहाँ पे मैं pad करूँगा. Here I am going to pad 59 zeros. So यहाँ पे we need padding, and here we need to like delete remaining words. Obviously there is loss of information. Here we are making loss of information in R3 and in R0. We are losing information because we are not going to consider some words. Obviously कुछ ना कुछ तो हमें करना ही पड़ेगा adjustment. So this concept we have to apply so that every review is going to have a same length. So how we can do this? To do this, we are going to use the concept of pad sequences. To do this, we are going to consider the sequence of consider the concept of pad sequences. So let me just import pad sequences inbuilt functions. So from TensorFlow dot keras dot sequence. Let me just write down sequence. It is into let me see, preprocessing में है क्या? Yeah, sequence import. We have to import pad sequences function. Yes, perfect. I'm going to use this pad sequences function to convert your fixed length data. So that is into your extend. तो extend में जो सारे reviews है, उसका maximum length, max length. Generally, sometimes I just like forget where is that function is there or what is the format of that function. Sometimes I forget. Let it be. So max length I'm going to keep it as 200. and after doing pad sequences, agar extra words hai, तो it is going to remove later words. If the number of words are less, it is going to pad with zeros. So let's see. Let me call it as xtrain. So capital Xtrain I'm going to call it as. Same thing I'm going to do with. Same thing I'm going to do with xtest. Xtest. I'm going to call it as capital xtest. Capital xtest. Let me do this. Yeah. Now if I just show you this length, so same thing I'm going to do. सिर्फ एक change मैंने किया कि ये जो x है वो capital किया. So let me just make it as capital. Capital Xtrain of third, capital Xtrain of 2, capital Xtrain of 1, and capital Xtrain of 0. So let's see their length. So obviously what we are expecting for everything we expect the 200 length. We expect the 200 length. देखो. So everything is going to be of length 200. Everything is going to be of length 200. Now that's fine. So abhi to theek hai, matlab your data is ready directly. Your data is ready because tokenization already we have done, because we are going to import data from TensorFlow. Pad sequences we have done over here. Now after that, this data is ready. Now this data directly we are going to give to the embedding layer. Embedding layer means jaise jahan pe we are going to find out the vectors for with respect to each and every word. So let me use that embedding layer over here. Let me use that embedding layer over here.
Excuse me, sir.
Yeah.
Sir, in this there is a loss of data. So what is the use of it actually? Because ultimately we will get the model will be not correct one, huh? I think.
Yeah. Perfect. Whatever you are saying, that is right. So in that case, what we can keep max length, that is going to be the maximum. Let's say, for example, I'm going to keep it as 500.
Okay, maximum
So
we have to. Okay.
No. It could be more than 500 as well. So whatever it is possible, we can keep, no problem. Why I'm choosing 200 over here is that because in our case, it is going to take lot much time. So we don't have that much time to train, because jitna length zyada hoga, number of words, like this is going to be the vector. So that much time it will take to train the model. So that is why I'm just reducing the size. Otherwise, if you are working on like very huge project, we should not lose the data. We should not lose the data. So you are right. It must be like larger one, but in our case, I'm going to keep it as smaller because we don't have that much time to train the model. We cannot wait for 2 hours or 4 hours or 5 hours likewise.
Okay.
Excuse me, sir.
Yeah.
So we are deleting data, for maintaining our 200 size. So and here also we are adding some data to maintain 200.
Yeah.
So if we are deleting, can we add in this to maintain? Suppose somewhere we add 11, somewhere we add 29, somewhere we add 49.
No.
Yeah.
No. That we cannot do because original review may get changed.
But we are losing, so that loss we can fulfill here by adding that deleted data here, because we are adding 0. Yeah. Okay.
Yeah. Let me give you example. For example, we do have one review. So let me just have review like the food. For example, food ka review hai. The food was good, but service was not. How many words we do have? 1, 2, 3, 4, 5, 6, 7, 8. Review 1 we do have. Review 1 we do have like इसका जो लेंथ है ये मैं करता हूँ 6. तो the food and service 1, 2, 3, 4
not
was good, let's say. अब देखो यहाँ पे इसमें कितने वर्ड्स है? 1, 2, 3, 4, 5, 6. ऊपर वाले में 8 वर्ड्स है, नीचे वाले में 7 है. एंड लेट मी जस्ट कीप दैट साइज एट 7. सॉरी, इसमें 8 है, 6 है ना नीचे वाले में, इसमें 6 है. तो लेट मी फिक्स दैट साइज एज 7, लेट्स से. So in that case, what you are saying, so first of all, if you are keeping 7 size, so you are saying that keep first 7 words of first review, and जो remaining है that you can use in the remaining one.
Yes, yes.
Okay. So this 6, तो ये जो नॉट है ऊपर एक्स्ट्रा हो रहा है, that we are going to use over here. So if you are doing so, can I say that इस review का meaning ही change हुआ उस केस में?
Yes, sir. Yes, sir. Right, sir. Right, sir.
So we should not adjust that, it like this.
Okay, sir. Okay. Thank you so much. Got it.
Yeah. So now what I'm going to do is I'm going to import the layers that we are going to use. So from TensorFlow dot keras dot models, let me import sequential model, and from TensorFlow dot keras dot layers, let me import LSTM लगेगा हमें, LSTM. Also, can you tell me some other thing that we may need over here? और कौन सा layer लगेगा? Can you tell me? Because yesterday भी ऐसे ही हुआ था कि हमें और एक layer लग रहा था वहाँ पे. कौन सा layer है?
Sir, dropout.
Dropout. Yes, basically dropout we use. To reduce the overfitting. Okay. Okay, कोई दिक्कत नहीं. Then final layer must be what? Final layer in AN. So initial part is of like LSTMs in CNN, initial part is of convolutional layers, pooling layers, but the last layer must be of ANN, artificial neural network, and where we need to have the neurons to predict the final output. So there we need dense layer to create the neurons layer. Simple neuron, huh? Simple neuron. It is not, LSTM is not useful at the end. तो ये कुछ थोड़ा सा मैं import करता हूँ, and yeah, so let me create the model now. So model is equal to sequential, and in this model we are going to add the layers. So model dot, one more thing we need over here, we need to add embedding layer also, because हमें word embedding भी चाहिए. So need to add embedding layer also over here. The model dot add, first of all we are going to convert these words into word vectors. We have to convert that into word vectors. So how we are going to do that? To do that, I'm going to use embedding layer. Yeah. So in this embedding layer, what we have to mention? We have to mention how many unique words we are going to provide this embedding layer. Number of unique words. I hope you understood. That is 20,000 we have used. Now, then after that, we are going to convert each and every word in the vector of length. So basically whatever I have explained over here. So every word is going to be of one vector. So यहाँ पे ये vector v0, v1. तो ये जो vector है यहाँ पे मैंने बोला था कि it is of length 128. So every vector is going to have 128 values. So such kind of number we have to mention over here. Generally, if we want to store much more meaningful information, that number must be larger. बहुत ज़्यादा भी नहीं होना चाहिए, बहुत कम भी नहीं होना चाहिए. Let me put it as 128. So it is the length of output vector. Whenever we are going to convert any word into vector, so what is the length of that vector that we are mentioning over here? That's it. And then after that, obviously for the first layer we have to give the shape. The first layer we have to give the shape. Input shape. So whenever we are going to design the model, पहले आपको input shape देना ही पड़ता है, because how your model is going to understand what is shape of your input. So that we have to provide. Here in this case, the input is going to be single review at a time. I hope you remember yesterday, the review is going to be like single, like timestamp is there. So for example, previous 60 days ka data, that was the input shape. For embedding, the input shape is going to be length of input review. So what is that? Length of input review, that is 200. Only that thing we have to mention over here. Length of input review, that's it. Length of input review, that's it. Then after that, yeah, same like that, we are going to add model dot add, we are going to add LSTM layers. LSTM we have to put LSTM units. Let me put LSTM units as 50. Baki ke cheeze, let me just put return sequences. Return sequences. Return sequences. Let me put it as 2 because मुझे और एक LSTM layer चाहिए, let's say. लेकिन इसके बाद में मैं पहले ऐड करूंगा model dot add dropout to reduce the overfitting. To reduce the overfitting, let me just drop out 20% of the weights every time. Model dot add, let me just have LSTM and again 50 units are there. Return sequences by default false होता है, तो यहाँ पे नहीं mention किया तभी भी चलेगा. दो ही LSTM layer में use करता हूँ because कल आपने देखा होगा काफी ज्यादा time ले रहा था वो. And then after that, let me add the final layer. So model dot add final layer is going to be of simple neurons dense. मुझे बताओ in this final layer how many neurons are required? Basically, let me ask you one thing. Whatever the problem we are discussing right, it is not working. Yeah. Whatever the problem we are discussing, that is sentiment analysis, it is a regression problem or classification problem.
Classification.
It is going to be classification. So आपने देखा होगा, अभी मैंने आपको y नहीं दिखाया, so that is my fault. मैंने y नहीं दिखाया, लेकिन you can just see y over here. If I just show you y over here, so that is what y train is. So you can just see this is just ones and zeros. This is just ones and zeros. These are labels. So basically, how many classes we do have over here? Only 2 classes, either 0 or 1. Yeah. Now, if it is so, can you tell me how many neurons we must use over here? It is binary classification. So how many number of neurons must be here?
2.
Number of neurons to predict either 0 or 1.
2.
10,000. No. Yesterday we are used only 1 to predict the tomorrow's stock price. अभी हमें सिर्फ ये प्रेडिक्ट करना है कि 0 है कि 1 है. सिर्फ 2 ऑप्शंस. 2.
Sir, 1.
Yes, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. Power cut here, so इसलिए disconnect हुआ. ठीक है. So यहाँ पे सिर्फ 2 options है, either 0 or 1 we have to predict. So how many neurons are required to predict either 0 or 1?
1.
Only 1 neuron is required. So for binary classification, if your classification is binary, number of output neurons we can use is 1. If your multi-class classification, multi-class classification, for example, n number of classes are there. So can you tell me how many number of neurons are required at the output layer? अगर आपके पास n number of classes है, let's say 4 classes are there. How many neurons are required at the output layer?
1, no? So again 1.
No. In that case, for each and every class, we need separate neuron. For each and every class, we need separate neurons. So if you are doing multi-class classification, so we need the number of neurons that is equivalent to number of classes. सिर्फ बाइनरी क्लास में क्लासिफिकेशन में आप 1 यूज कर सकते हैं. इवन बाइनरी में आपको चाहिए तो यू कैन यूज इंस्टेड ऑफ 1 you can use 2, no problem. Instead of that 1 we can use 2 as well, but not really necessary. It is not really necessary because 1 neuron is sufficient. But for multi-class classification, जितने classes है, that much neurons you need to use. ठीक है, let it be. Now if you are using only 1 neuron, can you tell me what should be the activation function here?
Softmax.
Okay. Any other option?
ReLU will be
ReLU is going to give us value not as a classification. 0 and 1, सिर्फ 0 and 1 ऐसे value नहीं देगा ReLU.
a binary will also be okay. Binary.
Yeah. What is activation for function for binary? For example, I hope you know about logistic regression. So logistic regression is based for binary classification. So what was the like activation function in logistic regression? Sigmoid. So for binary classification, sigmoid is there. For n class classification or multi-class classification, softmax is there. Okay. So softmax is there. So try to understand those things. So here we are going to do binary classification using one neuron. So here we must use sigmoid activation. Binary we can do using two neurons as well. So in that case, we need to use activation as softmax. So that depends. अगर यहाँ पे आपने 2 use किया, 2 के लिए भी काम करेगा, but in that case you need to use softmax over here. That's it. I think ये बन गया आपका मॉडल. ठीक है. Because it is going to be the last layer. Try to understand. It is the last layer. Now let me just set the parameters for the model. So for the whole model, I must say the model dot compile. So here we are going to keep like the options like optimizer. So which optimizer we need? My favorite one in general, developers favorite one is Adam optimizer. And for loss function, can anybody tell me what should be the loss function over here? Because it is binary classification with one neuron. What should be the loss function then? Let me tell you, it is binary cross entropy. So this cross entropy we use to find out the loss in binary class. If multi-class classification है, तो the loss function is categorical cross entropy. Binary classification, if we just see mathematically, it is just going to look like this. It is minus y actual log of y predict minus 1 minus y actual log of 1 minus y predicted. So this is what the loss function, same loss function we use in logistic as well. It is very meaningful loss function. So this is called as binary cross entropy straight away, same like logistic regression. Okay, so let me just see the metric. Because it is classification, so we can use accuracy as a metric. And even we do have validation accuracy, validation data. So let me compile, and after that let me fit the model now. So model dot fit, and fit करने के लिए we do have x train, capital वाला x use कर रहा हूँ मैं. Y को तो हमने कुछ preprocess किया ही नहीं, y train. Then after that validation data, let me just have validation accuracy as well. That is x test comma y test. Then after that number of epochs. Okay, let me keep at 5 epochs initially first. Then after that let me have batch size. Let me keep batch size equal to 32, let's say. देखते हैं अभी कैसे होगा, because ये भी हो सकता है कि because of such options it may go overfit. And let's see what is going to happen. So let me just start the epochs. Okay, so per epoch it is going to take around 40 seconds. So total it is going to take around 200 seconds. That is sufficient time. It is also using GPU. GPU इसलिए ये इतना fast है, otherwise ये slow होता काफी. Accuracy देख सकते हैं आप, ये training accuracy है 74%. ये बहुत important है. So here I'm also going to use the validation accuracy. तो यहाँ पे आपको ये accuracy दिख रहा है, एंड वैलिडेशन एक्यूरेसी एट द एंड ऑफ इपॉक दिखेगा वैलिडेशन एक्यूरेसी. तो ये अभी तक आया नहीं बिकॉज इट इज गोइंग टू बी देयर एट द एंड ऑफ इपॉक. देखो वैलिडेशन एक्यूरेसी. So validation accuracy means whatever the test data we do have, वहाँ पे accuracy देखो 87% है. That accuracy is 87%. Training का accuracy कम है, that is 77%. Training accuracy is less, but test accuracy is greater. So that's fine, no worries. होता है कभी कभी. Second epoch is going on. Let me share the notebook by that time with you people, so that you can just use this later on. You can use that notebook directly. अभी देखो वैलिडेशन एक्यूरेसी, हाँ ट्रेनिंग एक्यूरेसी बढ़ गया, वैलिडेशन एक्यूरेसी थोड़ा सा कम है. दैट्स फाइन, नो वरीज. दिस इज ट्रेनिंग एक्यूरेसी एंड दिस इज व्हाट टेस्टिंग एक्यूरेसी. तो पहले 87 था, अभी 85 बना. ठीक है, कोई दिक्कत नहीं, देखते अभी क्या होगा. You can observe that training accuracy is increasing every time. It is increasing 95, fourth epoch it is 97. वैलिडेशन एक्यूरेसी आई थिंक अभी चेंज नहीं हो रहा है जितना ज्यादा, मतलब थोड़ा कम हुआ लेकिन ऑलमोस्ट इट इज अराउंड 85%. देखो ट्रेनिंग एक्यूरेसी इज इंक्रीज्ड, वैलिडेशन एक्यूरेसी इज सेम, मतलब ऑलमोस्ट 85% ही है. ऑलमोस्ट सब जगह पे 85, अराउंड 85%. देयर इज नो मच इंक्रीज इन वैलिडेशन एक्यूरेसी एंड दैट्स फाइन. मतलब वैसे तो जैसे epochs बढ़ेंगे वैसे वैलिडेशन एक्यूरेसी मस्ट इंक्रीज. सो देयर इज सम प्रॉब्लम विद द मॉडल. लेट मी टेल यू, इट इज प्रॉब्लम विद ओवरफिटिंग एज वेल. बिकॉज अगर आपका ट्रेनिंग एक्यूरेसी बढ़ रहा है लेकिन वैलिडेशन एक्यूरेसी नॉट इंक्रीजिंग, देयर माइट बी द प्रॉब्लम फॉर फिटिंग. देयर आर मेनी कॉन्सेप्ट टू अवॉइड ओवरफिटिंग. प्रोसेसिंग के रिलेटेड भी इश्यूज है, मॉडल बिल्डिंग के टाइम पे भी इश्यूज है, हाइपर पैरामीट्रिक ट्यूनिंग के भी इश्यूज है. Let it be, but this is what your sentiment analysis is, and the sentiment analysis accuracy we got, the validation accuracy we got is 85%. The accuracy of this model is going to be 85%. Accuracy of this model is going to be 85%. So this is what sentiment analysis is. This is what sentiment analysis is. Now in this, if you have any doubt, you can ask, and you can just start coding by yourself. डायरेक्टली रन किया तभी भी चलेगा. ऐसे कुछ नहीं कि इसमें बहुत ज्यादा कॉन्सेप्ट्स है. कॉन्सेप्ट बहुत ज्यादा है, इम्प्लीमेंटेशन के लिए कोई ज्यादा चीजें नहीं है यहाँ पे. मींस नंबर ऑफ लाइंस ऑफ कोड इज लेस. लेकिन इन जनरल इफ यू हैव एनी डाउट्स विद रिस्पेक्ट टू NLP or sentiment analysis or yesterday's problem, you can ask. Just try it at your side also. अगर कुछ दिक्कत आते तो you can ask me directly. Start implementing it at your end. यहाँ से start करना.
Done. Okay, anyone has started training of model? Okay, so I'll consider that you don't have any doubts over here because I just like nobody has asked anything regarding the implementation or regarding the doubts while implementation. So I will consider it as you have done with this coding, or you don't have any doubt. So that I will consider, and let me conclude this session because we have done with the implementation, and also we have solved your doubts. Okay, so done from my side. In further, if you are going to have any problems with respect to your implementation or any doubts, so you can just reach out to me. You'll get my details from the coordinator, sir, and you can reach out to me as well later on as well. Okay.
Okay, sir. Thank
So
you, sir.
for any kind of help. Yeah. Thank you.
Thank you so much, sir. Thank you.
Thank you.
Great. Thank you very much for I think such an exhaustive session wherein you have explored almost everything. Okay, and I'll share your detail definitely with the participants. They will be in touch with you and they will trouble you.
Yeah. Yeah.
Thank you, sir. Thank you.
Yeah, that's fine.
Thank you.
Yeah,
Thank you so much.
yeah. Thank you, sir. Thank you very much.
There are people still in the